There is.
I had no idea what you're talking about.
No evidence,
and I'm done then because you haven't heard it yet.
There is no evidence to what you just supported.
It's a very good hypothesis, Dodo. Dodo, that's a really great hypothesis. You got to back it up.
Please, because as you go to north and south, then there's lesser distance between ground and sky level, hence the inclement weather, right? So therefore, the ether will be more pressing. So as you get to the Dead Sea, then go lower again, there'd be less of a force on it.
There is no physical or piece of science that supports what you're saying, whereas there is a load of
that's an answer offered
that
for you.
supports what I said about the changing weight. If you've got a spinning, rotating globe at the radius we've got, we would expect to see 0.3% less weight if you're on the equator than you are at the pole, and that's exactly what we see.
Right. So tell me this then, Rumpus. When that kilogram weight, I'm sorry for anyone else trying to get in, but it's a very interesting question. Rumpus here is one of the best the opponents I'd have to offer. Well, Rumpus, if you take that kilogram weight from the North Pole, the very north center, right? Very north center, and you take it all the way to the equator, you're taking it from a relatively stationary position, right, to a position that's traveling. I know you're going to say it's 1 revolution per day, but it still works out as 600 meters per second, or something like 1,024 miles. Now, isn't that after picking up a certain amount of momentum, first of all, and that on a Wayne scale, shouldn't that press more? Shouldn't you get greater weight at the equator, according to that thinking?
No, because it's like being spun out. I mean, have you been on one of those rides where they spin it round and you're forced to the outside of the wall? You know, I can't remember what they call it now. It's the wall of death or something like a wall of death.
The gravitron.
Okay, and you spin round. So you're sitting in this circuit in a cylinder, and they start to spin it up, and then you're forced to the outside, and that means that there's a force going outwards, the centrifugal force, and that subtracts from your weight. So if you had some scales, if I were to somehow have some scales on you, there'll be or put a force meter, it would show there's a force pushing you to the outside. So the same thing happens on this. Hold on, nearly there. The same thing happens on the surface of the Earth in the equator. You're being spun out by a force, and that subtracts from the force of gravity. So when you put some scales underneath you, your actual weight registered by the scales is equal to your weight being pulled into the center of the Earth minus the sort of centrifugal force, and that's your net weight, and that's 0.3% change from when you're at the poles.
What about the angular momentum that you picked up? Because if the Earth was suddenly to stop, you were going to shoot off in a straight line at a massive...
That's not angular momentum.
Rate, right?
Yeah, you would do that indeed. If the Earth was suddenly to stop, you would then suddenly have 1,000 miles an hour at the equator in the direction east to west, and you would then shoot off at 1,000 miles. If I could just hold the
west to east.
Stop it, you go bang, and you would shoot off at 1,000 miles an hour. Yeah.
What's the amount of angular momentum contained within the body? So should the Earth stop and a massive brick wall is waiting at some point?
That's not angular momentum, Pete.
Well, hold on.
How is it not angular momentum?
Sorry, are you asking about the angular momentum you would have, or the angular momentum the Earth has? Because obviously, if you stop the Earth,
you have. Once the Earth is stopped, did you have? How would you calculate that, Rumpus?
Well, it's just v squared over r times m. Sorry, that's right.
Yeah, but I think Pete is confusing both of them because the momentum.
It's MV
omega r. It's just mv. It's your velocity, so it would be 1,000 times your mass would be your momentum, or you can think of it as omega r. But at the equator, it's 1,000 miles an hour. So, but we talk about things in meters per second. You said, I think correctly, it's either 600 meters per second. I think at the equator.
It's mv times r, Rumpus, not divided.
No. That's the angular momentum. You asked. Okay, if you want the angular momentum, then it's v times r times m. But if you want your linear momentum.
So what is
I think he's confusing both of them because when you're talking about the Earth, stop, Pete. You have to.
No, he's asking about the angular momentum of the person. Now, so I didn't quite understand. So you want the angular momentum of a person at the equator, right? That's
so you're
absolutely correct. It's mv times r. So it's your mass.
Just give us the
let's suppose you're 100 kilograms. Your velocity, I think you said correctly. I think it's about 600 meters per second times r, which is 6,371. If you multiply those three numbers together, that's the angular momentum that you have got around the center of the Earth.
You have to convert the radius into meters as well.
I did. I just did. Okay, times 1,000. Okay, yeah. So 6,371 kilometers times 1,000 times your mass in kilograms, which is about 100, times your velocity, which is 600 meters. So if you multiply all those numbers together, that is your angular momentum around the center of the Earth.
Can you do that, please?
But the angular momentum it doesn't care on where you are on the surface of the Earth.
Hang on. Here's my point.
Your linear one does.
Hang on. Rumpus is going to work out. Just give us the bottom line on that, if you don't mind. Just type it into the computer or calculator, if you don't mind. Okay. While I say that, remember, we're after traveling, or I can say it now, we're after traveling from the very north center, where we have zero angular momentum, and we're after traveling all the way down to the equator, where now we're suddenly in possession of all of this potential. So when you get the number, Rumpus, you might tell me. And isn't it amazing? Our body doesn't feel a thing.
It doesn't. Yeah, right, because remember, you only feel forces, and you only feel forces when there's acceleration. And if you're going along in a straight line, if you were going along in a train at 1,000,000 miles an hour, you will be able to do everything you normally do as a stationary thing. That's why when you get in a train to go, say, or an aeroplane that's doing 500 miles an hour, you feel no different. You can pour tea, coffee, play golf, do whatever you like, run up and down an aeroplane, and it feels no different to what you have to do if you're on the Earth's surface. So it's only an acceleration, and the acceleration is because the Earth is so big. So the radius is so large, the acceleration, as I said, is only 0.3%. Due to centrifugal force, because the Earth is effectively very flat, it doesn't change angle very much. Because the radius is so large, your change in direction as being on the surface of the Earth is so slight, and because the Earth is rotating so slowly, you can't feel it. But it can be measured by, as I say, measuring the weight of something. That manifests itself, but you can't detect that. That's no different from you having a drink of water and saying, so in other words, if you had a drink of water at the North Pole, you would feel exactly like you do. Sorry, if you had a drink of water at the equator and then didn't have that drink of water at the North Pole, you'd have exactly the same effect on you. And of course, you can't detect the difference. You can't detect
Did you give us a final figure? Did you give us a final number for the angular momentum contained within the 100 kilogram man?
Yeah, so it's 100 kilograms. So it's 100 kilograms times. I better go and check that velocity figure you gave to me. It sounds about right. 600.
Yeah, put down 500. Put down 500 meters.
Okay, I'll put down 500. I'll tell you what. I'll go and look it
up.
The
ballpark figure, Rumpus.
Let me go and get the. Let me go. I'll actually go and do. I'll go and look it up.
100 times 500 times 3,000. Let's say. You said 5,000. Let's say 5,000 kilometers, which is 5.
As soon as you stop the Earth, there's no longer gravity, which was the center of their rotation. So that angular momentum you're calculating is useless for that situation.
Well, anything to do with a spinning ball Earth is fantasy, and it's merely
that's a claim. Let's stick to the argument.
You see, the problem is that what you're saying is demonstrably false. You weigh less at the equator than you do at the poles. You say you should weigh more. This is demonstrably false. Your whole theory is wrong.
Well, I didn't say you should weigh more. I said my thoughts are that you should weigh more.
Well, your thoughts are incorrect.
Just on the velocity you're traveling, right?
You actually weigh less because of that. It's called the Utvus effect, and it's well known.
So the velocity is sort of lifting you off the ground somewhat, alleviating your weight as you go to the equator.
It's one of the demonstrations, one of the proofs, if you will, to use the word and scientifically. It's one of the proofs that the Earth is actually rotating.
Really?
Yep.
Do you want the answer?
No other possible alternative hypothesis? No other possible.
Of course it doesn't. He just wanted to waste your time.
Let me know of an alternate hypothesis to explain this difference, please.
Ether. Direction of ether flow.
But you said the ether would cause you to weigh more. Are you going to change your...
No, I said ether would cause you to weigh less. I was correct in my thinking. Did you not listen?
You said the ether would cause you to weigh more.
I was surprised. I actually...
Ether will cause whatever.
I said...
Ether will cause whatever they need,
whenever they need. Let me clarify then. To myself, I expected the ball that at the equator you'd weigh more. For myself, you weigh less at the equator due to the ether, and more at the poles. So that made sense. But when I found out that you weigh less, that surprised me. That surprised me.
Yeah, so the ether causes the effect opposite to what you thought the ether caused, right?
I think it's fair enough, though. When Rumpus gives his final figure here,
I put the answer. I can read it out. I've put the answer in the chat, whatever it's live stream text. The answer is, I'll read it out in verbally. And that
let me see what that is.
293 billion 66 million kilogram meters squared per second. I've put the units and I've put the number in there.
That's something else, isn't it? That's something else.
Well, it's got that value of r on it, and the r of the radius of the Earth is 6,371,000 meters. So whenever you multiply that by anything, that gives you a big number. But remember, what you feel is the acceleration. What you feel is a force. Remember, the only things you can feel is a force. You can't feel if you're going 1,000,000 miles an hour in a train or an airplane or a spaceship. You would not feel any different. You could not detect. There is no scientific experiment you can do if you put a windowless spacecraft and you're traveling 1,000,000 miles an hour. There is no experiment that you can do that would find out that you're doing 1,000,000 miles an hour. The laws of physics work at 1,000,000 miles an hour exactly the same way they do at 0 miles an hour. So there's no way of detecting them that you're doing 1,000,000 miles an hour. It's only forces you can detect. So you have to be changing direction. Now, if that spaceship started to go turn left or turn right, then you would damn well feel it if it was doing 1,000,000 miles an hour, particularly if it was more than a few degrees.
And you can only feel the force if they're not applying to you, to every particle of you at the same time. Otherwise, every particle will accelerate.
You present these scenarios as if anyone can go out and do it. Like these are merely thought experiments. You claim that this or that would happen on a spaceship or something going 1,000,000 miles an hour.
We're just giving you the implications of modern physics.
You've been in an aeroplane, and we know that if there was to have an effect to be going at 1,000,000 miles an hour, there'd be a small effect of going at 500 miles an hour. There is no effect at all. We know that this works.
So hang on, let me get this straight. Here's another point, Rumpus, and I never got to do this yet, actually, and maybe I'll still get around to doing it. But if you have an airplane, right, which is, let's say it's like 100 meters long, just for the sake of argument, and it can fly as a normal plane does. Are you telling me as you're going from the front to the back of the airplane or the back to the front of the airplane, it will require exactly the same effort as it's going?
Yes, Peter. And we had this discussion about 3 years ago in which I went into this in great detail with you, and you can check this. So, for instance, if you were to roll a golf ball, let's suppose you were to throw a ball in an aeroplane. You were in the middle of the aeroplane, you threw it forward with the same force, or you threw it back with the same force, it would go exactly as far. So, or using a golf club, let's suppose you hit it with the same force with the golf club on the aisle, with a particular force, and you were able to reproduce that same force going the other way, it would go just exactly the same distance up the aeroplane as it would down the aeroplane. No difference at all. The laws of physics require this. There is no part of science that would say otherwise. Every piece of science we've ever done says what would happen as I described it.
And yet, here's the thing, right?
And yet he disagrees.
And yet, I have experienced exactly this on a train myself. Hang on, Rumpus, please.
I'm just going to ignore it. Whatever you say is your personal experience.
Many others have claimed to have experienced the same thing. That as you're going from one end of the train to the other,
made a mistake if you believe that to be the case.
Hang on, please.
Pete, we've done scientific experiments because you're saying you've got a personal experience. I'm afraid we've done scientific tests on this for hundreds of years, and no one has ever detected the effect that you're trying to describe.
It's very easy to fool yourself in experiments like that.
Though,
so your experience is not that relevant.
Can anyone here
I could claim otherwise.
Okay, can anyone here on the panel testify to the same thing? Forget about Ball Earth or whatever, but if you're on a train and you're going from the front of the train to the back of the train, as opposed to going to the back of the train to the front of the train, one way is noticeably easier. Less effort is required than the other way.
How do you check that?
Yeah,
no, I'm just asking for personal testimony here. Has anyone experienced that? And I'll let you say what way you think is easier or harder, because I can easily say it because it's in my memory.
It's just psychological. You're probably looking out the window or something, and therefore you think you're going forward rather than backwards. But if you were in a closed cabin, there's no experiment that you can do that would detect you're doing
fucking fly down. You fly from the front to the back of the train. It's like you're almost not weightless, but you're sort of lesser attracted to the floor.
Wait.
If the effect was true, you could conduct a simple experiment like I mentioned with the golf ball or something similar to that.
Go on a train.
I've been on a train and you don't have the effect. I've walked up and down airplanes traveling at 500 miles an hour. There is no effect that you're talking about. You are making it up.
If there was an effect like that, if you try to stand up
on an airplane, the aisleway is too short and too narrow, and you've only a short distance to go. That's why you extended in your mind the airplane to 100 meters. But on a train, you can surely do that.
There is no one has ever detected that effect ever.
So I've heard more guys.
If you do that when the train, Pete, if you do that when the train is accelerating, of course you're gonna feel that. And if the train is braking, you're gonna feel the opposite.
What are you telling me?
But if sorry,
train at constant speed over a level surface.
Yeah, in a constant speed that doesn't change.
It only makes sense that it was easier to go away from the direction the train was going.
Doesn't make any sense.
What do you mean it only makes sense? It only makes sense to you because that's what you believe. But there's no demonstration of that, which is what we're asking for.
Hang on, why? So anyone else testify to having a similar experience? That's all I asked, isn't it? If you either have or you haven't.
No one piped up, Pete, because no one.
So
let's multiply the relevance of your anecdote, which is 0, by the amount of people who experience the same.
Now,
it's going to equal 0.
Well, forget about that. Here's a suggestion for Veritasium, Rumpus. Why don't you write into that?
Because if I wrote to him to conduct this experiment, he'd say, "You're an idiot." And I would say, "Yes, I'm an idiot, but I was talking to an idiot who asked me to write this." Because there's no experiment ever been done by anybody ever in the history of science that has exposed the effect you're talking about.
But if you as a living being...
No one, Pete. Not a single person.
I think we're just wasting our time.
In the front and the back, you will notice a perceptible...
No, you won't, Pete.
This is going to go forever.
If it was noticeable, Pete, we could measure this, and no one has ever measured such an effect.
If it was noticeable, you could notice it or experience it.
It's not noticeable,
Not
Pete.
everything that exists can be measured, Rumpus.
Yes, and that's why we don't measure that, and that's why we know it doesn't exist.
Well... No one is willing to stand up and...
No, you're just making it up, Pete. It's a psychological
That must
thing.
be me. That's fair enough. I must be fucking on drugs.
Well, we've already decided, I'm afraid, you're not quite with it in the head on a number of occasions, I'm afraid.
We have. Is that okay? Well, that's okay.
That's not allowed, Rumpus. Just
big
warning right there, okay?
He's had problems in the past.
Yeah, no, but it's not allowed in this server, okay? Please, Rumpus.
I'm not saying you're saying I'm saying something that's totally outlandish and ridiculous.
Correct.
But I'm saying I'm not the only one to say these things.
No, you're not.
Probably heard Lemonbird talking about it before.
Oh well, Lemonbird's
hold on. I was away for a bit, but yeah, I have something to say on this. Absolutely. So when I've been on a bus, a train, anything like that, if you run from you have to kind of, it's good if you have like an open bus, so you don't have people that you're gonna, punch in the head as you run by them. But if you can do it, if you run, like let's say it's going 60 miles an hour down the highway. If you go to the front of the bus and you run to the back, absolutely, it almost feels like you're weightless, and you'll slam into the back of the bus. Yes, and if you go from the back of the bus and you run forward, there's absolute noticeable resistance without any question.
Well, I'm afraid you just made that up.
Let me just say to Rumpus, you're on the server of Geo, who's the man who spoke up and said exactly what I said.
Hold on, you guys are talking at the same time.
We have never measured such an effect. No piece of science has ever measured the effect you're talking about. If you've been experiencing it, it's just psychological.
I'm not really interested in what you think someone has done, but it is interesting what the truth of it is. I think one way to measure it, which would be cool, which I don't know that it's ever been done, but I've thought about this. You could have a little like apparatus where, let's say you have a little metal ball that is dropped, sort of like some of these gravimeters work, but a little metal ball that would drop, and then you'd have to have it be sensitive enough to where once you drop it, you'd be able to see whether, basically does it go straight center or does it go a little bit back? Because once you drop it,
you wouldn't be able to pour a cup of tea if what you said was true. On an aeroplane doing 500 miles an hour, you can pour a cup of tea from the pot or whatever into your glass, and there's no effect of it being accelerated one way or the other. Same on a train.
Absolutely not. No, I don't agree with that. Yeah, absolutely not at all. Yeah. No, you of course you'd still be able to pour tea. I mean, everything has to be propelled through the ether, through the environment, always. So nothing just moves on its own. Rumpus, please don't interrupt. Just let me speak. You can speak, but I don't want to be clipped and hacked on while I'm trying to say something.
Go ahead.
All right. So if everything has to be moved and propelled. So if you're on a train or an airplane or whatever that's going, let's say a bus that's going 60 miles an hour, you're being pushed along with that. So the only reason you're going 60 miles an hour is because you're sitting in the chair or you're standing on the bus, which is going 60. So yes, of course, you're already going a certain speed with the bus. So you're already traversing with the bus. If you jump out of the bus, we know what happens. You're going to fly backwards. So in the same way, if you jump up in the bus, then when you jump up, Now you're just a human who has been propelled at 60 miles an hour and there's no air resistance. So of course you're going to fall right back down. If there's air resistance, you're going to fly back. If you could jump up high enough in a bus that's large enough, yes, you'll start to drift back because you're no longer being propelled through the ether at that speed any longer.
So what you're saying is if I jump up and down in a train or an aeroplane doing 500 miles an hour, I'm not going to land at the spot I jump from.
You will, because it's so minor, because you're already going 60 miles an hour and there's no air resistance. So of course you're not just going to fly back just by jumping. But is there a measure? Yes, I think to measure it, you'd have to have a.
You're fighting a force, and if what you said was true, you wouldn't be able to jump up and down an aeroplane or on a train and land at the same spot you jumped up from.
No, I would not say that's the case because you're already going 60 and there's no air resistance.
Exactly.
So just jumping up a foot in the air is not going to make any significant difference in that.
Correct, and that's why the effect you're describing is wrong.
Well, when I say significant, I mean it's not major enough that you jump up, you're going to fly to the back of the bus. But what I've talked about is being able to measure it. I can sense it with my human senses without absolutely any question. But and I think another interesting way I've thought about to do this is if you've got like a group of like 50 people, maybe you get an airplane that has no seats in it, so it's totally open, and you're on an airplane going 500 miles an hour or a bus or any of these things, and then blindfold them and do a double blind study and have them sprint from the back to the front and see if they, statistically can notice it as well.
Well, there is no experiment that's ever been done that's observed the effect. It's a fundamental part of science about the conservation of momentum and the fact you cannot detect the fact that you are traveling at 1 million miles an hour, 2 million miles an hour, or stationary in terms of the effects you're talking about. You would be able to run up and down a bus or a spaceship that was doing 1 million miles an hour, and you would not be able to detect the difference. It's a fundamental part of science that you cannot detect the difference in just a constant velocity environment from another constant velocity.
Well, I think that's a pseudoscientific concept that's been created because of all this relativity and all this stuff, and I think it's just fundamentally false. But I know that your entire system rests on it, so I understand that, but it will be shredded and debunked in time.
If the effect existed you're talking about, it would have a small amount when you started, say, running in a bus or a car, and then it would get bigger if you're in an airplane doing 500 miles an hour, given the fact you're now doing 100 times the speed. Therefore, whatever effect you're talking about would be 100 times more noticeable in an airplane than it would be in a car. And the fact that there is no difference at all, you can run up and down an airplane and do whatever you like in an airplane, pour tea, etc. There are none of the effects you're talking about, and if they did exist, they'd be 100 times bigger in an airplane than they would be in a train, and there is no change in the effect.
Rumpus, you just said to me how you wouldn't suggest that to Veritasium because it was you equivalently said it's a deranged idea coming from a deranged mind.
Correct.
But Geo just chimed in and exactly mirrored what the words that I said to you, my own experiences.
Well, I'm
afraid you're going one direction, it feels like you're almost floating. Anti-gravity in the other direction is much more difficult.
I'm afraid this is the agenda of people who don't understand anything about science. If you knew anything about science, I mean, Galileo spotted this and called it the theory of relativity, where you couldn't, in a ship, he couldn't detect whether the ship was moving or not when he was eating or something, and that you can pour things. If the effect existed that you're talking about, then, as I said, it would be 100 times bigger on an aeroplane than it would be in a train. You wouldn't be able to pour if you're fighting a force, which is what Sir Gio was implying, and you're implying that you're fighting against the force, then that force would be 100 times bigger on an aeroplane. And there is no scientific experiment that's ever detected this. And it's a
why would it be? Why would it be that much different? I mean, if you're going at 60 miles an hour, and meaning like you're in the bus, so you've already been brought up to speed, so your body is traversing through the ether at 60 miles an hour. Fair enough. Now, if you're on an airplane going 500 miles an hour and the airplane has already gotten your body up to 500 miles an hour, why would it be necessarily that much different?
Because there is no effect you're talking about. But if the effect existed that you are talking about, then it'd be 100 times more noticeable on an airplane because you're going 100 times as fast.
I don't agree.
Because there is no effect, that's why. That's a test saying you don't see any effect at all, and that's because fundamental part of science is that with theory of relativity as outlined by Galileo exists, and that we cannot detect any difference between one velocity of another.
Okay, so if we do a little device that has a metal ball that drops a ball, and we do measure it, what does Rumpus say then?
Just that'd be fine. Yeah, but you could do the same thing as pouring a cup of tea. The test you're describing is exactly the same as pouring a cup of tea in an aeroplane. If the effect it went one way and preferred to the other, it would not go into your cup directly downwards.
Okay, what I'm talking about is a device that would have some type of a ball that would drop. So in terms of pouring tea, it's not like you would pour the tea and it flies to the back. We're talking about a slight measurable difference.
So there'd be a slight measurable direction in the direction of your tea as it came out of the teapot and went towards.
Yes, and there is. Yeah, there is.
No, there
yes,
isn't.
There is.
No, there is not. Your tea comes out of a teapot on an aeroplane and goes down in exactly the same way as it does in your house.
All right. Well, I think we've exhausted. I think we both shared our minds. Does anyone else have any thoughts on this topic, or should we move to the next one?
What is that? I'm sorry, I just got in. So if you guys want to change, you can. But
no, go ahead.
Isn't that the conservation of momentum law that he's talking about, where you pour tea on an airplane?
It's fundamental. There are so many things that rely on what I described to be true. All great words of physics rely on what I said to be true.
Hang on, Rumpus. So conservation of momentum, right? As you're traveling, running with the train is traveling at a certain velocity in a certain direction. You are traveling in a certain velocity in the same direction as the train. You can calculate the momentum here. But if you reverse your direction then and go against the motion of the train, isn't there going to be a change according to the mathematics? There should be a change.
No, because you're adding or subtracting from the train, and that's the same difference as if the train was stationary. It's the same both ways. So for instance, if you wanted to get up to 10 miles an hour running, you would have to use exactly the same force to go 10 miles an hour up and down your living room or you're outside your house as you would in a train. The fact that the train is moving doesn't change that. The difference is plus 10 miles an hour or minus 10 miles an hour, whichever you pick on your coordinate system. And the same is true in the train. It's plus 10 miles an hour at the train or minus 10 miles an hour. The difference between plus and minus 10 is exactly the same whether you're on the ground or the ground is moving in a spaceship doing 1 million miles an hour. Makes no difference.
Well, now what if you're going at multiple different vectors, though? Because I can understand why you would say we don't feel the spin of the... let me just finish what I'm saying before you cut me off. So I can understand the law of conservation of momentum, say on a train going in one direction. But we're not just spinning on this Earth, allegedly. We're also spinning around the sun, which is also spinning around the center of a galaxy. How come we don't feel any of that?
Because it's so slight. I mean, there is a difference that you can measure. We talked about this earlier in the...
Define slight.
0.3% is the difference between being at the equator, where you are affected by the rotation and the acceleration due to the Earth, and being at the pole where you're not. The difference is 0.3%. Not something that you can feel, but it's something you can measure.
So I can feel myself going 30 miles an hour in a straight line in a car, but I can't feel myself hurtling through the galaxy, like corkscrewing around the center of the galaxy.
You cannot feel yourself. If you go in a perfect straight line in a car...
I can't.
No, you can't. No, you
I
just
can't
feel the bumps.
Well, that's another problem, and I'm sorry to interrupt you, but that's the problem, is we're not going in a straight line. Can you name me one type of planetary orbit that is not going in an ellipsis?
Right, but it's so close to a straight line in any...
No. It doesn't matter, because in an ellipsis...
It's so big.
In an ellipsis...
The radius...
In an ellipsis, you have to slow down and increase speed. It's not a perfect circle. It's an elliptical orbit.
Third law, yeah.
How much speed over how much time?
That's Kepler's third law, Rumpus.
How much speed over how much time?
The point is that the things you describe, like the rotation of the Earth, the change in angle over a period of, say, an hour is 15 degrees. Over an hour, you're changing an angle by 15 degrees. And in space, when we're going around the sun, it's over a period of an hour, you're going a fraction of you're going 1/24th of 1 degree. So the change in your angle, the change in direction due to an Earth, I mean, it's slower. I mean, you could be on a rotating roundabout, a one with or a spinning thing you see in a park. Those things are going around. The effects of the rotation, the angle you're changing per second, is about 10 times as big.
So no matter how fast or what direction we're traveling in, we should not expect to feel it. Just the same as if we're not moving at all, actually, isn't it?
0.3% is the amount that it changes, being at the equator, where you're going around spinning, and at the North Pole, you're not spinning at all, in effect.
That's a possibility.
But the difference, because it's only going around once every day, once in 24 hours, that's so slow that you just don't feel it. But we're still big enough to measure 0.3% difference in your weight. But I say that's like picking up a glass of water. You cannot feel the difference using your senses.
So you're saying we could go as fast as we want, as long as we don't change speed or vector, and we won't feel it. But then you're also saying we can be going thousands of miles an hour through the galaxy, and we will change vector, and we also don't feel it. You understand that doesn't make sense, right?
If you don't change your direction, you're not subject to an acceleration. You've got constant velocity. You could be going 10 million miles an hour. And
you know what an ellipse is, Rumpus?
What's the change, Dodo, and how much? Over what time?
Do you know what an ellipse is, Rumpus?
I do know what an ellipse is.
Right. So what do you call the two ends where there is a sharper curve or contour?
Well, you've got the major minor axis of an ellipse. I don't know. There's nothing.
Right.
Are you talking about the epigee and the perigee or something?
No, I'm just talking about the two ends. I was hoping you could tell me what they were called.
Well, there's we're talking about elliptical orbits. We talk about
you can see how you can,
perigees, if that's what you mean.
Yeah, no, what I'm talking about is you can see how the curve is much more severe at these points, and this is where Kepler's third law.
What is Dodo? How elliptical is the Earth's orbit?
How elliptical?
How elliptical?
How elliptical? The major axis is, I don't know, 93 million
if I were to draw it on a diagram, you would not be able to tell the difference between that and a circle. If I were to draw a full screen, you would not be able to detect the difference between the Earth's elliptical orbit, elliptical and a circle.
So in other words, unfalsifiable model, right, Rumpus?
Well, no, we can measure.
It can be measured. You just can't.
Wait. Visually, you can't see it, but we can measure this. But you have to have an instrument to do it. And the fact that the sun changes in size, depending on parts of our orbit, we can detect it. But it changes by whatever it is, 1% or something, the size of the sun, seasonally, because of our orbit. Similarly, the moon changes by 15% because it's got a more elliptical orbit.
So what is this? Are you saying it's only a very, very slight ellipse? It's more a circle.
Didn't you understand? That's what I said. I said you couldn't see the difference if I drew it on screen and compared it against a circle. And I said, here's a circle, and here's an ellipse of the Earth, the same radius. You would not be able to tell the difference between them on screen.
So we have, let's say, a diameter, we'll just make it a circle. A diameter is twice the sun's distance, right? So let's just, am I correct there? Say 200 million miles.
Diameter, yes, the radius to the sun is 93 million odd miles.
So that's the diameter, and that would be of a complete circle. Of an ellipse, of the ellipse you're talking about, what is the variation between the major and the minor axis? Let's take that as the major axis. What would the minor axis be then?
Well,
you're saying it's close to 200 million.
You want a big number, basically, Dodo. You want a big number.
No. If he said 100 million, for instance, that is.
Terry's put the diagram in the text. He's showing. Terry's put the diagram convenient. Thank you very much, Terry. One is 147 million kilometers, and the other one is 152 million kilometers.
Well,
those are the two values, the major and the minor axis.
Is that a difference in millions of kilometers? I'm sorry, I didn't know.
I'm very.
Subtract one from the other. There's a difference of 5 million kilometers from
an hour.
No, between July and January. Jesus Christ!
No, hang on. That diagram doesn't show the.
I know it's got it opposite. It should be at 90 degrees to one another. The diagram is a bit. Yes, the diagram's flawed, but it's got the numbers in there, and the difference is 5 million kilometers between the major and the minor axis.
Rumpus, you have that wrong.
That is correct. Sorry, that is correct. That diagram. Yes.
No, you have it wrong. That's not what it's indicating here. The elliptical path. That's indicating a different season, opposing seasons.
5 million kilometers difference between them.
Hang on, Rumpus. Let me tell you what that diagram represents. This is opposing seasons and direct and and distance from the sun. So in other words, in one season it is 5 million kilometers more than the other. That's not telling us what the elliptical axes are, Rumpus. Come on,
man. Yes, the difference between the perigee and the apogee.
So what we need to know, that's what we need to know. And if you're saying that's around equal to the two values here, then it's as close to a circle as we can. But I'm predicting it's going to be a lot less, which will make it a more pronounced ellipse, right?
No, it's not.
Well, let's see what get the figure then, Rumpus. Get the figure, please. If you don't mind.
The eccentricity of the Earth's orbit is a tiny number. I happen to know that. Yeah.
Okay, I'd love to see the figure. Come on.
This does reflect.
Yeah.
Because
Harry, get it right,
the difference between the apogee and the perigee is also linked in with the formula for an ellipse. So it does although so from that you can determine the if you run draw an ellipse, it's got two foci, and there the center one between those two. This is one end of the focus at one end, and then the other end at distance is the other focus, and that's related to the eccentricity between the major and the minor axis. So although I can't immediately off the top of my head tell you what the minor axis is going to be, the fact that those things are within 5 million kilometers, i.e. What's that? 1/3%. That means it's only 1/3% difference, which also is reflected in the difference between the major and the minor axis. So it's a very similar number.
Okay.
The eccentricity is related to the difference in position of the two foci, so that you can think of one. They move. The eccentricity squared. I can't remember. It's the ratio between the maximum and the major and the semi-axis, major and the minor axis is related closely to that distance there between the two foci, which is and that's one foci at one point side and one foci at the other one. So it's very close to being a circle. You would not be able to tell it if I were to put it on the screen.
Okay, fair enough. Now, you're going to have to excuse me. I'm not the brightest bulb in the lamp here. But could you maybe tell us how much faster and how much slower we're going? And how much faster would we have to go for us to actually feel it? Does science have any answers for that?
The sun, or do you mean the rotation of the Earth?
Either.
You're breaking up now.
Whichever's easier. Whichever is easiest.
Well, let's
I think the easy answer to that is we don't feel motion. We only feel acceleration.
Yeah, and he's asking how fast does the Earth have to spin before you would noticeably.
I thought I figured it. I figured this out once. It's like,
how much effect do you want to have on your weight? Do you regard as something you could detect? Because you can't detect 0.3%. Do you think you could detect a 10% change in your weight?
That's what I'm asking you.
You have to tell me what difference in your weight you think you would detect, and then I can tell you how much.
I have no clue. I have no idea how.
Well,
I've never felt any. I've gone outside and stood. I've like meditated before, and I didn't feel anything.
Give me a criteria of what you've asked me, what you would feel a difference, and I therefore need to know what you would require to feel different.
You're asking me to describe something that no one has ever.
No,
felt.
I'm not. I'm asking you. You set the criteria of what you've asked me. Hold on, let me. Right, you've asked me how much would it have to make a difference for you to feel different. But to answer that question, I have to know what you think you would need to be different for you to detect.
Probably the speed.
Oh my God. How much difference in your weight would you require? Would you regard as significant? Oh my God!
I need to weigh more.
Right? How much? What percentage? How many kilograms? Tell me how many kilograms you want to weigh more for me to be able to tell you what the numbers are. It's really simple.
Why are you so mad, bro?
Because he's such a bloody idiot. He's asking me
a
a
question.
I saw you he basically said, tell me how much it's going to make it be significant. But I can't tell that because he's asking me what he would regard as significant, and I don't know what he regards as significant. Would you regard as twice your weight or half your weight on your scale? Would you regard half your weight as being significant?
All right.
Bro, why are you so mad? Why are you so mad?
Because he's so thick, and I can't get through to him, and I'm asking him a simple question he won't answer.
No, it's not simple for me. I'm a little confused. You're asking me.
I'll ask you again. I'll ask you this really simple question again. Would halving your weight on your scales, would that be regarded by you as the sort of thing you're looking for?
No.
Oh my God. Well, what are you looking for? What difference in your weight do you wish me to work out for you? You're breaking up now. Oh, Jesus.
Looking for.
You're breaking up. We haven't been able to hear you for the last 10 seconds.
How much?
No, you're breaking up. We can't hear you.
Fast.
We can't hear you.
Yeah, you're roboting, bro. Hey, Rumpus, I got a question for you, man.
There's a kilometer per second difference between the apogee and perigee.
Hey, Rumpus, do you agree that the Earth could, in fact, be geocentric?
No.
So do you think that all the top-level astrophysicists on your side that say it could be, I guess they're wrong?
I don't believe there are any astrophysicists that we're geocentric.
So if I provide quotes from them, you would concede you're wrong?
Who said that, Witsit?
I'm just going to provide numerous quotes.
Well, just one would do. From an established astrophysicist, then yes.
There's Bernard Cohen. You heard of him?
Can you hear me?
Yeah, right. Indeed, right. He's saying there is no planetary observation by which on Earth we can prove the Earth isn't moving. Indeed, and he's absolutely correct. Visually, you can't detect. There's nothing visually you can do. But he's not saying you can't work it out. He's just saying you can't do it visually. So you didn't understand what he said, did you?
No, what he said was that there's no planetary observation by which you can substantiate the Earth is not geocentric.
Yes, so he's saying there's no visual observation that we can do, and he's absolutely correct. There is no use, but by looking up in the sky, the Earth could be spinning, or the space around us could be spinning. And Einstein said exactly the same thing. There is no visual observation that you can make that would distinguish between those two things. But fortunately, there are many other ways of us determining that we are spinning. For instance, I've moved it on to spinning. I don't know whether that was something you were right, which is moving in orbit, right, which is the same thing. Or you're talking about just geocentrism. So I have slightly changed this so that you can tell me off if you want to in a minute. We can demonstrate, for instance, that the Earth is spinning rather than the space is spinning around us. I don't know. Now, if you want to talk about just geocentrism, which is the orbiting part, which is actually what you did ask me, there are other ways that we can detect the. For instance, there's various Doppler effects. That can show that we are moving around the sun rather than the other way around. Because if you assume that things like the cosmic microwave background radiation is a fixed entity, we can see that we are moving with respect to that, and there are various other ways of showing also that we are. But he's talking about visually, so that just means he's basically saying for you. That's what he means by an observation. He means
when you say Doppler shifts, you're actually talking about red shifts. But so here's actually a quote. Here's a quote about it. It is shown that the cosmological interpretation of the redshift and the spectra of quasars leads to yet another paradoxical result, namely that the Earth is the center of the universe. The Earth is indeed the center of the universe. The arrangement of quasars on certain spherical shells is only with respect to the Earth. These shells would disappear if viewed from another galaxy or quasar.
Incorrect.
Yeah. And that's
incorrect. He says incorrect. I'm not done.
That's why. Hold on.
This means that the cosmological.
Let's let each other finish. We're gonna let each other finish. Or I'm gonna start muting
the quote
people.
For Christ's sake.
Yeah, I know, and he's gonna finish reading the quote.
For fuck's sake, why do you get to read quotes?
Well, because we can talk about the quote. So this means that the cosmological principle.
And I can answer that first. Can I?
This means that the cosmological principle will have to go. Also, it implies that a coordinate system fixed to the Earth will be a preferred frame of reference in the universe. Consequently, both the special and general theory of relativity must be abandoned for cosmological purposes. Very famous astrophysicist Y.P. Varshney.
Yeah, that's from 1970. Okay, oh sorry, it's the whole thing. That's 1976. So this is before we had all the stuff with the cosmic microwave background radiation. That's why, if you listen to what I said, I talked specifically about with reference to the cosmic microwave background radiation. This quote you've got here is about the redshift of quasars, and indeed that's correct. With the redshift of quasars, they could either be moving, but I didn't say that. If you listen to what I said, I talked about the cosmic microwave background radiation.
Right. So have you heard of the axis of evil?
Yes.
Explain to me how that proves the Earth's in a heliocentric solar system, please.
I didn't say the axis of evil proves the...
well, that's a resultant of the background radiation test you just invoked.
Because the axis of evil exists in the cosmic microwave background radiation, I'm not saying I'm relying on that. I'm talking about the Doppler shift. The Doppler shift of the cosmic microwave background radiation has got nothing to do with the axis of evil.
Well, and then how did they get the axis of evil? They didn't use Doppler shift?
No, the axis of evil is just a distribution of matter in the a distribution of the particular temperature profile in the cosmic microwave background radiation. That's another aspect of it. There are several things about the cosmic microwave background radiation, one of which is the axis of evil, but there's the Doppler shift as well. There are several parts of information. It doesn't just give you one piece of information. There's lots of ways of using the cosmic microwave background radiation to determine information. One of them is the distribution. One is that particular shape, which they call the axis of evil.
Are you saying they don't use the Doppler to determine the distribution?
Yes, the distribution is just what you see. It's just a straightforward measurement. Then the Doppler thing is something you can say, oh, look, this is, we can see there's a Doppler effect as well.
within the distribution that's evenly distributed relative to the Earth being the center.
Well, yeah, but you can see that. You can see how when it's spinning round that the Doppler shift is layered on top of the background radiation. So we can see, for instance, so when they use the something like the Planck instrument to look at the cosmic microwave background radiation, they get a picture. We can call it a picture, but it's actually a temperature distribution. We'll call it a picture because you can generate a picture from it. And then if they do the same thing a day later, when the Earth or something, or a different season, or when the Earth's in a different part of the orbit, it will be shifted in one thing slightly differently. A blue shift or red. It's blue shifted as well, depending on which way you're looking, and you'll get this seasonal effect that can only be accounted for by our and it exactly matches our seasonal rotation around the sun, and we can see the Doppler changes with regard to that, which would not happen if we were the center of the universe.
Oh, so the change in Doppler proves that the Earth is spinning around the sun.
Correct.
All right, feel free to go a little bit more in depth here. Enlighten me.
Right, I thought I've explained this already. Let's try this again then. The cosmic microwave background radiation effectively is a fixed reference frame in the universe. As we go towards one part of it, because remember we're going 64,000 miles an hour around the sun. And
66,600.
Yeah, it doesn't. Yeah, that's 60-odd thousand. Yeah. So, our rotation around the sun will mean that there'll be a seasonal change. If we're looking at a particular spot, let's suppose imagine we're looking at a particular spot. As we're going towards it, we'll get a blue shift, and then 6 months later, we'll be going away from that same spot, and so we'll be able to see this color change in the effectively it's the color you see is the temperature. Be redshifted or blue shifted, we will see this seasonal change in the cosmic bits of the cosmic microwave background radiation, exactly alike with our rotation orbit around the sun.
So wait, are you saying that redshifts are Doppler shifts?
Yes, of course they are.
Really?
Unless you're talking about gravitational redshifts, that happens as well. So, for instance, if you have something you park it next to a black hole, there will be something called a gravitational redshift as well. And indeed, even light emitted from the Earth is actually subjected to a gravitational redshift. It actually becomes redder as it leaves the Earth because it's leaving our gravitational well. But the effect of the Earth is quite small, but we can measure this. And if you had some light emerging from a sun, there'll be also a gravitational redshift. But we're not talking about that for the moment. We're talking about
motion. Wait, would you see a difference if the sun was moving?
If we're moving towards
if the sun was moving.
Well, no, our distance to the sun is relatively constant.
No, but if the sun was moving instead of us moving, would you see the shift? Yes or no?
No, you get exactly the same effect.
You get exactly the same effect regardless of the position of the sun.
Yes, we would. Yes, we can't. You can't visually, just by looking at the sun, as I said, you can't detect whether we're moving or it's moving around us.
No, we're talking about the shifts, not looking at the sun.
Well, there is no Doppler shift with the sun because our distance from it is the same. To get a Doppler shift, you have to be going towards it or away from it at some considerable speed, like 68,000 miles an hour. We're not moving them to and from the sun. We're going around the sun at that speed. Our distance to it is the same. So effectively the same. Therefore, we're not moving closer or further away. Therefore, there is no Doppler shift to the sun. Whereas
you just said based on our position relative to the sun, the Doppler shift changed.
Let's try it again. Our distance from the sun, from the minute if we ignore the very slight elliptical orbit, our distance from the sun is constant. If we're constantly the same distance from the sun, there is no Doppler effect. But towards the cosmic microwave background radiation, we move towards that and away from a particular point on it at 68, or you said it's 68, I thought it was 64,000 miles an hour. So there's a huge change, but there is no change in effect for all practical purposes for this discussion between us and the sun.
Well, then why'd you bring up the relative position to the sun?
I can't remember now where that came in.
Because you asked about it, Witsit.
No, that was my rebuttal. Try again.
Yeah, so you asked about it. Exactly right. So you asked
No, it was my rebuttal.
I didn't introduce
false rebuttal.
Sun, you did.
Okay, so anyway, well, this is being recorded,
let's
buddy.
Just throw it away. Let's just throw it away now.
You brought up the subject of the sun.
No.
Let's just throw it away now that you've been debunked.
Unless we talk about orbit.
No. He brought up the relative position to the sun. That's why my rebuttal had to do with the sun. Good try. Rumpus, does this require the assumption that redshifts are primarily velocity shifts?
Yes, they
How
are.
do you explain it otherwise? Explain it otherwise, Witsit.
Okay, time out. So do you agree that if they are not primarily velocity...
Explain it the other.
Why does this guy get to keep interrupt? I'll just mute you, dude, if you interrupt me again.
Witsit, please explain how it is not a velocity shift then.
Please explain how you're going to stop interrupting while I'm having a conversation
Please explain
with
to
someone.
me. Please explain to me how redshifts.
It would be a different in the density of mediums. There could be numerous different things. So anyway, Rumpus, so do you agree that if the red shifts are not primarily velocity shifts, then it would drastically change the way that you interpret the data?
But they are primarily.
But that's not what I asked you.
Yeah, well, you might as well be asking me if fairies are doing it. At the moment, all the science says that the red shifts and the blue shifts, which we also experience with the Doppler shifts in the cosmic microwave background radiation, are the result of our change in velocity. I mentioned to you earlier there are other red shifts, gravitational red shifts, but those are the only two shifts that I'm aware of off the top of my head, gravitational red shifts and motion red shifts.
Right,
And
so does this require the assumption of the medium and vast distances?
Well, there is no medium. The space is effectively empty.
Okay, so that is a medium. You still claim that there's a few hydrogen atoms per cubic meter.
Yeah,
so
we can ignore them. They don't have any effect.
No, you don't get to ignore them. It doesn't matter. So you have to assume the makeup of space and
No, we
then
don't
vast
assume it.
distances.
We know we've been there. We've been to space. We know exactly what it's made of, and also we can detect any effects of those atoms. If there was we can detect dense clouds of dust or something in space, which do exist in places, and obviously stars or whatever. We can detect them, but we can also see that there is in most space is almost completely empty, and the odd hydrogen atom kicking around in it, one hydrogen atom per cubic meter, does not cause any effect.
Okay, Rumpus. If it was a much more dense medium and the objects were actually significantly more local, would that change the readings? Yes or no?
Well, obviously, if it's denser, I mean, if there was not space between, say, us and the sun, and it was chock-a-block of atoms, of course it would affect. But we know the fact that there is no effect on these things, and we've been out there, sampled space, we know that it is almost entirely empty.
Well, without appealing to the authority of a few people that claim to go out there and then reifying what's in contention, you agree then that you actually require the assumption of the makeup of space and the distance to the objects, correct?
The effects that we observe match our experiences of going out there and taking samples of space, and all our observations agree on the same result. That is that the space is very basically empty. All of our observations point to that.
Okay, so the departure from a linear law of redshifts, the departure from uniform distribution, the curvature necessary to restore homogeneity, the excess material demanded by the curvature, each of these is merely the recession factor in another form. If the recession factor is dropped, if redshifts are not primarily velocity shifts, the picture is simple and plausible. There is no evidence of expansion and no restriction of the time scale, no trace of spatial curvature, and no limitation of spatial dimensions. Moreover, there is no problem of internebular material.
Well, if you say something doesn't exist, then obviously you've changed the whole of science. But all the science points to redshift matching a change in distance.
Well, no, it requires the assumption of vast distances and then the makeup of the medium.
We know, for instance, so we can match we know the redshift, for instance. I suppose that's an argument for the expansion of the universe. Well, we know the redshift matches the distance that things are away from us, so that gives us the expansion of the universe part. But whether or not you want to account for, we know that the only explanation we've got for the redshift is gravitational redshift. So when we see something, for instance, like we can see a local star, or we can see this vast spectroscopy. We can see that what is being radiated out. And then if we then look at a picture of a very distant star, we see that all the spectrum is shifted by a certain amount. And the only explanation we've got for that, besides gravitational redshifts, is a Doppler effect. So far, no one has proposed an alternative mechanism.
Well, here you go. I'll propose one. It's a more dense medium, and the objects are more local, and the movement is with.
We know that.
I'll let you just monologue, bud. So
well,
I guess that's where you got your name. I guess that's where you got your name.
We know the medium is not dense because it doesn't behave that way. There'll be other effects. There'll be other effects like you get the extinction and the attenuation of light would also be affected. You also get some gravitational effects you're talking about, and you get interaction between light and things. And this just does not happen. We've also can measure things by triangulation. For instance, even the closest stars. For up to about 100, actually, I think it's about, no, actually we've improved it up to about 1,000 light years now. We can measure with triangulation. So we can just use simple surveying type techniques to determine that there are some stars that are 1,000 light years away, and those are the close ones. So we know these things are a long, 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 long way away from most basic techniques.
So if you use triangulation, do you have to take another position out in outer space?
Yeah, use the
Okay,
seasons.
so then that's begging the question. That's begging the question. But
no. The only
yes,
thing
it is.
saying, no, it isn't. No, we know that the Earth moves around, and therefore in the seasons we know it's on different.
You just begged another question.
No, I didn't. So we know we can form a base between one season of the Earth and one side of the other. Then we can see, we can see that the stars wiggle. That can only be accounted for, and it matches the seasons around the sun. So we know that it's our movement of the Earth around the sun is causing these little seasonal variations in the position of nearby stars. So we know that that's the cause of the movement of those stars. And then from that, we can then say, right, how much does it wiggle? We also know the distance to the sun is 93 million miles via a variety of techniques, and also us having been there. So because we know that's 93 million miles to the sun, we then know the distance.
We've been to the sun? Dude, that's crazy.
We know that absolutely. And because we know the distance to the sun is 93 million miles from a variety of techniques, we then know what the diameter of the baseline of triangulation is. We can then, when we see a star that wiggles, and we know how much we've moved between January and July, we know that distance. We can then make a very, very simple calculation that even a sort of school child could do, 11-year-old could do, to work out how far these things are away. And that's the distant stars. The more distant ones don't wiggle at all, and then we have to use redshift techniques to determine how far they are.
Okay.
All your theories, quit acting like you know all your theories.
Yeah, first of all, Rumpus, try to keep it concise, man. You're monologuing a lot. And even an 11-year-old,
that's rich coming from you.
Even an 11-year-old would know
I've had to explain.
Wow. Even an 11-year-old would know that you just begged like 15 questions that are in contention. Okay, so are you familiar with the person that has the current attribution for how we understand distribution in space? Who came up with our current understanding of it? Do you know?
Who is muting me constantly? Stop it.
It's me and others, so please.
Right, well, so he's asking me questions I can't say. Who's you? Who spoke?
Rumpus, if you overtalk people and clip people, then you may be temporarily muted so we can keep the conversation, because otherwise you may talk over people nonstop. We can have a conversation, just like right now. I'm just speaking and you just started speaking over me. We can't have a conversation if you're doing that. So the temporary muting may occur, but we will give you a chance to speak. So if you don't do that, you won't be muted.
Yeah, why isn't Witsit muted for overtalking?
Are allowed to be mods?
We were having a reasonable conversation and we weren't over talking to any great degree, and then someone started muting me.
All right, man. So I'm just letting you know, dude. Hey, listen, man. It's very simple, okay? If you don't assume the medium and the distances, then there are numerous other plausible explanations for the phenomena of red and blue shift.
Right.
And if you cannot be honest about that, then you're disagreeing with the top astrophysicist on your side.
We know the distance to the sun. We know the medium between us and the sun is empty space. And from simple triangulation, we can work out the stars. There's no assumptions here at all. This is all based on absolutely rock-solid observation evidence. So we therefore can work out that even the nearby stars are an incredible distance away. We've been into the medium of space, so there's no assumptions whatsoever. No assumptions at all. This is all based on foundation of evidence and then building up and reasoning and more evidence and adding that. There is no, I know what, I'm going to guess this and then just build on it from there. There's none of that at all. And science is very self-critical. And if anybody could find some of these assumptions and they found them invalid, then they would have done so. There are hundreds of thousands of people who research in this who would get a Nobel Prize if they were able to show.
The stars disappear, man, at about 20 miles, bro. The stars disappear. You're saying we know.
They don't disappear.
If you triangulate Polaris from the ground, you come up with between 3,000 and 4,000 miles. You don't know.
No, you don't.
It's your theory, man.
You just made that up.
Who said that?
Wait, can I respond to Rumpus real fast?
Go ahead.
Rumpus, here's the deal, my man. Okay. Can you provide any empirical evidence?
You've broken up. I can't hear you anymore. Either I've gone quiet or
No, he cut out. That's unfortunate.
Okay, do you have any way we can verify?
Have you got any verifiable evidence?
Yeah, other than me just believing stories of people they claim they went there. Because you said that we went there. You've never gone there. I've never gone there. We haven't gone there. Is there any way I can verify this without just believing like 24 people in the history of mankind that claim they went past low Earth orbit?
That's
We've sent instruments. We sent probes out there. We have at every space agency in the world, which was 80 odd of them, have sent up rockets or whatever. They've all established that space is basically empty. They all verify, every single astronomical observation verifies the parallax effects that I was talking about that establishes the distance to stars. All the scientific evidence that anybody everywhere around the world knows of the distance to the sun. We've bounced radar.
So no evidence.
So you're just ignoring all the evidence we've got then?
Well, I just don't believe governmental agencies that tell me stories about going to space. I'm asking a pretty point blank question. Like, is there any other form of verification void of me believing stories of people that claim they went to space?
Right.
Yes
so if
or
you're
no?
going to reject all the scientific evidence that we've gathered, the body of human knowledge over the last few hundred years, and you want to reject every single piece of scientific evidence we've got, and the only evidence you're interested in is what you found in your bedroom, then we've got a problem. You don't have your own personal telescope. You have not done parallax observations, have you? So you're in a position of complete ignorance, and you reject all the evidence we've had over hundreds of years that establishes this as rock solid evidence. And the fact we bounce beams, so if some scientist comes along and bounces beams off the sun and finds the distance of the sun, you're just going to say, well, I haven't done it, therefore it's not true. Well, if you're going to reject all the evidence we have in the body of human knowledge, then you're left with your own knowledge and what happens in your bedroom, which is absolutely zero.
How you bouncing beams off a black body, Rumpus?
The surface of the sun is not a black body. If you look at the spectrum of the sun, it's not a black body, and there are certain frequencies that you can use to bounce off the sun. I know you listen to bloody QE's drivel, but the sun is not a black body, and certainly the part of the surface of the corona, which is what you can bounce off, is not a black body.
Rumpus. We gotta try to keep it concise, man. So your answer is this straw man about how I deny all science, when actually I'm invoking all actual science void of anecdotal stories from people that claim they went to space. So your answer that we're left with is shooting a beam to the sun. Is that correct?
No, there are many ways of establishing the distance to the sun. For instance, it was first established by doing a triangulation trick to do with Mars, establishing the distance to Mars and using Kepler's laws. So in something like 1681, we established the first decent distance to the sun of about 90 million miles an hour. That had nothing to do with radar beams.
How did you establish the distance to Mars?
You do it by triangulation, because if you take the angle to this Mars from one side of the Earth to the other at the same time, you can then use simple triangulation to go to Mars. You can't do the same thing with the sun because the sun's too far away, and that's how they determined it in 1681 using.
So they did triangulation from one side of the Earth to the other side.
Correct.
Okay, so can you have a straight angle on a sphere?
You can have an angle.
Can you have a straight one? Can you have a straight line?
Yes, you can have straight lines coming off a sphere.
You can have a straight line on a sphere.
The angle, all you're interested in to do the triangulation on Mars is to know that you're on a spherical body. You know the angle you measure to Mars, and from that you can calculate the distance to Mars. And what's more, we have been there. We sent a probe there, landed it on there, so we know exactly how far it is. And when subsequently to discovering how far it was in 1681, we've also bounced beams off that. We've also bounced radio beams off Venus as well as the sun. One of us has gone quiet again.
You're not going to have NASA spokesman. We.
That's
because Earth to the ball first.
You're going to need a straight line.
We have proof those things, Brian.
Okay, you don't have one on the sphere.
You don't need a straight line.
You don't need a straight line to triangulate?
We can be on a curve. Sorry, I'd say you can use a straight line of observation, but what you meaning, you think you're going to be on a flat surface. No, you don't. If you're on a spherical surface, I can make just the same observation of where Mars is, whether I'm on a flat surface or a spherical surface. I just have to account for the sphere.
Oh, so the theoretical line cuts through the Earth, directly through the middle if you're on the quote-unquote other side of the Earth, and then you account for the difference with the curvature.
Yeah.
Okay. That's
well. Do you not have a basic understanding of geometry, how to do it? Do you want me to draw you a diagram as to how you do that?
I want you to show me a diagram of a straight line on a sphere.
Here we go.
Yes.
Okay, here we go. I'll show you how you do it right now.
This is exciting.
My screen.
Well, if you just know the distance between 2 points on the Earth, and then you can just calculate the interior distance between them.
Right, so let me
Right, but it's much easier to deny everything. It takes no effort.
No, it's much easier to blindly believe every story you were told,
No.
reify them, beg the question, compile them together, and then pretend that that's science, that you're denying. It's much easier to do that, actually.
Yeah, no critical thinking, right?
Pretend
Just
like you've
believe,
seen any of that data.
repeat.
He's like, we got all this
Arrow.
data. He ain't got no data.
Well, then where's your data? Seriously, all you guys
Okay,
do
we
here is
shot- I got
deny
the
what
data.
Rumpus is saying.
I don't have
And
any
you're
data.
now
We're
you
waiting
don't
for y'all's
present
data.
anything.
We got plenty
Claim
of
that y'all
data.
have all this data. We have all this. We've done that.
You got
Yes.
nothing.
Yes, we do.
Right,
Okay.
so here we have, so here's the basic principle. I don't know if you can, hopefully can see my screen. So here we have a position on, let's just put a position on the Earth, an observer point here.
I am sharing it on the YouTube stream, just so you know, Rumpus.
Thank you. Right, so there we have one observer position. This is what they did in 1681. I think it was not Huygens. God, what was it? The Cassini. That was it. Cassini did this. Right. So here we have what they did. Is they had two observation points. One was in Paris, and the other one. This was the very first decent calculation to the sun. So they had 2 points. One in Guyana and the other in Paris. So basically halfway across the world. And they then said, right, okay, let's work out the angle from here to Mars, and then we'll work out what that angle is there to there, and then it's to Mars. And then by a simple piece of geometry, working out what these angles are, and I could go through it in detail if you like, use just simple geometry on this, knowing the radius of the Earth, you can then work out exactly how far this body is away, just simply by, it's not the classic, you just have to make it count for how far away. But it's a simple geometrical problem. I think about a 15-year-old could probably work this out, given enough time. And you can then work out the distance, knowing the angle there, knowing the radius of the Earth, and how far this is away. And once you've worked out the distance to Mars and used Kepler's laws, this is how they did it. They worked out the distance to Mars because it's relatively close. The distance to the Sun is much further away. Therefore, they couldn't. You need a certain angle. This angle here, A, which is related to the angles you will find here, B and C.
Hey, Rumpus, for angles B and C, don't you have to assume a flat plane?
No, you don't.
Really?
No.
Really?
Okay,
Really, you don't.
Zoom in as far as you can to like where the line meets the ground, and we'll see what the angle is. If it was actually true.
Right, so there we go. If I zoom in.
No, but in actuality, it would be parallel, wouldn't it?
Parallel to what? Here's the angle.
If it's a curve.
No, the angle. A curve is if you zoom into enough to a curve, you get a straight line. So, for instance, here we go. Look, here, for instance, here's a curve, right? But if I zoom into it enough, you then end up with some straight lines. If you zoom in sufficiently, and that's what effectively you're doing when you make an observation on the surface.
That's curved. That's not straight. That's curved.
Well, if I zoom in further...
Hold up, Rumpus. You have the tangent point, right?
If it be zooming further, it would become a straight line. I can't zoom in enough in this program. I can only zoom in 25 times. If I were to zoom in another 25 times, they would be perfectly straight. Go ahead.
No, curves aren't perfectly straight, Rumpus. That's
they
an
are
incident.
at a point. Do you not understand how...
Rumpus, let's think about this logically. You have a tangent point, right? The line is touching that tangent point, right? The next point is going to be like infinitely small, right? And then it's going to keep on increasing. It's going to exactly. So zoom into that, and at the tangent area, it's parallel. There is no angle. You understand?
You don't think there's a gradient on screen, then? You don't think
there's no angle there. That's
is.
perfectly parallel at the tangent point.
Hold on. Right, let's just go back a bit. Here is a circle, and I've drawn a tangent on that circle. Now, if I zoom in, I'll move away the tangent line. Right, there is the line. I've zoomed in now. This is the line of this circle I've zoomed into. Can you see that it has a gradient?
I appreciate you bringing this image because it perfectly explains my point.
Can you see that it's got a gradient?
Hold up, the purple line and the black line are parallel when you're zoomed in this much.
Instead of answering a different question, how about answering my question? Can you see
what's your
question?
question?
There? My question
What gradient?
Right, exactly. So you can't see a gradient of the curve on screen.
No, of course not.
You can't see this big black line that's got a gradient.
Yeah, it looks straight. I'm with you.
Exactly. So you can see a gradient. It has an angle, doesn't it? It has a gradient.
Exactly. So when you zoom in,
So
when you zoom in, you're using planar geometry, right? You're assuming it's flat.
Right, so there we go. So at that point, I can give you the exact gradient. So on this circle, I can give you the exact gradient of that line at that particular
Okay, let me ask you, what's the angle between the black line and the purple line at that point?
Well, this purple line is just an extension of this.
Yeah, what's the angle? So have them touching and tell me what the angle is.
I have created this purple line from this.
I understand, but what's the angle? Right there, what's the angle?
I have created. I'll say it again.
I understand. Yes, it's the tangent. It's the horizontal.
Else? It's the So I have created this purple line, this tangent, from this point here.
Absolutely. So now, what's the angle right there? What's the angle?
Well, this looks about what? You want the black line, the angle of this black line on screen.
The angle of the black line compared to the purple line. What is it?
They are exactly the same.
They're parallel, right?
From the other. Yes.
Now zoom out. Now zoom out.
I've created that from that.
I understand. Now zoom out and have a rougher viewpoint. See how as you zoom in and as you zoom out, that parallel line, the angle keeps on changing. It goes from parallel to whatever you want it to be.
Yes,
right?
That's what a tangent is only...
Exactly. So using a specific angle...
You don't understand what a tangent is, do you? Here we go.
No, I do. And you're the one that's having trouble...
Let me explain.
Rumpus, using any specific angle on a curved surface is incorrect.
The tangent is a point, is a gradient at a particular infinitesimally small point. So I've created this purple line from the gradient of the curve at this point.
Mm-hmm. And that angle, as you zoom in, continues to get smaller and smaller to 0 or to 180 degrees, whatever you want to say, right?
No,
so it's incorrect to say that the angles B and C in your other representation are whatever they are because it's just not accurate.
You can see the angle on screen. It's 45 degrees.
So basically, the angle depends on your zoom factor, how zoomed you are.
If I were to zoom in more, do you think angle would change? Do you think I would stop being 45 degrees if I zoomed in more?
Hey, let me jump in. Rumpus.
You think if I zoomed into this black line more, it's going to change its angle on screen?
No, the angle between the purple and the blue, between the horizontal and the curve, is going to change depending on your zoom.
No, it's not.
Yes, it is. Zoom out.
I've created this from the black line.
Zoom out and look at how the horizontal changes, that angle changes from the horizontal.
But we're only interested in the tangent at a point. A tangent...
Yeah, and the tangent has no angle, so why are you using an angle for B and C?
That's what you can see the black line is. The black line is the angle of the curve at this point.
Which is 0, right?
No, it's not. It's 45 degrees.
At the tangent, it's not 0?
Why is percentage not getting muted for over-talking constantly?
Right,
let's actually, here's the deal.
Let's just forget about
Rumpus.
Can I just finish the point, please, quickly?
Oh my god.
Right, so can you see on screen? This is just the zoomed in curve. So let's forget about the purple line for the moment. So all I've done is to zoom in to this curve like this. And you can see the angle of the curve at this point. And all the tangent is me saying, right, I'll just make this curve into, I'll extend the point. So there's a point here where the tangent is, but we can see there's a gradient. So all I've done to create that purple line is to take the point that we had there and then just simply extend the gradient that you can see on screen further.
Absolutely.
That's what a tangent is.
Okay,
absolutely.
Rumpus.
Right, so there you're right. You agree with me. Great, fantastic. So
but you're missing the point, Rumpus. At the point,
the angle went to 0.
You're missing the point, Rumpus. In your other, hold up, Rumpus. Let me respond. So in your other drawing, you have angles B and C, and you're trying to say that they were a specific amount. But the truth is, they're not that amount because that line will go to the tangent point and it'll be 0. There's no angle at B and C unless you're assuming a flat plane.
Hold on. If I draw another line here. So let's make this a bit, let's make this thinner. Whoops, make this thinner. Right, so is there an angle between this, I'll make it green.
Is that horizontal?
Hold on. Is there an angle here? Whoops, text is a bit big. Hold on, give me a second.
Hey, is that horizontal?
Yeah, hold on, let me ask you the question. Let me get, so we can all see on screen before we get excited. Right, can you see there is an angle?
Absolutely. Is it horizontal? No, so it's a false analogy.
No one's claiming it is.
You were claiming the other one was.
No, we're not talking about tangent anymore. You said you couldn't get an angle to the curve.
Look at this straw man.
Let me finish my point. So we've got an angle here, which is we can make into a straight line. That's the angle of the surface of the Earth. And so we can, from this green thing, we can say, well, there's something in the distance. So let's suppose, let me give that an arrow. Let's suppose there's something in the distance relative to that shape. So if we put an arrow on
Rumpus, this isn't what I'm arguing. I'm arguing that with a horizontal, which is tangent to a point,
no, you claimed
you cannot have
an angle. You claimed you couldn't have an angle relative to the
You
surface.
can't have an angle with the horizontal unless you're assuming flat plane.
No, you can. Look,
Simple as that.
I've got an angle between the surface of this curved object and this arrow, which I'm going to pretend is pointing to Mars.
Yo, does anyone else want to try telling him, because he's obviously not getting it from me?
Between the surface of the Earth and the direction to Mars.
Great, now make that line horizontal.
Why are you talking about horizontal?
Wasn't that what angles B and C in your other diagram were? Horizontal?
Horizontal, no.
Oh, really? They weren't horizontal?
Why did you say they were horizontal?
Okay, go back to the other drawing.
Look, let's just establish this first.
This is established. This is not what we're arguing.
I want to make this point first before I go to that.
All right, go ahead.
We hopefully can all see that I zoomed into this curve and I've now drawn a straight line, a green arrow, which I'm pointing at something. And you can now see there is an angle between the green arrow and this, which I'm going to now call the surface of the Earth. This black line represents the zoomed in surface of the Earth. And we can see there is an angle A between this something I've got looking at, this green arrow is pointing at, and the surface of the Earth. So we have an angle. Right, so now there's some question about my other...
Is that line A tangential?
No.
Okay. Was the line, the purple line tangential?
No, that's a tangent. We're not dealing with a tangent.
Keep up, Rumpus. This green line is not tangential. It's not what we're talking about.
This is not tangential. No,
exactly, it's not, which is why it's a false analogy.
The green arrow is pointing to an object, and the surface of the Earth is represented by the black line. We have an angle between them. No one said that. I never said the green arrow is tangential. It's an angle.
But the purple line was, right?
Yes, the purple line was
exactly. And in your other diagram, angles B and C were, right? They're represented by a horizontal that was tangential to the globe, right?
They were not tangents. You just made that up.
Oh, really? Go back to the other drawing.
You gotta let him finish, Rumpus.
The diagram, I never ever said that was tangential. Where did you get that from?
What's the point of it then?
Because it's the angle relative to the surface of the Earth.
Relative to the surface of the Earth.
You've got to measure. Jesus Christ.
Relative to the surface of the Earth, how?
Right, here we go. I've just demonstrated to you in the other diagram, we can have an angle between the surface of the Earth, which is its tangent, and the angle to Mars. So that angle, actually it's angle B. Let's just substitute that. So it's angle B over here. So
yeah, perhaps you're getting this angle without having a horizontal.
So there we have an angle B between the tangent of the Earth, the surface of the Earth at this point. So if I were to draw in a tangent here, so then I'm going to draw a tangent in.
Exactly, off of the horizontal.
It is the same as the horizontal, you idiot. That is the horizontal.
Wow.
So there we go. There is just, that's no different to the zoom.
Now, if you were to zoom in, if these lines were thin, like very thin lines, and you were to zoom in, they would come to a tangent point.
As an observer with a telescope would see above the horizontal on a curved surface to Mars. The angle B is that very angle to get to the angle to Mars from at this location where I put the star. This person with a telescope, the angle that he would see would be angle B.
Okay, so again, you're assuming a flat plane, right?
Go ahead.
Got nothing to do with it being a flat plane. Jeez, why do you get?
Of course it does.
I just demonstrated a circle. Look at that, it's a circle, and I've got an angle to the Mars from it.
Rumpus, you've just refuted yourself, my man.
No, I've just shown that you can have an angle relative to the curve of a spherical body to something else. I've just demonstrated that angle B exists. You have got, my God, the fact that you think this is a problem. I didn't realize you were this stupid, whoever I'm talking to.
It is a problem.
Oh, you could draw it as a square, Rumpus, and it wouldn't make any difference, couldn't it?
No, if it was a square, you wouldn't have an issue because it would be a flat plane, and he's doing flat geometry with it. He's doing Euclidean.
No, he's not. He's doing actual geometry.
You cannot understand there's an angle between this purple line, which just represents the horizontal at this point, and the black line. You can't see there's an angle there.
That's absolutely fine. But you have to understand that horizontal is a flat plane that you're getting that doesn't have an actual angle.
It does.
Right? If you zoom into the horizontal, it's going to go down to a zero.
All a tangent is a zoomed in there. It becomes flat. If you zoom in enough, it becomes a straight
Parallel.
line.
Yeah, exactly.
That's
It becomes
what...
tangential.
Yes. So we've got an angle to it. So that angle B is the difference between the surface of the Earth and the black line. That's what B is.
Okay,
Exactly.
I think we
So
should
you're
let the,
assuming
I think
a
we should
plane
let the
right there.
How
audience.
can you be this stupid?
Okay,
My God.
Rumpus, calm down, man. We'll let the audience decide there. I mean, you did contradict yourself, and whoever was listening knows that. But can we get back to my question here? How do you get the line between B and C?
Contradict myself about. Please tell me. I'd love to know.
You're saying that
Yeah,
wasn't
you
with the
just
flat
said there
plane, and then
was
you
no
introduced the flat plane.
horizontal. Then you
I
came
want
back
to
and
know.
said there was one. So anyway, how do you get your line?
All this tangent, all a tangent is. Remember, all we're dealing with is this point here. There's this little star where I've actually got. Let's make this star a bit smaller. Let's make sure we all know what we're talking about. So imagine we got a little observer with a telescope, and he's sitting. I'll make this star a little bit smaller again. So he's sitting
turning
here.
a 90-degree
He's
triangle
sitting here.
into a.
So he's sitting here on the surface of the Earth, and I've just put the purple line in to help you. But you can ignore the purple line if you want to. Let's just see it. He's going to say, right, what's my angle to Mars? So the black line here is the angle, a line he's perceived to Mars. This is in his telescope. He's saying, right, let's look at Mars. And then he's going to measure the angle to Mars relative to the horizontal, his local horizontal, which is just the point of the curve, the surface of the Earth, the tangent at that point, and he's going to measure the angle B. And I
So
show
you
here,
assume
and there you are. I've
so
got
you
a spherical Earth, I've got a sphere, I've got a circle, and I've measured the angle B from this point where the person with his telescope is to Mars. So I've done it.
Okay, so you assume a local
I haven't
horizontal.
assumed anything. I don't
Yeah,
assume anything.
you just said that. You just said
the
that.
tangent is a straight line from
Yeah,
which
of
you can
course.
derive a.
Straight lines all over the sphere, of course.
Yeah,
So how do you get your line from B to C?
Okay, let's imagine this purple line here is a spirit level that he's got on the bottom of his telescope. He puts his spirit level like this on the bottom of his telescope, and then he says, right, I'm going to measure the angle that I'm pointing my telescope relative to the spirit level that I've got at this point, and he's going to measure this angle B. There you go, carry on.
Wait, is he measuring it from horizontal or measuring it from level?
Dude,
let me ask Rumpus a question, y'all. Real quick. Hey, Rumpus, where is there anywhere on Earth that Mars is ever directly overhead?
Well, it would be someone. Okay, it's a different question, but okay, there would be a point here that in this particular scenario I've drawn here, there's a position here where that would be directly overhead. Obviously, this is in 2D. I mean, if this, for instance, if Mars was nearer into the picture, into the screen that I've got driven here, it would obviously come round this side. But let's imagine it's just 2D a problem at the moment. Then this, obviously, this point, we'll call it point D.
My question is, why is there a ball already?
No, wait. Can we please? He pulled this diagram up to answer my question, and it's been 15 minutes. So, Rumpus, can you draw the line from B to C, please?
You want me to draw a straight line?
Well, that's what you need. So.
No, I don't know. No, I don't need that. The only thing I need to determine the distance to Mars is this angle, the angle C, and the distance along the arc. So this distance here.
Why are you assuming it's an
arc? And a great imagination.
That's the difference. So I just need to know this distance along here from there to there. And then simple geometry, using simple 11-year-old, 12-year-old geometry, you can then know the angle between these two things. So if you know that length of that arc, you can then work out this angle here.
Yeah, we know.
Like Silent said, why are you assuming it's a ball? Why are you assuming it's an arc?
We already know it's a ball.
Right, so then you know the distances are here to here. So it's a simple 12-year-old type problem that you could get
okay, wait,
12-year-old to answer.
Rumpus.
Would then give you what the distance is between here and here.
Okay, so wait, Rumpus, can you do me a favor for the audience? Can you draw a straight line from B to C, please?
I can do that. I did ask you if that's what you wanted.
Well, that would be a chord.
Hey, can you guys just show? Thank you.
There we go. Yeah, but we don't.
Okay, so this is how you triangulate, right?
You can work it out. You can work it if you wanted to. I mean, if you wanted to.
Calm down. This is how you triangulate, right? You use a triangle. Isn't that right?
You know you can use radians, don't you?
Yeah, I understand.
Right,
but this is how you use it.
But do you understand? I can determine this chord length from by knowing R. Do you know there's a simple relationship between R, S, and this chord length.
Of course, of course.
Right, so you can determine it then, can't you?
Well,
so that
are you guys
chord
gonna,
that you're getting all excited about, I can very easily
you're the one.
calculate from the information I've got.
Rumpus, you're assuming it's a globe and you're assuming it's an arc.
Right.
It's not assumed. It's known. It's already known.
The Globers think they know what I'm going to say. They don't.
But it's a globe.
Okay,
Just from the fact that
look,
that's
hey, feel free to stop interrupting, man. So, B to C, straight line, that's how you triangulate, right? And then you're assuming your local horizontal in your own words. Now you are going to actually assume an arc based on your distance relative to the R value, and then mathematically factor it in via assumption, right?
No.
Would you agree that we would have to have the R value to do this?
We do know the R value.
But do you agree that we would have to have the R value to do this?
Yeah.
Okay, how did we get the R value?
By measuring the circumference.
Oh, really? We measured the circumference
Yes.
and it gave us the R value.
Yes.
Okay, how do we do that?
You just, once you know the circumference, it's a simple operation of trig to calculate.
How you measured it.
How? Well, first of all, I should probably allow Rumpus. No, I'm right here. First of all, I should probably allow Rumpus to complete whatever he's talking about. I mean, I shouldn't. Oh, he's muted.
Cool. Well, Rumpus pulled this up because we were discussing his fairy tale of how he has to assume all these things, and he said, "Well, no, we know the distance to the sun." I said, "How did you know that?"
Yeah, we do. We do.
Well, we knew the distance to Mars. I said, "Okay, well, how'd you figure that out?" Then he pulled his diagram out, and what we have found out is that to get the quote-unquote distance to Mars, we need the R value for starters before we can do anything. Before we can even address the dozen other assumptions you make looking at Mars, the light in the sky, we need the R value. So how did we get the R value?
Well, I just want to make sure that Rumpus is done.
Well, yeah, this was what our conversation was about. That's why Rumpus brought this up.
Yeah, the circumference is 2 pi r, right? So you just calculate it. So you know the circumference. You just solve for r.
How do we know the circumference?
You measure it.
How so?
Any of a number of ways.
Well, just give me one.
Such as?
You could use the method used by Al-Biruni or Eratosthenes, or just directly with geodetic surveyors have calculated the circumference.
Basic answer is we use math. If
Yeah,
you don't
so geodetic
agree with
surveying
math,
also-
well then we've got a problem.
Well, it's just measurement.
Geodetic surveying actually assumes a sphere, taking topographical measurements, assuming planar geometry. Then
No.
it compiles them over a vast. This is just objective, and then you assume that sphere, and then you take a.
You cut out. We didn't hear anything.
The circumference value was not.
You cut out. We didn't hear what you were saying. You cut out.
Okay, so they use topographical measurements, assuming planar geometry. They then compile them over vast distances. Yes,
They don't assume planar geometry.
Really? So
They
how
don't.
do you make topographical measurements then?
They make geodetic measurements. They measure the curvature of the Earth.
So we make maps using geodetic measurements.
They make for geodetic surveys. Right? They yes.
Oh my God.
So wait,
Yes,
okay.
they
So
do.
to do geodetic surveying, do you need to know the distance between 2 points?
Yeah.
So how did you get that distance?
They set up a station. With theodolite. They set up a station, a theodolite, and they set it up and they measured the distance.
They did a planar survey.
And when you add up all the triangles, you get an excess.
Look, you're running away. So again, what I said was you take planar survey data. That's how you get the measurements. You then compile that data set to a greater distance. Okay, and then you make an observation, assuming a sphere, applying spherical geometry. They did not actually determine the circumference with geodetic surveying, nor did they determine the radius value, because in fact, they actually compared their measurements, really their calculations, their observational calculations, they compare those to the R value to get an accuracy percentage. So when you say they use geodetic surveying to determine the R value, that's patently false.
I'm hearing people sort of popping in and out and stuff. So it doesn't matter. We can use any of a number of methods to calculate the circumference of the Earth. Once you have the circumference, you know the radius. And from the radius, you can do all the other things. You can get the angle from a curve, because the angle between a straight line and a curve is simply the tangent to the curve and the straight line.
Okay, so when you say that we have a plethora of ways to do it and ask for just one, and then we instantly refute your one way that you invoked, you cannot then just breeze back over to assuming that it's there. That is the fundamental assumption that's being challenged. So we demonstrated that it requires the R value to make your little diagram here pretend to be real. So we need to determine the R value. We cannot just assume it. We cannot assume the Earth's a sphere with a certain dimensions and then make up stories about what's in the sky.
The Earth isn't assumed to be a sphere. It's measured to be a sphere. And the circumference is measured. The radius is measured. All of these things have been done.
And all you did just now with it was go,
The radius has never been physically measured. That's absurd. You claim that it's 3,959 miles away to the center of a magma core. Obviously, no one's physically measured that. You've calculated it based on an assumption of spherical geometry, compiling planar survey, and then getting a supposed circumference. So I asked you, how do you determine the circumference? You said we have millions of ways.
You measured it. You measure it.
I said, no, you didn't measure the circumference, because I asked you, how do you do that? And then you said geodetic surveying, where in which I objectively stated exactly how geodetic surveying works. It actually requires the planar survey data, the assumption of a sphere, and R value.
You're roboting again. You were what's it? You were roboting again.
With
You were
geodetic
roboting.
surveying, that's timing to prove.
So you were roboting again. We missed the last half of that.
Can you give me an actual?
You cut out again.
Yeah, he keeps cutting out all the time. There is other ways to done measurements too. You know that with the Aristarchus angles with the stick and shadows for the sun, which has been done a few times.
Okay, can you validate how you determine the circumference or the R value without assuming the very thing you're claiming to prove?
There are a number of methods by which we can measure the circumference of the Earth. There are multiple methods. All of them have been done, and they all agree within a degree of error with each other. Like the Eratosthenes type experiment, the Al-Biruni type experiment, the measurements by geodetic surveyors. There are any of a number of ways of doing it. You can measure the circumference by standing on a beach, waiting till the sun sets, and then going up higher, and then waiting till it sets again, counting that time, and then there's a little formula you can plug in, and then you can figure out the circumference.
No, that's not true, because you're supposedly using this to determine the distance to the sun. And if you need the distance to the sun, then you obviously can't determine what you need to find the distance to the sun by using the distance to the sun. You said geodetic surveying. I just objectively refuted it by describing exactly how it works. You then said Eratosthenes and Al-Biruni, which of course Eratosthenes assumed parallel rays and not even account for the possibility of divergent rays with a localized source. And with Al-Biruni, he actually looked at an apparent location, a fluctuation within, assumed spherical geometry, begged the question of the sphere, and then took a middle ground, median, and then reverse engineered an R value, also reifying the circumference value.
Funny how all these values all agree with one another, though, isn't it?
Because they are dependent upon one another, my friend. This is very basic, rudimentary things here, but
I'd like to respond.
Funny how they all agree with one another, though, even though they're very
because
different.
that's how you got them.
No, it's the other way around.
No, our perspective
I'd like to
matches
respond.
the globe math. Ain't that funny? Ain't that a great coincidence?
No, I've seen that leaky, and it doesn't. You guys just use numbers and masturbate with them.
I can tell you right now that it matches. They don't even deny that. They just call
No, I deny it because I've seen your math, your so-called math, and it's basically you have no units to go with your math. It doesn't work.
Okay, wait.
But guess what? Ruhif don't deny it. Rumpus don't deny it. They call it a coincidence.
I don't even call it coincidence. I call it you guys don't know what you're doing with math.
Okay, but wait, let me address it specifically. So isn't it funny how all the measurements work together? They work perfectly. Well, under your own side's admission, he even brought up a diagram. I don't know if you were here. He was saying the way we determined the distance to the sun was because we determined the distance to Mars. And the way that we did that was utilizing the R value. And so when you say that the supposed distance to the sun agrees with the R value, that's not very bright because it actually used the R value.
You don't need the R value to determine the distance to Mars. No, sorry.
Okay, so how can you do it without the R value?
Radar.
So can you please cite where they shot radar at Mars and determine the distance?
Oh, you want me to pull that out? Sure. Let me go Google it for you. I'm your little
Thank you.
slave today. I'm your little slave today. You want me to waste time finding?
Don't make claims if you're not willing to substantiate.
You want me to waste my time so you can hand wave away once I find it.
You're the one that made the errant claim. You have a burden of proof.
You want me to waste my time finding?
Okay, so anyway,
it always happens, right?
Sorry, I'm just saying my point was simple.
Why are people getting muted when they ask questions? That's not fair. Whatever the word is.
I'd like to respond to what Whitsett said.
Okay.
When you all get a chance, are you all done?
Go ahead.
All right. So your claim was that Eratosthenes, you denied that because he assumed parallel rays, and that's false. The rays of light from the sun are in fact parallel. It's not an assumption; it's an observation. They are parallel. Right? And so so
one at a time, right? One at a time so we can have a
is that what you don't do that though? You gish gallop.
Well, no, the reason I had to bring up like three things because you brought up three things.
Then I get to bring up then I get to refute them three at a time.
Well, just because that's what I'm saying. Like, can we just agree to, actually discuss one at a time?
Okay, one thing at a time. That's cool. The rays of light from the sun are parallel.
Okay, and you said that they're observed to be such that they're actually observed to be the opposite of that.
By whom?
By everyone that's ever existed.
No, that's not true.
I don't remember measuring that.
So wait, are you saying we don't observe rays diverging away from the sun?
Oh yeah, of course we do.
So we don't observe parallel rays.
You mean crepuscular rays?
So we don't observe parallel rays.
I want to get precisely what you're talking about. You're talking about crepuscular rays, right?
Well, every time you've ever seen a ray coming from the sun, it's not parallel. It converges under the sun.
I just want you to commit that these are crepuscular rays that you are talking about.
They're diverging rays. Why do you need
I'm talking about every ray ever from the sun.
Why won't you commit to this? I want you to commit. You are talking about crepuscular rays as your evidence.
Why are you trying to pigeonhole it to that word?
Well, because I'm talking to him, not to you, for one thing, and to another.
Understand what he's saying, right?
Flat earthers often demand very precise definitions, so I want to be super clear. You're talking about crepuscular rays.
Not under the current assumption. So the current definition of crepuscular rays is assuming what you're claiming to prove. You think you're going to go pull the definition out and it's going to prove me wrong or something.
Oh, that's what you're claiming.
You made the claim.
I'm not going to pull. I'm not going to pull the definition. I'm not going to open up a webpage.
I'm going to end up getting at you. You made the claim, okay, that we observe parallel rays. I said, no, actually,
yes.
we don't. We observe the opposite. So can you enlighten me, when Aristophanes was out there, how did he observe parallel rays?
So crepuscular rays are what parallel rays look like from a distance.
So he didn't observe parallel rays then?
No, he wasn't answering that.
Yes. So that's what parallel rays look like.
Okay, is that what converging rays look like?
That's what parallel rays look like. They look like crepuscular rays. That's what they look like.
Okay, Brenda, is that what converging rays would look like?
No, they wouldn't.
So converging rays,
there would be a slight difference.
Like what? What's the slight difference?
Depend on the angle of the conversion, right?
They would be, yeah, the angle would be greater, I think. So when you know the answer, you know this answer. You've already heard it many times. Just like train tracks, parallel light rays from the sun appear to diverge, but they are not. They are parallel.
Well, yeah.
Just like the ground is curving. You say the ground's curving. We say the rays are diverging. You can't prove the ground's curving.
You're right. You're right. They are diverging because that's what parallel rays look like.
Okay, Brenda, it's really simple. Okay, you made the claim that he observed parallel rays. You've now circled around and said, well, what he actually observed looked like converging rays, but that's
no, it looked like divergent rays. Divergence is what parallel looks like over a long distance.
Okay, so he didn't actually observe parallel rays, though.
He would have observed parallel rays, like, for instance, the columns of the Colosseum, because he lived in Greek. They had Greek columns everywhere. He would have observed that the shadows cast by those columns are parallel.
Not if he was 60 miles away. Then he would.
They're parallel.
No, they're not.
They're observably parallel.
No, they're not.
I can show you photographs of vertical items, whether it's columns or fence work or anything, where the shadows cast are parallel.
Hey, if you have a local light source and there are rays converging onto that light source, are any of them parallel?
No, that's how we know that the sun is distant and not local.
Because there would be zero parallel rays on a converging light.
Because the shadows cast are parallel. That's how we know it's distant.
Actually, not all the shadows are parallel.
From the sun, they are. They are.
I gotta say this. How many times I gotta say this? They diverge, Brenda, 1 degree every 60 miles. Okay? You say that's Earth curve. We say that's diverging sun rays. We observe diverging sun rays.
We do not. We observe diverging sun rays because that's what parallel rays look like.
Okay, that's the assumption. That's called begging.
It's not an assumption. It's an observation.
Okay, so anyway, Brenda, so whenever you brought up Aristophanes, you say determine the circumference. I said, well, he assumed that the rays were parallel and it was a distant light source. Okay?
He didn't assume it. He observed it.
You said it's not an assumption. He observed it, right?
Yes.
And then you've actually admitted, well, what he's observing, what he literally sees, is divergence. But it's just optical. It's just a perception. It's an illusion. They're actually parallel.
Right. When I look at train tracks, I don't assume that they're parallel. I can see that they are.
Well, you can physically verify that they're parallel.
I can see that they are. I don't have to physically verify it. Because I know what parallel looks like. It looks like train tracks. That's what parallel looks like.
Okay, so Aristophanes assumed a distant light source and parallel rays, and his circumference value wasn't even the same that you claim it is.
No, none of that is true. None of that is true. He didn't assume. He knew it because he made deductions. He made logical deductions.
All right, here I'm gonna watch a movie with my girl, but here's my whole point. Okay, the conclusion of this, dude, it was very simple, right? He's saying we were talking about how we actually don't know the properties of what's out in quote unquote space, and he brought up Doppler shifts and red shifts, and he says, is there anything other than velocity shifts? If it's a more dense medium and they're closer, then you would also see some change in the medium, and then you're misidentifying. I actually quoted Edwin Hubble, the person that came up with the current theory. Then he moved to, well, we know what it is, we know what's out there because we know the distance to the sun, and he said it's because we know the distance to Mars. Blah, 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 blah. Yeah. So then we found out, well, you have to have the R value to make up your assumption of triangulation. Then we asked for
the R value.
We went back to a story about Eratosthenes, which everyone
because
that's not in this conversation has heard it. Everyone that's honest knows that he made the assumption that it's distant and that they were not.
No, he didn't make an assumption. He deduced
I gotta get out of here.
The sun. Yes, I know you got to run. But Eratosthenes did not make an assumption. He made a deduction. He deduced it.
Okay, Brenda, I'm running away from Eratosthenes. You got me.
That's not what. That's not.
And then I'll get you on Al-Biruni next.
Man, what a troll!
Right. So
yeah, it's pretty bad.
So that's just what.
That's just not really the type of live stream content that's very quality. But yeah, go ahead.
Well, the main problem, Brenda, is the light from the sun appears to come in through the window with a decidedly downward aspect throughout the day. It's not consistent with a revolving object. If we were on a revolving ball rotating toward the sun, you'd expect something like the sunlight hitting the ceiling and rotating down toward the floor or something to that effect. But the light always appears to come in with a decidedly downward aspect as if it is always above us and not on a revolving object. So this kind of evidence appears to fly straight in the face of the globe Earth model.
So I'd like to ask Gio what was wrong with that content, because I'm trying to conform to his ideas, but I had to respond to what Whitsitt was saying, and he was wrong.
Well, 100 times the assumption. Bill Bell will admit them assumptions.
It's not an assumption. I don't know how many times I can say it's a logical deduction based on observations.
By definition, it is an assumption.
It just didn't seem, overall, Brenda, it just didn't seem like a productive conversation where there was like a fair back and forth. Right. It seemed like more like a hammering, you know what I mean? Like kind of where you were, just sort of trying to force the ideas.
I had to repeat myself because Whitsitt kept repeating himself. So the point is, it is not an assumption, it's an observation. We deduce from observations, right, that the rays of light coming from the sun are parallel. Anybody can see that. And there's almost nobody who thinks
you get about a seventh of a degree diverse.
There's almost nobody. There's nobody.
Hold on, Brenda. When we look out 10 miles and we don't see drop, but we see the shadow change by about a seventh of a degree. Okay, I mean, like about a 13th of a degree over 10 miles. You say the ground's curving, but we can look them 10 miles and see the ground's not curving. We see diverging sun rays. You can assume it's a ball, Brenda, but it's only an assumption.
No, it's not an assumption. It's a deduction.
The only problem, Brenda, is we can deduce something else. In fact, it's not even a comfortable deduction to say that light is parallel, because that flies in the face of triangulation or being able to trace the rays of the light coming off the object back to a point source. If it was parallel, you would not be able to do that, and so that's a little bit of a contradictory premise.
The sun is not a point source.
Did you do it? Can you exemplify a situation where that happened, where you use the light rays to triangulate a point?
Whenever we see light come off of an object, we assume that they're light rays that are coming off of the object, traveling back to the point of the object itself, number one. Number two, you also see shadows that appear to diverge and spread from the object itself, almost like the light rays are spreading and non-parallel. So these are contradictory premises.
No. That spreading of the shadow has nothing to do with the distance of the object, because you can, for example, put two holes on the wall, right? And those holes, let's suppose they're 1 meter away from each other. As you go away from those holes, the shadow or the light that is being casted from those holes start to scatter at the boundaries, and that that increases the radius of the circle, but the distance between those circles keep being 1 meter, which means that that's not due to distance of the light source. That's due to
So we're dealing with light that is non-parallel if it is spreading in its way.
No, it's not because it's not parallel.
If we were dealing with truly parallel light, it wouldn't spread at all.
That's
That's
false.
a contradictory premise.
That's
say
false.
that it's practically parallel, but all of our senses and all of the evidence of our eyes
I'm
and
giving
senses
you.
point
I'm
to,
explaining why that's a flawed reasoning.
otherwise, shadows wouldn't spread, and we wouldn't be able to triangulate anything.
Let me explain to you. If the spreading of the shadow was due to the distance of the object, the distance between those two circles would increase with distance, and they don't. Which means that spreading of the shadow is because the light source isn't a point light source. When you have a light source, it's not a point light source. It has an area. Then the shadow spreads. That has nothing to do with the distance of the light source.
If you start raising that piece of paper off the ground, them two holes will grow. Okay.
Yeah, exactly, but they're not going to get further from each other. That's why it doesn't point to a
spreads and it's non-parallel. Otherwise, it would have.
It doesn't show that they're non-parallel. It just shows that the light source is not a point source.
They'll start touching each other. The shadows will touch each other after a while.
The distance between the center of them is going to be fixed, which means that the light source is parallel.
Eventually, they overlap and smear into each other, which shows that light spreads and it's non-parallel.
No, that doesn't show it's not parallel. It shows that there's not a point. The light source is not a point.
Why did the shadows merge with each other and spread? That's a contradiction.
No, it's not a contradiction. I just told you it's because the light source is not a point source.
If the light is coming from a shadow is coming from the absence of parallel light, then the shadow should not change shape and should just maintain its size and not spread. You have a contradiction.
No, that's when you have a point
practically parallel on the galactic scale.
That's when your light source is a point light source. When it has an area. When it's an area.
Let me say something. So we can shine a laser from like 5 foot off the water, right? We shine a laser 15 miles away. And it's parallel across the ground, and then we see that the sun's rays have diverged by like 0.22 of a degree. So you're going to say that the laser's refracting? I'm calling bullshit.
No one's talking about that.
So basically, you guys are trying to claim that it's parallel so that you can invoke perspective as to why it appears that we have a local light
they're
source
observed
all
to
the
be
light rays
parallel.
are converging to. What were you saying, Brenda?
They're observed to be parallel.
But you can make another deduction, Brenda, so that it gets to the point of being more.
Not a deduction; it's an observation.
Are you not hearing anything I'm saying? I don't know if y'all can hear me.
The
but about
observation.
every 10 miles, we measure divergence in sun rays. You call it Earth curve. Okay, so quit saying that they're observably parallel. They are not.
They are. Well, no, you're just wrong because crepuscular rays are what parallel lines look like.
So if I travel 60 miles, it's not, the shadows aren't going to diverge by 1 degree.
I don't know.
Look it up.
Yeah. So the rays of light coming from the sun are not perfectly parallel. They are because the sun is a disk, not a point source. So there is some. I don't know if it's 1 degree over 60 miles, but it is smaller than any instruments that Eratosthenes had, or people had, or anybody had until the modern era.
Brenda, listen. Brenda, you're saying the Earth is curving. You're saying the Earth is. Hold on. Brenda's saying the Earth is curving 1 degree every 69 miles, but she can't acknowledge that the sun. So my point is the light is diverging, whether it's the ground or whether it's diverging sun rays. You can assume it's the ground curving, Brenda, but that's what we see. We see light. We see angles change, Brenda, period. Don't you not understand that?
Crepuscular rays are what parallel lines look like when you look at them from that long distance along the length. That's what they look like.
Crepuscular rays, Brenda. I'm talking about observable reality.
Your voice is so much better now. What did you do differently? It's so much better.
No, I'm just talking. Listen, I'm talking about observable reality. And so I say we shine a laser straight across a lake 15 miles, and we see that that's the bottom line of the triangle. And then we check the shadow of the sun, and we see that over that distance, it's diverged about 0.22 degrees. Then, that shows that the sunlight is diverging. If our laser
sounds to me like that would be the curvature of the Earth. I'm not 100% sure, but it sounds like it.
Yeah, you could assume that. But
but Brian, that's a different topic than what I'm talking about. I'm saying that when you have parallel lines or shadows or rays of light, when you look at them along the end, they appear to converge or diverge, but they don't. Crepuscular rays are what parallel rays look like. I don't know how many times I have to repeat this until you understand. It's
I think they're just
like train tracks.
I think they're disagreeing that those are crepuscular rays.
They are crepuscular rays, but they're from a local sun. That's the main thing.
No, you can't have both.
Yes, you can. Because if the sun is 4,000 miles away and we see the crepuscular rays deviating about 1 degree every 69 miles, or roughly something near that,
and they wouldn't be crepuscular.
How do you explain, Brian, how do you explain anti-crepuscular rays?
That's my question to you.
Oh, it's very simple. Because that's what parallel lines look like when you look at them from end on.
Like I say, look, so look, let me
supposed to get this is what it should look like.
So we focus in on about 60 degrees of what our vision out of the 90-degree plane that we're looking out at. So divide the 90 by 60, you get 0.666, which is the rate of Earth curve, or the 1.22 in our vision. I mean, on the horizon ties into our vision. You have turned perspective into Earth curve, and now you're trying to prove it when all you're doing is you're admitting everybody. You're assuming it, Brenda.
It has nothing to do with perspective. Well, I'm sorry, but actually, with a crepuscular rays, that is perspective.
I'm not making the argument of crepuscular rays.
Well, that's what I've been talking about this whole time.
But Brenda is correct that crepuscular rays do look like perspective, parallel lines converging. That is correct.
That's what they are. It's not what they look like. It's what they are.
No.
So Terry,
you cannot prove that.
Yes, simply by showing you anti-crepuscular rays.
Well, the crepuscular ray argument is basically used to avoid what would otherwise be an obvious triangulation to the sun's local position. They say that it looks like it's basically 3,000 miles away by triangulation, but that's, basically a fake. We know that there are parallel light rays that go millions of miles away to a faraway sun.
How do you demonstrate that claim?
Fight.
Oh, unless you demonstrate that claim, it's just a claim.
So the way we can refute that,
rays that converge on an object and allow some level of triangulation locally to a local sun.
So Terry is putting up some excellent images of anti-crepuscular rays. Those rays refute your claim that there's a small local sun, because the sun in those pictures, the one with the palm and then the one with the red landscape, the sun is behind you.
She got us, y'all. Time to take down the channel. Let's all go home. She proved it.
What?
Everything you think is proof, you just assume.
It does, Brian.
Everybody here wrong.
Yes, I just refuted flat Earth. Those are anti-crepuscular rays. The sun is at your back.
There's too many.
How come the train track converges after about a few hundred feet? Not even a mile, a quarter mile, but the crepuscular rays don't converge nowhere near that fast. They go past the clouds. We don't even see where they're. So your so-called proof is an assumption.
No, in these images put up by Terry of anti-crepuscular rays, if you were right, the sun should be right there. But in fact, the sun is behind the photographer. The photographer has his back towards the sun. This totally refutes. This totally refutes the flat Earth. All your claims.
No.
Small local sun. I just refuted every single claim about a small local sun. Every single.
May I respond?
All right. Yeah, I'm gonna have to mute you for a bit. Yeah, go ahead. Go ahead.
Okay, so you say that you know the train tracks are parallel. Okay, you know they're parallel. So how come they don't deviate? How come they're not the same? If you know the sun's rays are parallel and you know train tracks are parallel, how come the crepuscular rays go for miles without diverging or converging? So if you know the sun's rays are converging, they should converge at the same rate perspective wise as the train tracks, but they don't. So globe debunked, like her philosophy.
What?
I mean, she said she debunked a small local sun, which she didn't. So I'm gonna say, look, since they're not converging at the same rate, if she's calling it perspective, they should converge at the same rate.
What do you mean they're not
converging at the
same rate?
But I was being facetious. I don't think that technically debunks a globe, but no more than she debunked a flat Earth.
But what do you mean they're not converging at the same rate? Like, what do you like? What do you
called it perspective? She said she knows train tracks are parallel. She knows the sun rays are parallel. Okay.
Well, the best way to make a claim would be if you have parallel rays that are the same width as the train tracks, you'd expect the same rate of convergence if they're the same width or whatever. But the problem is two separate light sources will appear to converge due to diffraction limit and perspective anyway, no matter how separated they are.
We only have one
crepuscular rays, they're separated, Brenda.
So they're going to converge because of diffraction limit? Is that what you just said?
What was that? Anyway, two separate light sources will appear to merge and come together even when they're separated due to the diffraction limit and perspective anyway. So those anti-crepuscular rays, Brenda, will eventually appear to converge and merge.
Do you think we have two suns? Is that what you're trying to say, Lemon?
What was that?
Are you thinking we have two suns? We don't have two suns, Lemon.
So, your postulate also is...
This is not Tatooine. This is not Tatooine.
Contradicting Euclid, who says that parallel lines never meet, but we have a point source, the sun, where those rays meet.
The sun is not a point source. It's a disk.
So we have too many contradictory premises here, Brenda, and that's a problem.
How? The sun isn't. Oh, I'm sorry. Go ahead. I've spoken long enough. Go ahead. Somebody else take over.
I just asked him to point one contradiction. He said there were many, like
parallel
point one.
Lines never meet, but they appear to meet at the sun. It's contradictory.
Perspective. I mean, what are you on about? Like, what kind of question is
away from a contradictory postulate by looking at the appearance of something? Because you're saying it's just the appearance of perspective. You're postulating that they're parallel lines that should never meet, but they're coming from the sun. Therefore, by logical extension, they should come from the sun and meet at that source that it's coming from.
Okay.
So your postulates are too contradictory to go with. I'm sorry.
But they do meet at...
Okay, then by logical extension, if the rays are coming off of this object, they can't be parallel.
Yeah, of course, when he says parallel, it's not perfectly parallel. It's just parallel enough.
Yeah, it's very, very small. It's like half a degree or something like that. It's 0.5 degrees, I believe.
So not parallel.
Sure, but not comparable to a close sun.
It's not anything that Eratosthenes could have detected with his instruments he had, or even much later until the modern era. I don't think.
Okay, how do you know they're parallel? How do you know they're coming in parallel?
We can see that they're parallel.
No, we can see that they diverge.
That's what parallel lines look like, Jeremy.
I think Jeremy came late into the conversation.
Okay, so you're saying we can tell by appearance, then we can tell by the Earth is flat simply by looking at it by appearance. There you go.
Sometimes they don't converge.
The train tracks analogy is the best analogy you can use.
All I have to do is repeat my refutation of the small local sun, which is anti-crepuscular rays completely refute the flat Earth claim that the sun is small and local.
Well, in art class, we say that they're parallel based off of their distance from each other and their constant elevation. Have we made sure that these rays are spaced perfectly apart from the sun to the Earth? I don't think so. I think we've assumed that they're practically parallel based off of appearance. I'll grant you that. But there's a contradictory postulate in there, namely these rays that emanate from the sun are coming from a point source and therefore by logical extension are not parallel.
We're not assuming that they come from a point source. We know that the sun has a disk. You can see the disk of the sun.
And so since it is a local light source with non-parallel rays, we can triangulate it fairly accurately up to 3,000 to 5,000 miles away.
And how do you triangulate it with the anti-crepuscular rays? You never explained how that works on a flat Earth anti-crepuscular.
You go to
you kind of glossed over it.
You go, oh, I see the sun at noon, and I'll triangulate it then.
No, the anti ones. You know, how do you explain that on a flat Earth? You just glossed over it.
Anything that's separated will appear to merge and converge as long as they stay at more or less a constant distance from each other. So as long as these crepuscular rays maintain a more or less constant distance from one another, they'll appear to converge in an anti-crepuscular way anyway. But it will just be perspective. That's all. Look at the sun when it's high up in the sky at noon and triangulate from there.
If I have my back to the sun, why is it the rays of light from the sun are converging?
Because, as we know, two light sources will appear to merge into one due to the difference.
The sun is one light source. It's not two. I don't live on Tatooine.
The rays are another light source. And the rays that you're seeing will appear to merge anyway.
Hey guys, hold on a second. Hold on.
Going to merge.
Hold on. Yeah, hold on. Okay. So I've got something I'm posting. Oh, wow. It's 15 megabytes. But that's actually uploading pretty fast. All right. So it's posting right now. This explains it, Arma. Was it Arma that was asking? With crepuscular and anti-crepuscular rays, it shows just a basic, it's just a vector. It's showing, this is actually showing southern and northern star rotation. But actually, crepuscular and anti-crepuscular rays are the exact same concept because we live in a fractal holographic universe in which all things are synchronous. So this is a synchronous process, the way the sun works and the way the stars work. So what Brenda was just saying all about, being behind or in front of the sun doesn't matter because what you have is a vector of the sun. The sun itself is creating the environment. And so whether it is up in the sky, you're going to get the crepuscular rays. And if it's setting, you're going to get anti-crepuscular simply because the light is coming at you over the XYZ axis and you're seeing those rays coming from the sun.
So this isn't the same at all. This doesn't have anything to do with what we're talking about.
All right, I'm going to jump in the host role right now.
So, Brenda,
I'm probably just real quick. I'm just gonna kind of be chill though. I'm not gonna really
the GIF that you
I'm just gonna do
the
that.
GIF that you posted about is it refutes the flat Earth because it shows two poles. Flat Earth doesn't have two poles of rotation; it has one.
I think according.
I don't think anybody
Jewish,
said that.
Right?
I don't think anyone quite said that. About quote unquote a flat Earth having one. What does that mean? Because that's nothing I said.
Like a record, like a 78 record or 33.5 record.
Okay, is this a flat Earth theory you have, or what are you referring to?
That is the flat Earth. That's what it is.
What is the flat Earth? What is that?
That the Earth is a flat disk.
Okay. Does anyone in here think that?
No, I think that it's on pillars on top of a watery deep, like the biblical cosmology says.
Well, we're talking about the surface, of course.
There we go.
And I think that it's covered by a solid section of sky called the firmament or a dome or whatever.
Well, that's not addressing the question. It's obviously
So it's not
asking
a
about the
disk,
surface.
it's a hunk of land that's on pillars on top of a watery deep.
Do the stars rotate about a central point?
In the north, yes.
What do they do in the south?
In the south, it's deformed based off of atmosphere, the solid firmament glass, twisting and curving the light like that Spanish dude demonstrated when he passed the hemispheric glass dome cupola over concentric circles to represent the star trails under the atmosphere and/or dome.
That's not what the southern pole looks like at all. It's not deformed.
Off of atmosphere or glass or firmament.
It isn't. It does. That's not what it looks like at all. It looks
That's what he
exactly.
demonstrated.
It looks.
No, it does not look exact.
Trail.
It looks exactly
Look
like
again,
the
Brenda.
North Pole. It looks
No, it
exactly
doesn't.
like the
No,
North
it doesn't.
Pole. Yes, it
The
does.
south looks, hold on, Brenda. The south looks more like a tunnel. Look at them both side
No,
by side.
it
They do
doesn't.
not look anywhere near the same.
You get the same circular pattern in the south that you get in the north.
You get circles looking at a 2-degree picture, but it looks more like a tunnel. The south doesn't look like the north.
No,
Look
it
at it again.
doesn't. That's
You're assuming
wrong.
they look the same, but put them side by side, Brenda. They look way different.
No, they don't.
All right, I think we could probably get to a more productive conversation. I think Brenda just saying no, they don't over and over is probably not the most productive.
But that's and
let's shift to something else. So, in terms of what I was referring to before, we were talking about the corpuscular and anticorpuscular rays. So, I guess Brenda, you kind of did a whole derail there. No offense, but I know you started talking about flat Earth theories and stuff. We're just talking about the sun, the sky, corpuscular rays, and in terms of how that would work on a stationary planar surface, it would be the way that that a polarity of vectors within light function, which is how the stars function and how the sun functions.
So it's word salad. Is that what your answer is, Gio? Word salad?
No, when you no, not at all. So if you in terms of corpuscular rays, yeah, I don't know why you're trolling, but yeah, word salad is not a thing. So the words mean things, and they have a purpose.
When you string together a bunch of
model is word salad.
You're just you don't know what those words even mean. You don't know what a vector is.
So, Brenda, we already know that two separated light sources, like the anti-corpuscular rays, which are light sources also, will appear to merge with enough distance. We already know that, Brenda. So eventually they're going to appear to converge anyway.
They wouldn't. No, they wouldn't if they're diverging. I mean, you could literally test this yourself. Diverging lines don't meet up again.
Depends on how much they're diverging.
Yeah, but
like you said, they're practically parallel, but they have a source, so they're not quite parallel. Otherwise, they would never meet.
Lemon.
Yeah, I mean, basically, like when you have a sun over the Earth in an XYZ axis, when I was talking about a vector, you have light and dark because the sun is the light, and then everything that dissipates from the sun. Hold on, you wanted an explanation, so because you called something word salad, which is not the case at all. So when I was referring to a vector. And carrying on with what Lemon just said as well, like you have light and you have dark, and that creates the environment of which we live. The rays appear to be coming from the sun, which is a close and local source. So when it's above the planar Earth, the corpuscular rays come down and spread out. That is not looking at the sun at 93 million miles. That's a local sun putting down corpuscular rays, which is exactly how that would function. And then in terms of anti-corpuscular rays, that's when the sun is either rising or setting, so it's way far down on the horizon. And in that scenario, the corpuscular rays, instead of coming from the top down, they're coming from essentially like the bottom up, but really it's just horizontal up, as the sun is just so distant from your perspective. So the angle of which you're viewing the sun is so reduced down to where it's almost parallel with your eyes, which is why the sun sets. And that's why the anticorpuscular rays will come up and spread out that way. So it's just, when I was referring to the vector, it's the same vector, it's just 180 degrees flip. Either corpuscular rays coming down from the sun, or when it's setting, coming up from the horizon in your visual viewpoint.
I wanted to poke a hole at least, in this like logic though. All right, you're saying it works out, right? But with that being said though, right, the anticorpuscular rays, they do meet up at a point though, right? And so
for a point, but we don't actually see the point where they meet, like with the sun. That's the difference.
But they would meet up at a point though, if we could see.
One would expect it if they lasted long enough to do so. Yes.
Okay, so we could
But-
triangulate something there, but it doesn't mean anything. Though. There's not actually anything. There's
They
not
go
anything.
beyond the horizon, and people infer a point based off of the anti-corpuscular rays without showing the actual point where they meet.
The point I'm trying to get at, right, is that they do seem to meet up at a point, right? But if we were to triangulate something, there would be nothing there, though. There isn't anything there, right? So I mean, how do we? How can we
on a flat Earth? Light going away from us, they converge. Light going away from us on a flat Earth converges in real life. Light going away from us.
Can I just So the point of my argument is that because, all right, we can sort of triangulate something with the anti-corpuscular rays. How do we know that? How can we do that with the actual corpuscular rays when the anti one doesn't actually give you any location? It's just you know sort of a illusion.
As long as we have a sun there, we're comfortable doing that.
They're coming from the horizon.
There, we're cool.
Yeah, sorry, let me not talk over you. Yeah, they're coming from the, well, anti-corpuscular rays are coming from the horizon. Yeah, they're coming up from the horizon. Just like the southern lights come up from the horizon when the northern lights come down from the sky against the polarity.
Unless you want to imply that the sun isn't there for triangulation, which nobody is going to venture and say yet anywhere at all. As long as the sun is there, we can triangulate it.
No, my argument is that this triangulation method is flawed. The fact that you could apply it to the anti one and not actually get any, like it's not. It's
flawed because we know there's no object there, as far as I can tell. We know the sun is over here, and we can triangulate over here at the very least.
Okay, so how do we know it's not just perspective once again that's causing this
relevant and not
worth array effect? And at that point, you can triangulate anything.
Worth exploring. Otherwise, I don't care.
Can I just finish? Like, come on, I'm saying something. You guys just kind of I get it. I do that too, but like, geez, let me just finish. Anyway,
well, I think you guys were talking past each other a little. Let's try again. Brian, your mic just went real quiet. By the way, Brian, we couldn't hear you.
All right. Anyway, so
that's a good thing.
All right, yeah. Anyway, so my point is, all right, I'm saying one more time. All right, my point is, we don't the fact that the anti-corpuscular rays do this because of perspective, right? The same thing could be happening with the corpuscular rays. Therefore, I mean, you can't just assume triangulation is going to work. And I'm saying you could totally be wrong. All right,
they always triangulate. They always triangulate. Yeah. Well, I mean, not a measurable distance because you can't unless you can get to that distance, but you can still create. It's like the X, Y, Z. You don't have the altitude of it, so that you can't get that.
Well, the problem with what you're saying is that's not the formulation that we use to triangulate things like the sun. We say that we have an object, the sun, and these rays are coming off of it, and we can get angles to this object with these rays that we can use for a triangulation. With anti-corpuscular rays, we're not just tracking the rays. We need an object there that the rays emanate from. So what you're saying is not the same case with the sun. That is the object that the rays are coming from that gives us the angle to that object for the triangulation. So it's not even the same thing. No. We need an object there first.
My point is you would get the same effect with parallel rays. All right. So you really can't use this method because it's just flawed. There's so many things that could be happening, and you're only assuming one. You're only assuming that these light rays do meet up at the sun when it could be parallel. And I mean, and perspective could be doing a thing to them visually. So I mean, I just think it's a little naive to assume
Several
that
things look similar. And as you said, the practically parallel rays of the sun look practically parallel, but philosophically, it doesn't make sense to have parallel lines which never meet converge on the object that they come from, aka the sun. That's contradictory.
Brenda was trying to prove the globe with corpuscular rays. That's where we're at. Brenda thinks she's got globe proof with corpuscular rays, and none of us obviously agree to that.
And also, we can tell that rays are parallel because we can walk down the hallway and see the scene open up like a book, whereas the train tracks which appeared to meet open up, and you see the separation between them by walking up to them. Can we walk up to the sun and see the separation between these rays, or do they just converge on the sun?
How can you
can't walk up to them, but you can certainly view them from a different perspective, as I've posted. It's perspective that allows corpuscular rays to look the way they do. But when you're viewing those same rays from a different position, they don't look like they're doing that They don't do that same thing.
The
They
main
look like they're
problem is that they're parallel, which implies they never meet Koso. Having a sun on which the rays meet contradictory.
that they're parallel. The evidence is
Koso,
that they're
it's
indeed parallel.
contradictory to say that the rays meet on the sun in one instance, therefore diverge from that source, and saying that they're parallel in the next, when parallel lines should never meet by Euclid's postulates. That's contradictory.
That's fine, Lemon. The diameter of the sun is about 865,000 miles. It's almost 1 million miles in diameter, meaning rays that are coming from the sun and reaching the earth have no reason to be coming from the same point. So it's not a violation of anything at all.
So you're using this premise to basically buttress this idea of a huge sun with huge planet-sized parallel rays, basically.
The idea is that the rays from the sun are obviously not perfectly parallel for the reason that they are attached to the sun, so they're going to be winding out, but they're parallel enough for us to consider them parallel here on Earth. Because like I said, it's almost 1 million miles in diameter. We're only about 8,000 miles in diameter. We're only receiving a portion of those sun rays, and the rays that we're receiving on Earth are, I think, like Brenda said earlier, within half a degree from end to end on the Earth.
So we're assuming that we're getting huge parallel planet-sized rays, essentially, and using this parallel postulate to avoid an otherwise 3,000-mile high-ish triangulation of the sun, it appears. Very questionable.
Well, you can't triangulate it because your method is flawed, like I said.
All you have to do is get a 45-degree angle to the sun. With that, you would have a 45-45-90 triangle by basic math. And you get that, guess where? 3,000 miles from the subsolar point of the sun, which by logical extension means at least two sides of that triangle in the 45-45-90 triangle are equal, namely the 3,000 mile from the subsolar point side and the side that is from the subsolar point up to the sun about 3,000 miles high. Simple.
I also heard that this distance changes, though. Like this height of the sun changes, so
a much more responsible and conservative rate than the millions of miles that they've changed over 2 centuries, all the way from 3 million miles to 93 million miles.
So it's a fair point, Lemon, except for the change that's happening that Arma's talking about is necessitating change. Meaning
my refraction model.
Position. Hold on, sir. Meaning that from any position, it's not possible for the sun to be at one height there and to be at that same height anywhere else. Whereas on our model, the reason it changed was due to precision. We just got more precise with the distance of the
Your
sun.
model breaks down at 15 degrees above the horizon on each end. So you got 30 degrees of dreamland. And I have a little refraction model that explains it perfectly. It ain't that far off from the source. And just a little bit of refraction due to a moisture gradient, a humidity gradient, covers it perfectly.
We also have other problems that this model suffers from, Kosho. The local highlight that we see of the sun on NASA's questionable space photos that make it look like a small local spotlight at best. And also, in Robotham's day, sailors were saying we travel 32 miles to get out from the direct shine of the sun and finally cast a shadow on our ships or whatever. So that implies that the sun is smaller. And with the rest of this evidence, perhaps it's smaller, more local, and not that far away at all.
Yeah, but remember that one argument that I put forth to you not that long ago about the building and the sun hitting the top of the building, and for my idea was that the sun was going below the horizon and the curve of the Earth. It was completely obstructing the bottom part of the building from getting sunlight, and yet the top part of the building was getting sunlight. And that was my idea of what is happening, and you had come up with, or I don't know if you came up with it, but you put forth that idea that the sun was moving farther away, and it has a sphere boundary that the light touches or can touch.
Like a circle
and
and
that's
a
what was causing
square,
that.
basically, and the building is parallel to the ground, like the edge of the square. The circle is just reaching the top of the building, like that, like a circle inscribed in a square.
Hold on.
Right, the problem is that the problem is that that's not.
Kosho.
Hold on, I'm making a point though, man. That's why I brought it up. So
I got to stop you though, man, because if the building would have to be 3,600 miles tall.
Please don't stop. Please don't stop.
Well, do the math, dude. 1 degree.
I haven't made a point yet, man. I haven't made a point yet. The point is that if you're using the 3,000 mile sun for the corpuscular rays argument, I know that you know that same argument does not cope with the sphere boundary, the light thing, because the sun can't be 3,000 miles and do that mechanism that you just described. The square, the building, and all this stuff. It has to be much further away to do that.
Well, we still need to work some of this stuff out and see if refraction or whatever is magnifying stuff over a flat plane too. So there may be a couple places we could go with this. I think Brian was trying to say something.
Nice, Lemon.
Yeah.
Well, I think he dropped out of the chat.
Oh, okay.
Well, we're still on the anticorpuscular rays. Well, yeah, that's exactly what would be expected over a planar surface, in my viewpoint. You would have the sun, which is local, over a plane, and as it moves away, I just posted one right there. It's pretty dramatic. You're going to get a focal point of the light source, and then you're going to get the corpuscular rays coming out from that light source. And when it's setting, you've got a lot of layers of the what I would refer to as the ether. Like you have many more layers than you do when it's right above you. So that's one thing, and that in terms of why sunsets are unique in that sense. But as that sun is moving away, it's still a close and local light source over the planar surface. So when it's setting, you're going to see those corpuscular rays coming up from the horizon rather than down when you're closer to it. It comes from
not only that. Let me get this in real quick. The building would have to be 3,650 foot tall to get 1 degree of upward sunlight by y'all's own globe math.
What was that?
No, I'm saying, according to the globe math, it'd have to be to get 1 degree of upward light. You'd have to be 3,600 something and some change high.
I'll check that out real fast. Probably right.
Yeah. Think about it. I mean, just think of this. 69 miles away is 3,600 foot of drop. Okay. That's 60 miles. This is just globe math. So that shining up on a building horse shit, that building would have to be so damn tall. So if the building is only like 100 feet, you're talking about not even an arc second of upward sunlight. Well, yeah, I mean an arc second, but not much. I mean, immeasurable.
Yeah, it's all exactly, Brian. It's all local. It's all local measurements. If the sun was 93 million miles away over on a little tiny little globe Earth, it would just be a wall of light. It would just, all you would see is a wall of light, and it would light up the entire environment equally. But instead, we get these very particular angles that all correlate with a local light source.
It's funny because when I threw this math at Rumpus on Jose's, everybody got quiet, and then Rumpus had to go off and do the math, and he's come back and he's like, he's right. So they don't bring that up no more.
Well, hold on. What's this
their own math backfires on their arguments a lot.
Well, hold on. What's this wall of light argument, Geo?
Well, if the sun was 93 million miles away, that's a very far distance, and it's the size they claim, and you're on a little tiny marble. The sun, if the sun was what they claim it is, it would just be a wall of light that would be hitting. You wouldn't get local lighting. Instead, we get a local light phenomenon.
Wait, what makes you say local light? What?
Well, the angles Brian's mentioning, the anticorpuscular and corpuscular rays, the way the sun sets, the way the heat dissipates due to the inverse square law as it moves away from us. None of that's correlative with a 93 million mile sun. That's all correlated with the local light. You know how the sun, like, the electromagnetic energy, the heat from it, of course, the light fades with it. All of that correlates with the inverse square law and that close local light source.
The angles
the more
that
I look into this, man, the more I'm starting to think that it's kind of like a, what do you call it? Not a matrix, but what's the word for
simulation?
Like a realm, yeah, like a realm, a simulate. The more I look into it,
But Gio, the angles that
I
mean, it could be a simulation. But yeah, but Gio, the angles that Brian was speaking about specifically were the angles that correspond to the curve of the Earth.
Yeah, but he's right though. You look at
assumed curve of the Earth.
You see a local light as it rises and sets, man. You can see it from altitude. Go to Dan Dimensions. He demonstrates what he's saying perfectly, man, with the local the light source, man. How it cuts in on the edges like way more than the Earth curve would dictate, man. Like I said, it's real apparent during sunrises and sunsets, man.
What's apparent?
The localness of the sun and the
Could you elaborate a little bit? I mean,
man, just listen. Go to my channel, Flat Earth Test, and like 3 or 4 videos back, just glance over the sunlight. Is the sunlight? You know, I'm not claiming it isn't, but just glance over that. It's real interesting. If nothing else, man, or go to Dan Dimensions channel and look at his altitude. Look at his altitude footage, and you'll see the light curving in, like the light fading on the edges during sunset, like way faster than Earth curve would dictate. I mean, you can't even say that it's Earth curve because he's only like 120,000 feet high. So you see way off in the distance the light bending, and it's like I said, to call it Earth curve to me is a stretch.
Could you could you elaborate what you mean by the edge of the?
No, I think he was referring to like a. Well, that's the whole conversation. Is like a local. You know, is the sun 93 million miles away? What's the evidence for if it's 3,000 or 4,000 miles away? You know,
right.
It kind of concludes that it's even closer than that, man. If you look at altitude.
Go ahead, Mr. B-Ball.
I have a question. Give me 1 second. I'm gonna ask you. Give me 1 second.
Well, I was just saying, Aristarchus actually was pretty clever with. Actually, that's one reason I thought he was really clever was that everybody else in the world basically assumed that they were the same size and the same distance, the sun and moon, because they looked like the same size. But he was the only one to kind of realize that based on the relationship between them, like the positions that they are and the light that's the moon's getting, that the sun must be much further, and he was actually able to use that fact to actually find a good method to discern how much further it was.
Yeah, but that's way before that. I mean, that is all good, but it's way before. See, what we're doing is letting science get ahead of itself. So if we'd have had, you know, all the math for perspective and angles of light and the Rayleigh criterion and all that, we'd have seen that if we'd have had that science, we'd have seen that our perspective matches Earth curve, basically. What we see.
Okay, Brian.
Okay, now wait. It's another thing when science got ahead of it. So one more quick thing. When science got ahead of itself with relativity, now they're still chasing fucking fusion and shit. It's like
Brian, we're not
science
talking about
gets ahead of itself, man. They realize the sun is electromagnetic. Why are you cutting me off? I was almost done, dude. Is it that important to you,
you're
dude?
going into a whole. Let me just ask this question real quick before I get out of here.
Go ahead.
So, you and I are 4,700 miles away, right? So if it's noon and the sun is directly above me and the sun is 3,500 miles away, what angle should it be from you? Think about that.
I had to pull out my refraction model real quick.
Actually, I made a calculator. I'll probably post it when I get the chance. I made a calculator in a spreadsheet that basically allows you to think about those questions. Like you can put the sun at any height that you want to put it, and then you could put the subsolar point at any position. So like maybe let's say it's in Hawaii, for instance. That would you'd be able to you can use this calculator to see what angles the sun should be from somewhere else, or how far away it should be, from a different person.
I'd like to see that.
Yeah, I'll have to post it. It's in a spreadsheet.
Yeah.
But I'm driving, so give me about 5 minutes.
I'll tell you what, man, it makes sense. It's a lot easier to do it. Assuming the Earth's a globe, all this math is so fucking much easier. It's just an easy explanation, to throw out. Like I said, though, man, it's not proof that just because the math is in the model is comprehensible.
I mean, it
doesn't make it a fact.
Kind of leads more towards one model than the other, though.
No, it's more comprehensible. But if you think deep and you don't just accept something over on assumptions, you see that there are other explanations. The math is a little more complicated.
Simplest
But
explanation
the explanations are
is most
perfectly
likely
reasonable, though, man. Like with the sun
Brian,
refracting. Why do you keep
Brian,
cutting me
the
off every
simplest
time I go to say something, bro? It's that important that you cut me off.
You got to take your. The simplest explanation is probably the most likely. All right, I gotta go.
Okay, and how do we observe the Earth? Flat and non-rotate. I mean, that's the simplest explanation. So
yeah, only if you don't examine it at all and just accept the fact you crawl off under a rock, look around. Yeah.
No. If you have to walk 69 miles to say, hey, look, it's just changed a degree, then that is a stretch, man.
Why is that a stretch? That's how you navigate.
You may not want to admit it, but it's just as likely that the sun rays are diverging 1 degree.
because you can do that with stars too, and stars aren't that big.
Anyway, man, it was, I just had to make sense of it in my own head. So I come up with a simple reflex model.
Hey, that's Shill made a great point. Now, I guess I was thinking about it enough before to rebut that, but yeah, that's an obvious.
That's an
obvious
oxymoron, man.
No. Well, no. What he said about the sun and the angles, and we don't know if the angles are because the Earth's curved or because the distance and size of the sun or whatever it would be, being 3,000 miles away. Well, he's right though. The sun's not the only thing that does that. Everything in the sky does that.
My refraction model worked on the stars and the sun, bro. That's why I made it.
Refraction model doesn't work on the stars. You can't.
My refraction model works on the sun and the stars. They're just a little bit different height. Stars are roughly about 100 miles further.
I just have to say for the record right now, I just have to say that like Brian right now is okay. I'm not trying to say this to rag on anyone, but he's literally like dancing circles around you guys intellectually. Like intellectually, he's running circles around me. And okay. And I don't mean that to be like that I'm putting anyone down. I'm saying he's actually doing that. He's dropping such truth right now, dude. Brian, you are on fire.
No, awesome. He's not really. He's lying his ass off. He knows he's lying.
He's doing very good. But I don't know if you saw what just happened, Gio. But his main point, that one that you gave him props on earlier about the 69 degrees and the angles, that being evidence about the divergent rays of the sun and all that kind of stuff. Well, Payne Has a Shield just made a good point that the sun's not the only thing that does that exact thing. Every object in the sky does exactly that thing, like every single object.
What do you? No, they're
like
they're
not
not exactly.
The moon, everything.
I don't think they're exactly.
Oh yeah, they do. It's exactly the same. Like Polaris, you'd use Polaris. It does exactly that. You do.
They don't even do the exact. They don't even do the exact same thing. Looking north and south. If you look east and west, they're a little bit different.
No, they do that exact thing. That the 69 miles. When they change the angle on stuff, like the angles that the light comes in at, it changes 1 degree for every 69 miles. But the sun's not the only thing that does that. It's every single object in the sky that does that.
Yeah, they're all pretty close to each other, man, in my model, Just based on the humidity gradient, man.
Could you summarize what your refraction model is? Like, how strong does refraction have to be?
It's not very strong, man. It's and it stops completely at about. See, they say on the globe model that there's no refraction directly overhead. And my model, it stops at about 64 degrees. So anything even close to overhead, you're not really getting any refraction. So you don't need to apply it. But it's just, it's not as much as Earth curve. It's not as much as Earth curve. It's about 2/3 of curvature, but it explains everything, man.
Does it produce the same 69 miles per degree thing?
What? No, that doesn't have that. This is just a way of making the Polaris and the sun, like linear, like all go to the same
right, yeah,
point.
That's what I was asking. Like, does it make the things in the sky change 1 degree every 69 miles?
Yeah, absolutely. I mean, that was, if it didn't, it wouldn't be no good, would it? I got tired of hearing Sean and his Polaris challenge.
Well, you haven't explained it though, because you can do the triangulation. If the Earth was flat, you could do triangulation on Polaris, and it always comes up differently. So is Polaris at different altitudes, at different latitudes?
No, it's just refracting. When it's,
but
the closer it gets listen, let me, you ask me a question, okay? The closer it gets to the horizon, the more it refracts. Okay. Now in the globe model, they do 7/6R. They say the Earth is curving, and then they flatten it out with refraction. Okay. I bend the light with refraction. I say the ground's not curving. I say the light's curving. I say the closer it gets to the ground, the more it's refracting.
So do you have this working out? Do you have the mechanism that this does? Do you have the math or not?
Yeah, the humidity gradient and distance.
My question then is, you say it's a little amount of refraction, but like if you just do like the triangulation of it, like say you're looking at Polaris from the equator and your distance is something like 6,200 miles. If you take Polaris to be 3,000 miles up, then you can construct a right triangle. You get that the angle you have to look up is 25 degrees, but really Polaris is on your horizon.
I got it.
Yeah. Well, that makes things okay. So that would make this angle even higher. Like, how are you refracting something that's supposed to be 25 degrees up to 0 and saying at the same time that you don't have much refraction?
Because, man, it's 6 inches per mile squared, basically, is the upward light refraction.
Right, but I mean,
hold on, wait. It's 100% from 0 to 1 degrees. That's the humidity. You're looking through the 100% humidity from 0 to 1 degrees and over a flat plane.
Right. I'm not asking about the humidity. What I'm asking about is, you said it was a little amount of refraction, but 25 degrees is 50 times higher than what the globers say refraction tops out at.
Yeah, but over 6,200 miles?
Yes.
It won't make any difference.
Oh, no.
Yeah, the globe says it doesn't change by more than about half a degree pretty much anywhere.
The globe itself is what's changing, bro. The globe itself is supposed to be curving at around 8 inches per mile squared.
Okay? Right. You said that your amount of refraction was not that much higher, but
it's not even as much as Earth curve. It's not even as much as Earth curve.
Well, right, but I mean, the standard for refraction wasn't Earth curve. It's how well we know refraction.
My point was, I see what you're saying. My point was, we don't need all that Earth curve. All we need is a little bit of refraction. That's my whole point.
Right,
but you can't argue that. It's wrong, but you can't argue that point.
That's what I'm saying. What you're saying is you just need a little bit of refraction. What I'm saying is it turns out to actually be a lot of refraction.
You need a shit ton.
You know what's funny about this though? What's funny about this is that same model works out for for Miles Davis's mountains and the Blackpool Tower. It makes all that shit line up perfectly. Just a little bit of refraction.
Yeah, you just have to add a shit ton of refraction.
I mean, you would agree that if the Earth is flat, for the sun to set and Polaris to set, there would need to be some refraction, right?
Yeah, but you haven't measured that amount of refraction. You do not have that amount of refraction in air.
There need to be like a miracle.
You haven't measured 7/6R, buddy. It's
7/6R is calculated. It's observed. They've observed.
You haven't measured the Earth curve. You haven't
measured the Earth curve. You can measure the Earth curve yourself.
Matches our vision, bro.
You can measure the Earth curve yourself.
The vision of perspective. You think it's coincidence that perspective matches?
I've seen your so-called calculations on that, and you don't have any units to do it.
Why do you guys say so-called, man?
Because
why do you gotta call me a liar?
Calculation.
I can't stand liars, dude. If you catch me lying,
I hate to say this, you are.
I can't stand liars. So if you hear a lie come out my mouth, please point it out so I can punch myself in the face.
Right. What I'm getting at though, is
if I hear you on that, but let's not do the personal attack, calling each other.
I'm trying to
liars.
figure out where your model of refraction like differs from, I guess, ours, or I guess like the mainstream, right? Because we claim that the index of refraction of air is something like really tiny, like 1.008. We claim that humidity affects it less than even temperature does. Like, I mean, we've all been out on the day after it rains, right? And there's incredibly high humidity, and yet we don't see 20 degrees or higher of our vision field shifting. So I'm curious where you're accounting for that huge amount of change with just humidity. It seems like the current understanding of refraction doesn't make that possible.
I hear you. Long distance refraction is an unsettled science. Okay, so where you would say it's Earth curve, you say it's the ground bending, I say it's light bending. Okay, now let me make my point. My point is long distance observation. So according to everything I read in refraction, light not changing medium doesn't really refract. I mean, so it's kind of a stretch for y'all to. I mean, I see what you're saying, but look, the only difference is the density. You can you look it up, and the atmosphere acts as a lens. Okay, and I think that's due to the humidity. So the humidity tops off at about, I forgot, but I think it's about what, 50,000 feet, 40,000 feet or something. Okay, so that makes an angle, and that also makes a inversion layer.
Sure, but
over long distances you would get inversion. Okay,
it's a super strong lens. Like, I don't think even some like high prescription glasses bend light 25 degrees.
What do you mean 25 degrees? Are you kidding me? Hold on, 6 inches per mile squared? You think that's a lot?
I mean, 6 inches, like, are you trying to like say it bends down 6 inches per mile squared?
No, it bends up.
Bends up.
How does it bend up?
Oh, got it. Okay, so that way things that are higher up bend into our eye.
But the difference between the index of refraction between wet air and dry air is 1 to 1.33. Right. That's not enough difference to make the difference that you say.
My confusion then, like, is why would it bend in that direction if the higher index of refraction is at the bottom? Then it should be bending toward the normal. That is, it should be bending down as it goes through the atmosphere, not up. At least, standard, unless there's this like permanent inversion layer. But inversion layers are typically, not the norm.
Well, the humidity is at its highest at ground level. Okay, water vapor accounts for a lot. Okay, now that calls for change medium, just air, regular old air, just so slowly getting less dense. Okay, you look in a swimming pool. I just was looking across, like, even Olympic-sized swimming pool. There's no refraction if you're underwater. Now, if you look from the air to the water, you get refraction. So the fact that
there's a huge difference.
Wait. My point is that water vapor is less dense than air. Okay,
right.
And there's an inversion layer above the clouds.
The thing though is, like, water has an index of refraction of like 1.33, which is pretty big.
Negative.
Its index of refraction is 1.33.
Okay, yeah. Okay.
Like, that's what you plug into Snell's law. You might get like negative angles and stuff if you do the rest of it. But in air,
right.
In air, I'd say, I mean, the standard for like standard temperature pressure air is like 1.008, and I think you'd be hard pressed to get it even an order of magnitude higher to get it to 1.08 without some very extreme measures.
Water vapor, right? So water vapor is less dense than air, right? So where the water vapor cuts off, it's that's the inversion layer pretty much.
But even humid air is not going to have that high an index of refraction. It's not just because there's particulate water in the air.
Over 6,000 miles, it does. It's just a little model. Okay, it's not a stretch, man. It just bends like barely. You're talking. Listen, it equates to this. It equates to over 3,000 miles. I mean over 6,000 miles. It equates to not even,
I guess let me ask:
500 miles.
Is the index of refraction stronger or higher at the bottom or at the top?
What do you mean?
Like, I'm trying to figure out how to apply Snell's law to, let's say there's a ray of light coming from the sun at 3,600 something miles up, and it's trying to get to my eye. I'm trying to think through in my mind what path that light will take as it goes through the different layers of the atmosphere. Like, you're telling me that it would bend up, right? Like, it would originally be going sort of downward, but then it would curve to where it's going more like horizontally. But I think that would require the index of refraction to become lower as you go down. Like what you're saying with an inversion layer, that's what can happen.
Well, they say, like I said, the principles. I'm using the principles of Snell's law, but it's not really Snell's law. The principle just saying water vapor is less dense. We can all agree that water vapor is less dense than air. Okay, why would light refract in a vacuum? Okay, it wouldn't. So air that doesn't really change, why would it refract at all? Would be my question.
Right.
I think the reason they say the atmosphere acts as a lens is due to all the humidity. It's not a stretch. At least give me that.
Sure. The thing though is, like, water vapor, even if the air is saturated, like, damp Houston day after a torrential downpour or something like that, air is still not a significant fraction of water vapor. It's still mostly nitrogen, some oxygen, and then there's water vapor mixed in. So, like, even if there is this effective humidity, I don't think it'd be that strong. And I think there are even papers that say things like temperature are much stronger effectors of how refractive air is than water vapor is. I'm just skeptical that you're actually going to get this strong an effect, because what the globers say, of course this can be taken with a grain of salt, is that even over the distance to the sun, from Earth looking across a sunset all the way to the sun, which is supposed to be really far away, even in that case, they say that the maximum amount of refraction you should expect on the horizon is about half a degree.
This is what it equates to, man. It equates to about it's about 95 miles per degree. Okay, so the Earth curve is like about 60 to 69 miles, 69 miles per degree. Okay, my refraction model is about 25% more longer. So it's less than Earth. Right. In other words, we don't need to bend the Earth and curve the light.
So what is this model based on?
The Earth is flat. It's just the light.
Like that's a constant rate, right? Like,
that's a simple question, Emerald.
Yeah.
Curve the light.
Brian, is this an ad hoc? This is an ad hoc. You're basically made your model fit the data rather than make the data fit your model, right?
Well, it kind of is, but let me tell you this.
So you work backwards.
I had to do to renumber. So let me say, it's not 100% ad hoc. You can't just throw any number in there and it work. Okay, it had to be based on a certain height.
You got to cover the Earth with sugar water to curve the light.
That's exactly it, Demok. You've got the problem.
That's kind of what I was going to bring up. Not the sugar water thing, but like this rate of, say, 95 miles per degree is like, I can get that if the light is always passing through, lots of differences in humidity or whatever the factor may be. But don't we say that the atmosphere only goes, 60 miles or something up, and then there's the Kármán line, and then there's like almost no atmosphere? And if the sun is...
I don't even know why I said that. Wait. I got to correct myself.
It should be the same 95 miles per degree. Trying to tell you. Stop interrupting him. It should be the same forward. The atmosphere should be the same forward as it is up, right? Like out 61 miles, 65 miles, up 60 miles. You get it, Globers? Think about that real quick.
What? No, if I go
I don't even know why I said that. Let me correct myself real quick.
Yeah, sorry,
I said 95 miles per degree. That only accounts for 1 degree. Okay, it boils down to this: over 6,200 miles, it's about what about 15% or something like that? I had to do the exact percentage, but it's only 15 degrees over 15, maybe 20 degrees over 6,200 miles. So it ain't nowhere near 95 miles per degree. That's my mistake.
Okay, got it. I guess though, like, so the light's starting at, let's just say Polaris, and we're on the equator, so we have something like 6,200 or whatever miles.
Once you start at 45 degrees instead of the equator, because the equator, Polaris starts to cut off.
Yeah, so let's say it's 36 something hundred miles, right? Up, and then let's say we're 3,600 miles
3,100.
3,100 miles away. And so it should be at 45 if there were like no refraction or whatever. My question though is like, you know, the light from Polaris starts at Polaris, right? So it's at 3,100 miles up from the Earth. At what point is it going to start being refracted? Because like I don't think either of us would say that there's that much humidity.
It starts being refracted at about 64 degrees latitude, and it's very slight. It's very slight.
I mean, like physically. Like at what point in its travel from 3,100 miles above the surface to my eye does it encounter, I guess, enough atmosphere to start refracting that 15 degrees or something?
Well, the stars disappear at about 12 miles, man. I mean, according to a lot of astronauts and according to a lot of other people. So why would you know, the miles of altitude is insignificant. But let me make this point. Okay, so the linear model, hold on, the trigonometry of Polaris.
No, which
astronauts? Not that
You
far
claim
off.
astronauts. Which ones?
How about Neil Armstrong, Michael Collins, right when they got back?
Okay, so provide the evidence for that, actually, instead of just saying they said that.
Leo, I don't think they went to the moon. Leo, I'm just giving you a hostile witness. I don't think they went to the moon. But so them saying they didn't
but that's beside the point. Give me any evidence that they actually said what you're saying they said. That's what I'm asking for, Brian.
Michael Collins said he didn't remember seeing any stars. Why are you butting in a perfectly rational? Look, let me make my last point about the refraction. Okay, so the linear model, the trigonometry, is not that far off from being linear. You know, it's off a little bit as you start getting further. It works good up to a certain point, so it doesn't require that much refraction. Brandon, let me make this last point. Brandon had an answer, an explanation, pretty good one, with just perspective and linear lines. So I advise anybody to go listen to his presentation about a couple months ago on the angles to Polaris and whatnot.
Perfect.
Right.
Now you can provide the evidence that Neil Armstrong and whatever his name said what you say they said. I don't care if they're lying or not, but I just want the evidence that they actually said that. Show me.
Well, I've only found stars in 2 high altitude balloons, and they didn't make it much past 65,000 feet. They were like half mid altitude stars. Okay. So maybe the camera wouldn't pick them up. Maybe it would. Maybe they would. Maybe they wouldn't. But I'm just giving you evidence from your own team. Michael Collins never stepped on the moon. He just kept circling around it, and he didn't remember seeing any stars at all. So I'm just giving you a critical.
No, we're talking about refraction, and I want you to provide the evidence that they agree with what you're saying about refraction. I want you to provide the evidence that they actually said that.
Dude, I don't know why in the world would they agree with my refraction.
Then why are you quoting from them? You said they said something. I want the evidence that they actually said that.
You must not have heard, Lale, because he mentioned elevation. Like he asked about elevation and how it would apply to elevation, and you'd have to go real high, higher than any of us can go. So let me retract that, and let me insert that. Okay, none of us can go high enough to make any difference in the model.
Okay, so provide the actual quotes where they said that. Show me. Don't just tell me they said such and such. Show me.
What did I said? Do you want me to show you?
Whatever you think they said, show me that. Instead of just saying they said something.
Well, you're being ridiculous in my eyes. Does anyone else agree?
Brian's saying someone said such and such.
You don't even know what you want him to show you though. Now.
Go look at the interview their first interview when they got back, and the question was asked.
Provide that interview for me.
Okay, I will provide it for you, Lale. I'll provide it for you if you'll go away after I do. Okay, you're being rude. Okay,
and they'll say
when they got back, in the first interview, they were asked, "Could you see any stars between the Earth and the Moon?" Neil Armstrong said, "In space or Sicily, which is the area between the Earth and moon that he couldn't see any. He don't remember. He said he thinks he might be able to see planets. He's heard that before, but he's never seen any personally. He said, and then Michael Collins said, I don't remember seeing any.
Okay, so provide the evidence that they said that then. That's all I'm asking for.
You've never seen that, Lil? No wonder you're a globe earther still.
Yeah, wait.
If Michael Collins did say that, wouldn't that make you relook the whole narrative that they've gave us? So why should I give it to you then, man? You're being unreasonable.
Can I tell you why? Because I believe they went to the moon, and they would probably in that you're cherry picking the entire quote. If they quote, I want the entire quote, including the reason why they couldn't see the stars.
You're breaking up, Lyle.
What?
I don't believe any of that, Lil. I don't believe any of that. But even if I can prove what I just said to be true, it wouldn't change your outlook or even have you second guess it. Why should I go get it, man? You're not making any sense, man.
I don't care if you believe it or not, or if I believe they actually went to the moon or not. It's a fact. They said what they said. I want the entire quote, including the reasons why they couldn't see the stars.
That wasn't addressed. They didn't ask why, I don't believe, to my knowledge.
No, but
Can anybody back me up on that? Is anybody in this room, I got to take a break anyway, but can anybody take over and also back me up that Christopher Collins did say he didn't remember seeing any referring to stars?
But did he say why? That's my question. Provide the evidence that he said that, and then I want the entire quote.
Well, that's what's baffling, Lil, is that they didn't give any explanations on why. So if they'd have given an explanation on why, you'd have a point to argue, okay? But they didn't give an explanation on why. So how could you even argue it?
And what did you say, Terry?
I was just saying you're breaking up a little bit earlier, but are we talking about when you're out in space, whether on the moon or even on the ISS, and if you're looking out the window away from Earth, you're not seeing stars? Or you're not saying you're seeing stars?
No, that's not what I'm saying. I was making it because people keep on muting me.
Oh, okay.
I predict that if they give me the whole entire quote, and not just
if we can get something that was said, or a video that him having an interview, or
I could quote it almost perfectly. When you're in space, could you see the stars despite the glare of the solar corona? Neil Armstrong said, I didn't see any stars in space or Sicily, which is the area between Earth and the moon. But how about you guys? Michael Collins said, I don't remember seeing any. And then Neil bumped him, or he said something to him, like he didn't say nothing verbally. You see his mouth moving, like, shut up, dipshit. Maybe he was saying that. Maybe he wasn't. That would be speculation. Him saying he didn't remember seeing any.
It was body language that indicated for sure that it was one of the things that clearly they had both been instructed to not, mess up saying, So it was definitely like a wink, wink, like, watch it, dude,
I have heard Globers say that since there's no atmosphere is why we can't see the stars, and that you need filters.
Maybe their concentration was so focused on what they were doing that they didn't even think remembering what they saw. It's like when you're driving a race car down a race track. How many people are in the grandstand? You go.
It's like training your whole life to go see the sunset in Brazil, and then getting to Brazil.
That's okay. Don't talk over me. I hadn't finished my sentence yet.
Yeah, but you're saying something that is so ridiculous. They went to space, and you don't think they would look at the stars? Come on.
They went to space. They landed on the moon in the daytime, so you can't see sun.
They
can't
were
see stars in
in
the daytime.
How many days
Michael
and nights
Collins,
were they on the way
Michael
to the
Collins
moon?
never stepped foot on the moon. Sorry, David.
It's being ridiculous. That's a ridiculous argument.
Apollo 11, they were on the surface for 8
Hey,
hours.
that's why I brought up Michael Collins, because he
You're
didn't
talking about
step
the
foot on the
glare.
moon.
Yeah, I know what you're talking
He's
about.
the one who said he didn't remember seeing any. He never stepped foot on the moon. He was circling the moon the whole time, according to the narrative. That's why
Did he give a reason why he didn't see any?
because they didn't go to the moon. Maybe that could be one reason. Another reason could be because they needed filtration, which kind of.
Oh, so you're choosing not to give the entire idea, just
He didn't say all that. That's my idea, Lael. All he said was, "I don't remember seeing any." Lael, look up Apollo 11 interview after. It's everywhere. It's literally everywhere. It's the first interview.
He's seen it at Jose's like 50 times.
And the other astronauts, half of them say, "Yeah, the stars are everywhere." And then the new ones, there's other astronauts who say that that you can't. It's a black void, an eerie black void. And I think it would be an eerie black void because that's what we see from all the amateur footage. I can't speak for them 100%, but I've seen so much different amateur footage that once you get up above the stratosphere and it turns black, it does look like an eerie black void.
Yeah, the Hubble is up there taking amazing photographs.
Sure. It's just we're talking about the astronauts that some say they saw stars and some said they didn't. That was his whole point.
Aren't they wearing some sort of filters on their helmets that actually filters out very dim light?
I think it filters out some of the sunlight, but that would be a slap in the face. Why would you need a filter to see photons that travel best in a vacuum?
Wouldn't it be more enhanced?
Yeah, well, that would be why you'd put Hubble up there, ain't it? Because it would be way better. But that's Hubble is. Can you prove Hubble's up there? The director of the Hubble program couldn't even prove it. Okay, if you listen to Robert Bassano, he called him, had a long conversation with him, and he can't even show you photos of Hubble.
Hubble is up there. They
all also said they couldn't even tell the people behind the computers at NASA. It said it was no different from a drill when the actual moon missions took place. That they had did it so many times they couldn't distinguish between the real thing and a drill.
Except that Apollo 13 blew up halfway. Except that Apollo 13 blew up halfway to the moon.
Yeah, they made a movie about it. Tell me the difference.
After 20-some years.
How can you tell the difference? By the actors?
Oh, you think it was faked, huh?
What do you think?
It was like they went to the moon and faked the disaster halfway there.
That wasn't my question.
Everything I own. I'd bet everything I own.
Why would they do that, Rocky?
How would you tell the difference?
Why would they do that, Rocky?
Now you're asking me a question. Fair enough. As soon as you answer my question, which is how would you know the difference, I'll answer your question. Fair?
Because technology to do something.
Is that paid NASA shill with a voice changer? Or is paid NASA shill avoiding my question?
Paid NASA shill is saying you're asking a really silly question.
That's what I thought you would say, script.
Yeah.
That's what you always say. You go by your script.
Silly questions.
I'm fine with that. I'm fine with that.
You ask a bunch of really. I'm not going to use the other words I often use.
I'm fine with your answer. Thanks. Have a good day.
Now answer my question. Why would they do that?
I'm not going to answer your question. It's silly.
Okay, fine.
What's up, Issa? Sorry to call you out, but I'm not trying to call you out if you don't want to speak. I just wanted to say what's up. If you don't want to speak, definitely just sometimes.
You're good, brother.
Well, I just didn't want you to feel obligated that you had to. I just wanted to say what's up, just shout you out.
Okay, I know you're good, actually. I was just here cuddling with my dog. I was funny because I was like, oh, there's a little puppy. You know what I mean? And you're like, hey, what's up, Issa? I'm like, oh, no. Right on. How y'all doing?
Pretty good, man. It's been quite a day. We had Rumpus and Witsit which I don't think I've ever heard those two talk before. So today they had a hour or so conversation. That was interesting. And Rumpus didn't completely lose it. I mean, he held through all right, actually. So it was good.
Well, you got to remember, Rumpus is performance art, man.
Yeah.
You got to like I look at him like, he's just, and he's brilliant. Like, you know what I mean? He's so good. Like, God, like.
Pure entertainment.
He didn't utter anything.
Him and Brenda
He didn't, yeah, you know what I mean? Like, it's, come on, dude. Like, he's, him, like, dude, there's a couple of ballers. And, like, if they're sincere, then, like, God bless their heart. But if they're, like, genius, like, provocateur actor types, like, they're fucking genius.
Dude, speaking of that, so we found a YouTube channel, or no, sorry, it's a what is it? A BitChute channel of. Do you remember that guy Human Sheeple, Issa?
Familiar with the name. I never really got to know the guy. I don't really know.
Okay.
But I know there was a lot of swirling around him. There was a lot of stuff going around the brother. I don't know what happened now.
I used to be a mod in his server, the Ice Wall.
Right.
Oh yeah, Jeremy. I think that's actually where I remember you from more is Icewall. Yeah, more than 24/7. I feel like, because I actually do remember. Yeah, I remember seeing your name as a mod there and stuff, because I was a mod there as well. I think at some point, and I was like, oh, who's this guy Jeremy? But I don't think I knew you that well. But I do remember your name now that you say that on that server.
I used to talk to them guys a little bit. They were into like video game. I don't know. They were always playing Minecraft.
What do you guys? You know his accent, like that. That like.
Oh my god, I couldn't even understand that, dude.
All right, so check it out. We found this BitChute channel, and it's Human Sheeple, but he doesn't have that accent. He's speaking in like a British accent.
No way. That was
not
a
even
facade
kidding.
That was a facade the whole time.
That is what. Well, I mean, we're not. I guess it's hard to be 100%, but we were comparing. I mean, I'll send you the channel. It's absolutely unbelievable. I mean, when you look at his actual Human Sheeple YouTube channel is still up, so you can actually go there and watch like his videos still and compare them. And one thing to note in those videos, the one on the old Human Sheeple, his daughter has a British accent. Like his daughter doesn't speak in that Cyprus.
So wait, you're saying on the Human Sheeple's videos when he's a Russian guy, that you can catch clip snippets of his daughter speaking with a British accent.
Well, he's from Cyprus is where he said he was from. So he's doing this, Cyprus accent. But yes, in those videos, he's doing the Cyprus accent, and she speaks like in a gentle British accent. And at one point, like I feel like she's like looking at him when he's doing that accent. Like you can see in her face, she's kind of like, it's like to her, it's like, because kids are so like expressive like that.
So hold on, Human Sheeple's in the video doing a Russian accent, and she's speaking British.
Well, it's Cyprus. It's not Russian, but yeah, yes.
What Human Sheeple speaks?
Cyprus, yeah. It's the island of Cyprus.
Oh, I thought it was like Russian or something. Sounded like hardcore Russian. I thought he always was.
Well, I mean, it's the accent is probably somewhat different, somewhat similar in some ways. Like I know what you mean.
Yeah. What I would say is like you could lose your mind, trying to like decipher whether or not someone is or is not somebody else.
You could tell, man. Hold on, it ain't just him. You could tell, man. Listen, I heard Grant Bro Sanchez the other day in a voice changer, man. I hear people quite often, man. And,
right, but the point is that just because you think, like, and I'm just saying this after fucking 6 years of experience or whatever it's been, is just that, I would just recommend, like for me, like I almost like off of a principle, not that my spidey senses aren't fucking tingling all the time, but like as a principle, like you treat everyone like they tell you who they are. You know what I mean? In the sense of whatever, but don't be naive. But I'm just saying, like, just like, I'm just saying you could get lost in that line of thinking, dude.
No, I do hear you. I hear you on that, and I agree, which is why I don't like spend that much energy on it. However, in this case, like this guy was such a character on that 24/7, all these servers, like speaking in that accent all the time, being super dramatic about it. I always felt like the accent was a little bit shady, even back then. I was like, it just seemed like he was pushing it. But I just thought maybe he was being a little bit inflection, a little bit stronger, maybe just kind of try to troll a little bit or something. But the thing is, he has this BitChute channel. It's called Human Sheeple. It has the same profile pic. The description is classic Human Sheeple. Like, I don't know, he uses the N-word and talks about Hitler. Like, it's just the way he is, like what he wrote. And it even says in there, it says, the earth is not flat, but it is mostly level. And after he
Get the fuck out of here.
I'm not kidding, dude, because after he took over that whole 1.0 24/7 server, he turned it into, he called it, what did he call it? Yeah, mostly level, right?
Yeah, that was like one of the tags in the ice wall, mostly level.
You got to remember too. A lot of people are like, here's something you got to remember, dude. Is that people even that, depending where you are in any of this grand fucking awakening or whatever it is you want to call it, is like, like people realize like flat Earth is a psyop term. So like, to use that term in a certain sense, like is to partake in this, like, psyop. So people look for ways around it, like alternative cosmology and such, which isn't a bad idea, to be honest. But like in the same stroke, just like some people really won't use those terms because of those reasons. You know what I mean? I've found in my journeys out here, because I really don't know the guy. I don't know that he's, I don't know what he was integral as a part of. Forgive me. You know what I mean? But I know that there was like some drama swirling around some people. I think he thought I was a shill. Like, you know what I mean? Whatever.
Oh yeah, he was a wild character. Yeah, he caused an immense amount of disruption and chaos on multiple levels, accumulating in the ultimate thing where he somehow, well, I mean, we know how he did it, but he essentially acquired ownership of that 24/7 server, the first one, when it had 32,000 members, just under 33, which I'm not trying to necessarily say that there's a connection there, but it's kind of weird.
I remember that was like a big deal or something when it happened. Like it was like a takeover had happened, and then everyone moved channels or something like that for a second. And then, I mean, like, or like, people that were mod statuses got like whatever. I mean, honestly, dude, like I used to fucking light up a Discord and have like, I don't know if anyone's here to even verify who's around, but like, I would light it up, have like 100 people in it and destroy it all the time and make like a new Discord for a show. Like, you know what I mean? And like, I don't know. I just don't, you can't get into the drama of these fucking apps and shit. Like, you know what I mean? I mean, like, what sucks is that control level. And that's what's crazy when you start getting into stuff like this. You got to remember, people are interested anytime you get large groups of people together. Do you know what I mean? Like, all kinds of people are interested in that.
For sure. I hear you.
But I mean, like, yeah, that's crazy though. And you know what I mean? That's crazy though. I wouldn't be surprised, bro. That's why I said, like, when I hear like Rumpus speaking, I hear like a fucking a collegiate master at work trying to disrupt as much as possible. I mean, the dude's name is Rumpus, dude. Like, it's the whole. It means cacophony.
Right, exactly. Yeah, like just
like, you're playing, and actually, what's crazy? It's an actual art form. It's called, like, to some extent. Like, I find it fucking hilarious to some extent, also. But like, it's this concept, and this is where I don't like some of it. Is that it gets a little deranged in the sense that it enters into absurdism, and absurdism is kind of meant to be like this, like, I don't know. It's like a way of pushing you so that you have nobody to lean on but yourself. So there's like nobody to trust.
Here's some of Rumpus's absurdism. Okay, he says that if at the equator, if the globe slammed on brakes, this is my argument too. I can't believe Pete brought it up earlier, but he didn't bring up the whole argument. He stopped short. But if the Earth slams on brakes, then you fly off at over 1,000 miles an hour. Okay, then if you were at the North Pole, you wouldn't fly off at all. But you only lose a few grams of your body weight. It's insanity. So you're saying that gravity? What if gravity clicked off real quick? Then what would happen? You'd have to fly off of it.
Well, dude,
It only
he's so
accounts.
like, and this is why I find him hilarious, is that you're still over here rambling on about the musings of somebody who made that up in fucking 3 seconds worth of thought to answer some question that was posed to him in the heat of debate. Like, the dude's brilliant, and like, you got to realize that at some point, I think.
Well, I think he's very, very like, yeah. Well, in terms of this mainstream model, like, you can become like somewhat an expert on it, because all it takes is like reading information on government websites and wherever else, quote unquote science, different things that, NASA found a new planet, like whatever it is. And especially getting into like, Al-Biruni and Copernicus and all these guys, like, it's a whole narrative that you can read about and learn about. And so Rumpus to me just seems like a very, very learned guy, man, in this field, basically. Like, he just, whether it's just a hobby of his or whether he just has looked into it to a degree. And then he defends those points, with such a full belief, even though a lot of them he doesn't really have proof for, but he will push them and say statements like, we know this, and all the scientists know this. And so he does a lot of that stuff. Like, a lot of the, the scientists have all done all this and figured it out, trying to like debunk people that way by just using this kind of like the scientist thing. So he does that a lot.
But that's like, and look at it like, I mean, honestly, it's like a script to an improv actor. And so the improv is, the subject matter, like, you have the subject matter, and then you have the improv entailed with it, which is whatever question some silly flat earther is going to ask. You know what I mean? That's what's interesting about any of this, is that, like, it's like, I mean, the debate is for like fleshing the ideas out, which is awesome, because everyone should do that for themselves. But at the same point, you come to your conclusions at a certain point. And I just think it's interesting. I don't know. I find, you know what I mean? It's like the Rumpus inspires flat earth. Like, you need that. You need the Rumpus. You need your gem. Like, unfortunately, there comes a whole bunch of baggage with all that. And I try to romanticize it all, but at the same time, like, recognize where you are. It's the internet. It's like, it's weird. There's like all kinds of games, and like in that sense, and it can be fun, but it can also be like fucking weird.
The knowledgeable globers like Rumpus, they know deep down there it's flat, or they know that it's a high probability that it's simulation or an infinite plane.
Here's the thing, though. It's like, it's kind of like, here's the thing with any of those cats, and this is why I say about making presumptions, like, oh, this person sounds like so-and-so, so it must be so-and-so. It's like the idea that, like, we're the ones posing the question that we don't know because you can't know, right? Like, we can't know what the stars are because you can't go there, but you can, you know what I mean? You can estimate, but your estimates aren't really it. Like, you know what I mean? We're the ones proposing these ideas. And when you start to go to the fact of, like, drawing conclusions of what these people's motives are, it's the same kind of thing, because you really can't know. And that's why I said,
it gets on my nerves, though, man. They ask for all this stuff. They ask for all this stuff. When we give it to them, they just ignore it, man. Like just earlier when I was talking about Michael Collins.
That's why I started off by saying that if you get lost in that rabbit hole of whatever, you know what I mean, you could lose your shit. And like, and that's their goal to some extent, because they think that's hilarious to some extent. That's why I always felt like with flat earthers, like, I always felt that, especially early on, before channels like this, even, like, we're like 24/7, even places that were like a soft landing for someone who's going through this mind fuck of quote unquote flat earth. Because you have to have, like, I thought, like, I did that back in the day, is what I thought, because all I saw was chaos. It was like everyone was being pushed into these groups, and this weird fucking, just was weird. And there had to be a simple place where people weren't going to be ridiculed. Like, I don't know, I could be harsh and funny at times, but like, generally it's like, I wanted there to be a soft landing, a place where you could actually exercise these ideas without being crucified for them. You know what I mean?
Absolutely. That, I would say, it describes one of the core sort of visions that has been in my consciousness. In terms of this platform being able to be a place where we can actually have discussions without all the personal attacks and chaos and be able to actually hash out the ideas.
It shows, man. Like, this place is like, I wouldn't come here if I didn't feel that way, to be quite honest. Like, and I like, and I enjoy the debate, to be honest, because I can be a dick. Like, you know what I mean? If you're going to come in and we're going to wage war over these ideas, like, that's fun to me.
Oh, hell yeah. Let's
You know what I mean?
go.
Right. But like, and it's like, and I might be a dick. It's like yesterday, I think I offended some dude, Funk or something like that, because I was like, and I remember because I was like, he's explaining something about gas pressure. I don't know what it was, but I was just like, I said something about like, after you say all that stuff, you know what I mean? Do you ever think to yourself, damn, I sound retarded? And he got really worked up about it and fucking left the call and it like killed the call. I felt horrible. Because I can I enjoy that shit. Like, you know what I mean, with whatever. And that's why I know Rumpus. Like, I love Rumpus. I've had him on my channel 1,000 times. We'll never agree because Rumpus won't agree with anyone. In fact, I had this guy, Professor Phil, on. Me and Cathexis had Professor Phil on. We had Rumpus on, and he came on with all this shit. We were talking about it, and then this guy, Professor Phil, that Rumpus looked up to, came on and verified everything that we said and wrecked Rumpus, but Rumpus still wouldn't concede to his friend. And we were dying. It's hilarious to me. That's how I've come to look at it. It's like Rumpus just is not gonna. He's just gonna be the abrasive person that he's come here to be, and God bless him for it because he ruffles the feathers and inspires something in somebody.
Well, he's usually correct.
Like you probably have been inspired by Rumpus, right?
Anyone?
What are you high right now, Issa?
What's that?
So what are you high right now?
Oh no, man! I'm actually tired. I'm ready to go to bed, but you guys caught me. I might have to get high.
Rumpus reminds me of like one of the old English, like the old British, like when they're talking about, no, the sun is 1,000,000 miles away. That's science. We know that the sun, and there's phlogiston. Look, there's phlogiston in every type of carbonate with wood. Anything that burns has to have phlogiston. Science. We know this.
Yeah.
No,
but what I'm getting at, they're so scared to change. It's the old English people. Any new science is just thrown out because they know science knows.
What would we change to? What would we change to?
You know what I'm talking about, Brandon, in the movies where they threw out all science. They threw out all new ideas because they're so set in their ways. The old English, the committee.
But you don't have new ideas. You don't have new ideas.
Royal Observatory.
You have old ideas. Flat Earth is an old idea.
Well, the stuff about the optics appears to be new territory. Bottom-up obstruction due to refraction, diffraction, or something optical. That appears to be new territory that has been broken.
Us living in an electric theory. They didn't know that there was a 100 volt per meter increase back when they made all these theories about the sun and all this shit and just gravity theories.
Mm-hmm.
Like I said,
Don't know what are you talking about? 100 volts. I don't know what you're talking about.
The atmosphere gets more electric as you go up, Brenda, by 100 volts per meter as you get higher and higher up. Also, the flat Earth appears to touch lightly on the ether, being the thing that's swirling over the unmoving flat Earth and giving us these gyro drift, these pendulums, Coriolis, or whatever the hell you're talking about, possibly. So it could mean a Renaissance revival of the ether, the energy of space itself going around objects like you and me.
Yeah, that's just all stuff that's been long ago refuted. These are all old ideas.
So no more advancement in science, Brenda, unless it comes from the gatekeepers in the science field. Nothing from the laymen like you, me, and others. Just shut up and take their pronouncements unquestioningly. Is that what you're saying?
No, there's plenty of advancements in science all the time.
Well, everybody has their own unique way of perceiving reality and what, it's interesting, like what people consider as evidence or as valid evidence, whether people do experiments or things themselves, whether they use other capacities, to decipher truth and reality. It's interesting how we all have our own unique perspectives on it.
But that's not science. That's mysticism.
Well, I'm not part of any scientific cult, so that wouldn't really relate to me.
Hey, what's up, Brenda?
Science isn't a cult.
Well, yo, Brenda.
Hello, Isa.
Hey, how you doing? I was wondering, do you think that like the creation story of modern day cosmology is borderline mysticism?
There's no creation story.
What do you mean there's no creation story?
The Big Bang.
Yeah, there's no creation story.
Isn't that a creation story?
No, it's not.
What happened before the Big Bang?
Nobody knows.
So, from as far as our perspective, the creation story would begin at the Big Bang. No,
there's no creation story. The Big Bang is not. The Big Bang is not a creation story.
It sounds like one.
Whatever, but it's not.
Right, but it sounds. You could agree that it sounds like one.
No.
Well, I thought you did there.
You talk to modern physicists, they'll all tell you that we don't know what happened.
You gotta tell them no.
Before time. We don't know what happened.
You want me to shake it up?
No, it says don't shake it.
You got a hot mic over there, Jeremy.
Oh, all right.
They'll all tell you that the Big Bang is not about the beginning of how the universe began. We don't know. It's not about the beginning of the universe. It doesn't go to time zero.
Well, could you say that us coming from monkeys is like a kind of a creation story?
There's no theory that says that humans came from monkeys.
Did we not evolve in some way, or what was the?
Yeah, but we didn't evolve from monkeys.
What did we evolve from?
Another primate species.
Is there any evidence? Is there any evidence of that primate species?
Copious. There's dozens and dozens of fossils.
Okay,
we found recent Afarensis fluoriosus. We found many different hominid species that lived at the same time as humans, right?
They're like artifacts of your creation story.
It's not a creation story. There's no creator in evolution.
Well, right, but whatever it is, evolution's creation theory.
Well, evolution doesn't have a creation theory or story.
The story of origins without a creator.
That's a good. Yeah,
that's right. That's right. There's no creator. There's no creator. There's no plan. There's no purpose.
No plan, no purpose. How sad.
That's right. Well,
there's no creation stories. It's like arguing with a brick wall. There's hundreds of stories of creation. How could you say there's no story? You can say that they're not accurate or you don't believe in them, but to say there's no stories is just I don't know. I don't want to I don't want to say what I think.
I did not say there were no stories. I said the science of evolution is not a creation story.
Because creation implies purpose, things that imply a creator, and evolution doesn't appear to have a creator, and neither does the Big Bang. No purpose, no person.
That's correct.
Nothing personal.
Yeah, there's
if
no.
Anybody wants to check the
tapas.
honesty of Brenda, if anybody wants to hear the honesty of Brenda, go to YouTube and rewind it back about 3 minutes. She said distinctively, quote, over and over, there is no creation story.
That's what I said.
There is no creation story. You said
yes.
it exactly over and over.
Yes.
And I tell you that there are stories. There are several creation stories.
No, there are not. Are you not able to track a conversation? When you say,
you know what a story is, Brenda?
We were talking specifically about evolution, though. That's
yes, I was talking specifically about evolution, and then Brian changed it into something else.
No,
I'm confused about what he was talking about.
You're fine, Brenda. I got you.
I'm gonna point out liars, and like I said, when I asked him earlier to point out if I lie, and so I could correct myself, I can't stand liars. and you just blatantly
I did not lie. I did not lie. You misunderstood me.
You said there are no creation stories over and over. Then you said I didn't say there's no creation
Hey,
stories.
Brian, we were just talking about her, like the particular modern. Like,
Evolution.
how about this? What I consider to be the modern creation story, even though Brenda says it isn't a creation story, I propose it may be. Just because Brenda says it
Yeah.
not Brian, doesn't mean it's law.
Well, every evolutionist will agree with me and disagree with you. It is.
Well, every evolutionist, I tell you what, every creationist might agree with me, though, right, Brenda?
Yeah, but that's a religion. I'm talking about science.
I'm just saying, we've got our
Before Big
team.
Bang was even brought up, you brought up a reference about a creation story, and she's led with over and over. There is no creation stories over and over.
What we refer to as the creation story of the modern era, she refers to as science.
Yeah, that's what evolution is.
I was just pointing that out. I was pointing out that there are stories, whether you believe them or not is up to you. Then she said, I didn't say that.
Right, I didn't. I was talking about evolution.
So you got an opportunity to correct yourself and say, well, I meant something different or anything.
I already have corrected you.
You didn't say it.
I have already corrected you.
If the audience who last pointed out, this goes out to them. I'll drop it.
Get the cotton out of your ears. I was only talking about evolution. I was not talking about other creation stories. I was talking about evolution, which is not a creation story. It is a scientific theory about the origins of life on Earth. Well, not the origins of life on Earth, the origins of species.
Yeah, she was talking about within the context of evolution. There is no story that goes with it. There is no creation that comes from it.
Thank you. Thank you.
Go to my channel, Flat Earth Test, and tomorrow I'm going to make a video pointing out your blatant lie. I'll give you one more chance.
Okay, hold on.
Hold on. Before evolution was even mentioned, or before the Big Bang was even mentioned, you said to his response, he was making a reference. You said there are no creation stories. There are no creation stories. Over and over.
I said
evolution was even a topic. So do you want to correct yourself or not?
I did not say there are no creation stories. I said it, referring to the Big Bang, is not a creation story. It's not a creation story.
Okay, there are creation stories then, right?
In religion, not in science.
Yes,
Okay.
yeah. The Big Bang has evolution has creation stories, right? Because you didn't have a tiger. Hang on.
Evolution is not a creation story.
Brenda, I'm talking. Control your little micro. So, creation means, don't interrupt. Creation means there was something was created. Now, with evolution, I'm air quoting here. There weren't tigers, and then there were tigers, right? It has to account for the creation of tigers. Now, how does it account for that? What's the story it tells? The evolving of a whatever into a tiger. So it does have a creation story. One, you're not there to witness.
That's false. That's false. Right. Creation implies intentionality. Nature does not have intentionality.
Well, hold on. What does mitochondria do?
Mitochondria is it. What is it? It creates ATP, which is energy for the cell.
Right. So that's a creation story.
What?
Right?
Definition.
What are you talking about?
Two definitions here, so we're having ambiguity. One is Brenda's talking about intentionality when something's created for a purpose. That's one definition. The other one that Right the Hand is talking about is something didn't exist at one time and somehow came into existence afterward. How do we account for that origin? So we have two different definitions of creation here. Please keep that in mind. I'm
simply rejecting the labeling of evolution as a creation story because that is misleading. Because evolution does not posit a creator or any intentionality, purpose, or telos to life on Earth.
So no purpose, Brenda?
That's correct.
What's your purpose? What's your purpose on Earth?
What I give to my life is what I create my own purpose.
What's your purpose here?
My purpose here?
Yeah.
To have a reasonably decent time, talking to people about flat Earth type topics.
Yeah, but if your life is built on no purpose whatsoever. You were created for no purpose. Then what's the
Well,
purpose?
I told you my purpose here right now is to have a good time talking to people about this.
Purpose? If you're created with no purpose in mind, like, what would be your purpose?
I have
Why would you
multiple
even have
purposes. I have multiple purposes depending on the situation. So if I go to classes, my purpose is to get good grades in class. If I go to the kitchen, my purpose is to make a delicious meal. If I go to the bathroom, it's to have a good bowel movement, right? All of those things are purposes. If I go to sleep,
if no creator gave you no purpose, then why do you have purpose? I don't get it. Where was
give my life.
Did purpose evolve?
I give my life purpose and meaning. I give myself meaning. My life. My life.
You have no purpose in life.
No, I do. I give it to myself.
So you can give yourself something that nature can't give you. You have a power that almost a godlike power that nature does not have, namely the ability to find purpose in telos that nature does not have.
Yeah, you're asking why questions.
No, I'm not asking you. I'm asking Brenda because she's passionate about
why questions though.
And I'm still asking Brenda, not you, Peyton Shield. So Brenda, do you think you're a god?
No, I don't think I'm a god.
So how do you give yourself these things? Like, where did it come from? Like, where did it evolve from?
I don't know how consciousness evolved. I don't think anybody does at this point, right? But
maybe it was created. Like we see every other thing, right? I didn't mean to cut you off, but we see every other thing, like, in computer programming, anything,
by people,
simulation, everything, right, are created by something, by a creator.
By people.
You keep interrupting and inserting people, but it's a creator when you get down to it. Yeah, a creator. Humans that created.
Yeah. Humans can create.
A creator. We can agree that it was a creator, though, because I see why you're trying to just say people with no purpose or creating things with no purpose, but
people have purposes.
But my point is that everything we see with our non-purpose life being created is by the creator of that object.
No, that's not true. We don't see that. What we see is evolution. We don't see creation.
No, I'm talking about what's by people. Everything that's created has a purpose, and it's created by the creator.
We don't see that.
So you don't think we can deduce, because every human that's ever created anything is the creator of that creation, and they did it usually for a purpose, right?
I don't dispute.
So don't you think we can deduce that everything created has a creator?
No, I don't think you can.
That doesn't logically.
It does not logically follow. That would be the composition division fallacy. Yes.
So what logically follows is that everything else besides what we see humans create for a purpose has no purpose and wasn't created by a creator. That's your logic.
Yes.
Okay, cool. Thanks.
Yeah, the universe has no purpose. It doesn't follow that organisms in the universe cannot have a purpose. They do. And other things besides humans have purposes.
Yeah, everything has a purpose. Everything was created by a creator.
Well, they have things that have agency. Things that have agency are able to direct their desires towards an end, which I would call a purpose. So I can direct my desires towards an end. So if I get up from the chair and go over to the sink to get a glass of water, it's because I have a purpose. It is to drink a glass of water because I'm thirsty, and
because that's how the creator did it. He created.
No, it doesn't follow. It doesn't follow that there has to be some kind of universal purpose.
Because if not, you wouldn't need water. If you had no purpose and you weren't created for a purpose, and that water wasn't created for a purpose, you wouldn't need it.
Oh, what's the argument for that?
Everything is logically deduced.
Well, what's the argument?
Needs everything.
So
from
good.
the
What's
very smallest cell
cool?
to the
Cool.
microorganism
Yeah.
down to
What's
every grain of sand has a purpose.
yeah? Okay. What's your argument for that?
Means to an end.
What is your argument? You've made a claim.
Oh my goodness.
What is your argument for it?
Yeah, you've made several claims that I mean, I don't know what your point is. I'm saying every creation we've ever seen has a creator. So
Yes,
why would
you've repeated your.
you
Repeated your.
Yeah,
you've
and you
re-
interrupted me the first time I said it, and the second, and the third. So I'll say it again. Logically, if every time I see something created, it has a creator, I would logically deduce that every other thing that I didn't see created has a creator.
That doesn't follow.
Well, it follows to me, so it does follow, right?
No,
You're
it doesn't.
making a mistake. This is not a unique thing. This is the watchmaker fallacy. We've talked about this before, Rakia.
You can name it whatever you want. It doesn't matter.
Yeah, it does. No, it's an old argument.
So Rakia, the an airplane can fly across the Atlantic. Therefore, airplane seats can fly across the Atlantic, right?
No, the airplane was with a purpose created by a creator of airplanes to fly across the Atlantic.
Therefore,
and the creator,
airplane
hang on,
seats.
you're cutting me off, and the creator put seats in that airplane that was created for a purpose, and that purpose for the seat was to carry passengers across the Atlantic.
But
Creator, purpose. Yeah.
Right. So the seats don't have. So even though the airplane has the purpose and the ability to fly across the Atlantic, it does not follow that the things that make up the airplane, the seats, the wheels, all the other
Everything
things.
has a purpose. Yeah, everything on that airplane has a
It
purpose.
doesn't follow that they are able to fly across the Atlantic.
It follows that the creator made it that way with a purpose.
No, that's
it
no,
does.
that's not
You
how it
think
works.
That plane
It's
was
called
created by random chance.
It was created by people.
Do you think those seats were put in the airplane by random chance or by a creator?
No, they're
By
put
a
in there
creator,
by people. Yes, who had a
by
purpose.
the creator of the airplane.
Yeah.
Yeah. Thanks for proving my point.
No, that doesn't.
So who created life? Who created life then?
Shill, I wanted
The
to know what
creator.
that I wanted to know what that thing you were talking about before, Shill, about a watchmaker or watch something.
Oh, the watchmaker. I'll find it. Hold on a second.
It's called the blind watch. It's called the blind watchmaker argument. It is
Yeah,
the
also-
belief. It is the belief proposed in the 19th century
Yeah,
by a
let's not go to
philosopher.
that too quickly.
I'm just giving the
Because
background to it.
Yeah, I know, but no one. I mean, I didn't. I'm in the conversation here. I didn't ask that. We're talking about.
Yeah, but somebody else did ask.
Yeah, and they said they were
You
going to.
weren't the center. You weren't the center of the discussion.
Yeah,
Somebody else wanted to know.
I'm trying to have the discussion. You just want to go to something else. So let's get back to the creator and a purpose, right? Everything. My claim is everything has a purpose, and everything created was created by the creator for a purpose. Now, you've proved my claim several times in this conversation.
No, I did not.
Yeah, you just said the seats were put in the airplane by the creator for a purpose to carry passengers. Don't you agree with me?
It doesn't mean that they have the ability to fly across
That wasn't my
the Antarctic.
claim. That wasn't my claim. My claim was the creator created the airplane to fly across wherever and put seats in it for a purpose to carry passengers.
So
the other purpose of an airplane might be to carry cargo, so they might not put seats, but the creator dictated that purpose, right?
So what is your argument?
Right.
What is your no? It's not. So what is your argument?
Cargo planes.
So what is your argument? Just a minute. What is your?
You asked me
Just a
what's my
minute.
argument. Yeah, you asked me what's my argument.
I haven't completed my sentence. I know that you're triggered. So what is your argument that everything has a purpose? Go ahead, prove it.
Because you can't prove that everything doesn't have a purpose. Everything I've stated and everything you've stated has a purpose, down to the seat in the airplane.
That's your claim. That's your claim. Now support your claim. Now that's your claim.
Fine, I'll prove it using you. What's the purpose of a seat in an airplane, Brenda?
To hold big fat American butts.
Awesome. So who created that?
Boeing did.
Was it a seat creator? Like the creator of the seat created it, right?
The designers and engineers at Boeing.
Yeah, they created it. So Boeing is your answer, created. So there's a creator and a purpose. Isn't that my point?
So people created life too. People created the world.
Brenda, isn't that my point?
I don't know what your point is. It's incoherent.
My point is that everything is created by a creator. We said that Boeing created the seat, and I think everything has a purpose. As in, they created that seat for a purpose, which is, in your terrible words, every fat American can sit in them. So purpose, right?
I was just trying to be humorous to lighten things up.
Ugly.
I was just trying to lighten things up so it didn't get too tense.
No matter what the weight of the American in the seat, the purpose of the seat is to carry that person, right? Purpose.
Yeah. I've said
creator and purpose.
Why don't you repeat it 3 more times or something?
Until you say yes, I'm going to keep repeating it. So, creator created the seat, and the purpose is to carry fat Americans, right, Brenda?
Yes, I've said
Thank
yes.
You, so you're proving my point again.
That doesn't prove your point. Your claim is that no, it does not. Your claim is that everything has a purpose, and you have to prove that,
including the plane and the seat. Now, any other examples you want to bring up?
Some things have purposes because they're created by people. Not everything has a purpose.
No, I said everything has a purpose created by a creator. You want to bring up something that I can't say has a purpose? And that was created by something?
You need to demonstrate. Yes. NASA is right. You need to prove your claim that everything has a purpose.
Why would I want to prove it negative? You haven't proven that something's made without a creator.
Somebody else had jumped in. Who was that?
It was me, real quick.
Yeah. I thought it was Isa. Yeah, go ahead, Isa.
I was just curious, like, Brenda, what's your position of, like, did you create yourself?
Don't be silly.
Okay, like, well, so then I would ask you, like, where did your purpose come from?
Oh, my purpose came from me.
And that's why I asked you again, is did you create yourself?
No.
So, would you agree that your purpose was created by nature?
It was created by me.
By nature?
No, it was created by me.
Vicariously? Like, would you not concede, like, a little bit?
Concede a little bit of what?
That it comes from, like, your purpose. Like, okay, so you've said that you didn't create yourself.
Right, my mom and dad did.
Okay. So, but you give yourself purpose.
Yes.
Okay, right. So my thing is this is like, so where does that sense of purpose come from? And if you could liken, like, you don't see the correlation between you're giving yourself purpose and that purpose came from nature kind of longing for itself?
Yeah, I don't think, I think, yes, I am a part of nature, right? And yes, I have purposes, right? Desires, beliefs, things like that, thoughts, right? It doesn't follow that nature has those things.
Well, my thing is, but at least you could agree that nature created you and you gave yourself a purpose. Therefore, your purpose was created by nature.
No, I don't accept that conclusion. I don't accept that.
Okay.
It came from me.
Right, but you came from nature.
Yes,
so
yes.
It's a byproduct. So your purpose is a byproduct of nature creating you.
I think you might want to say that my purpose is an emergent property of all of the things that came together that make up me.
You're very intelligent, Brenda. I'll give you that. You're just, I mean, like, that's such a, I mean, you know, fair enough to the no concede gang. You know what I mean? Like, you guys, like, I would think it'd be relatively self-evident that if nature, you know, if nature created you and you gave yourself purpose, that nature created you and your purpose, right?
No.
And I would dare to say, Brenda, if you'll come out on a limb with me, is the idea that, like, you know, oh, forgive me, like that, that nature in itself and what we deem as like mitochondria and tigers and shit, like all of this is the creation story of nature, which then promulgated you and your purpose, right? So
No,
in light,
I don't accept any of that. I don't accept
and I'll
that.
finish it up like this. In light of that, one could agree that that the common theory of today has a creation story.
No, I don't. I reject all that.
Just
because they don't follow.
Right, and this gets back to my question of like, what is mitochondria?
It's like they describe it as the energy powerhouse for the cell. It synthesizes ATP, which is an energy molecule that gives energy so that the cell itself can do things.
And you don't think that sounds a little bit like a story regarding creation?
Chemistry.
No, I don't.
Like it's an right? Okay, but this then maybe chemistry is the creation story broken down in different books.
No, it's not. It just isn't.
Okay.
So biochemistry, therefore God. Got it.
Wait, can you direct that question to Paid National Shield? He's a chemistry. He has a major.
That's what I said. Chemistry.
He has a
God.
master's in chemistry, so maybe you can
which
ask
is more
him.
than you have.
Feel free.
Well,
So chemistry, therefore God. Got it.
Retired airline guy who refilled SR-71s and shit. He's not a chemist.
No, he has a master's in chemistry. I didn't say he was a chemistry, but he could give us some really good in-depth, logic and reasoning, and use some
no need for
chemistry
that
term.
here. You guys don't believe.
He just can't do it here.
We're talking about purpose, right? So purpose has, at a more fundamental level, it's information, right? It's just, because your purpose could be anything, and that purpose is just some information. Now, the mitochondria can't give itself the information for what it does before it is born, right? So it can't create itself, then give itself the information that it needs to do its job. That must come from an outside source. That information must be held in some kind of vessel, which is then put into the mitochondria. And that's really basically this fundamental thing, this creation story.
It's cute when you try to sound intelligent.
And it's cute when I know you can't address it logically and you just talk about
okay, well, purpose is not information. You're just putting words together that you heard somebody else say that you have no idea what they mean.
Brenda, are you hitting on Right the Hand right now?
Right?
No, I'm not. If I did, he would be pinned to the. He would be pinned to the mat like that. It would. If I was, he would be pinned to the mat like that other woman.
Chemistry was.
Because you're on
ruined.
hormones though. You're like on steroids, so that's not really going to be a fair fucking.
Now, if anybody knows the history of right-handed Brenda, then they'd know that Brenda probably eats healthy just to live longer to hate right-to-hand more.
I don't hate right-to-hand. I don't think about him at all. He's
What's
nothing.
your purpose in life? He's nothing. He has purpose, Brenda.
Yeah, the idea of the purpose, when you were like, purpose is information, because if you're going to say,
it's not.
Hang on. So if you're like going to say, oh, my purpose was to eat something, right? Like the body has to inform itself that it's hungry, right? Now you can call it chemical reactions, you call it whatever you want to call it, but at the most basic level, it is information being passed along. Because there's a point where you don't feel hungry, right? But then something starts happening, and eventually you do. So that the information of hunger starts in your body somewhere, makes its way up to your brain, and then however it works, right? That's how it works. You don't just become hungry because somebody snaps your fingers. Like there's a process that makes you feel hungry.
Your stomach is empty and it shocks your muscles, and you're like, oh.
Yeah, that's not what happens at all. Can I be hungry, right the hand, and not? Can I? No, it isn't. So can I be hungry and not have the purpose to eat to have supper?
I didn't say the purpose. I said hunger. Hang on. That feeling of hunger, right, is chemical reactions, whatever it is. It's information being transported from. Okay,
Sure, I'll agree with you. I'll agree with you.
And that's my
with
point.
you.
That's my point.
Right, but can I have that information and not have the purpose of getting up to eat supper?
I'm not making that point. I don't know why you're asking me that. My point is not that.
You mean can you ignore it?
Because if I can have that information and not have the purpose of eating supper, then information isn't purpose. Then is it?
You can't go without eating. If you go without eating, you'll die.
Nobody disputes that.
I do like how you call dinner supper. That's cool. I don't hear a lot of people using that.
I'm in the Midwest. I don't think people call dinner supper very much around here. I mean, I'm sorry. Most people would say supper here, not dinner. I think.
Yeah, we say supper here too, or dinner. Actually, we say both. It doesn't matter.
Yeah, kind of. Yeah.
I mean, saying you're hungry is information, right?
Yes, it is.
Yeah, okay. So saying you're going
to purpose, though. I can have the information that I'm hungry without the. If I can have the information that I'm hungry without the purpose of consuming supper, then it isn't purpose. Then is it?
That's a bad example.
The purpose
Brenda.
is to get you to feel hungry. That's the purpose, and its
If
job
I
is
can
to
have
Now,
the
hang on. Now, whether you, as the person who is getting that information, your body, you can be like, I have time to stop and eat, or I don't have time to stop and eat. So just because you didn't eat doesn't mean you weren't given information with a purpose.
Yeah, but it shows that information isn't purpose, because I can have purposes that are not aligned with being hungry.
You can't have purpose without information.
You're using it wrong. You should use breathing.
Hold on, wait.
Brenda.
You cannot
breathing.
Can
you ignore the breathing?
You can't.
I can have the information that I'm hungry without the purpose of consuming food.
That's not my point. You cannot.
It is your point. You said they're the same thing.
So don't interrupt me. Don't get triggered for the third time, Brenda.
It is the same. Is information purpose? Is information purpose? Right the hand.
No, let me.
It's not.
You're interrupting.
Are you going back on what you said?
Come on. Can you have You cannot have purpose without information to convey it.
Yeah.
So all purpose is information.
No, it's not.
Oh my! Wow. Okay. So
And
wait.
The reason I can have purpose the reason that information is not purpose is because I can have.
Give me purpose without information.
The reason that information is not purpose is because I can have purposes independent of any information that I have.
No, you cannot have purpose unless you were given the information or you. Hang on. You can't have. I can hear when your freaking mic comes on because you're like, oh, ready. So you cannot have purpose without the information to convey what that purpose is. So purpose, at the most basic level, is information going from one vessel to another.
No. And the reason why is because I can have purposes that are not aligned with my information.
Just because you don't do something does not mean there wasn't a purpose for that information. The information your stomach gave was for you to eat. Whether you did it or not is beside the point. Now, a better example, don't talk over me yet. A better example would be breathing, Brenda. When your brain tells you to breathe, do you just not do it? Let's see.
Sometimes, yes, sometimes I don't breathe. I can hold my breath. I can hold my breath.
No, you eventually breathe or else you'd be dead, Brenda.
Yeah, what does this have to do with anything? You think you're making this point and you're not.
The purpose of the information. Breathe, Brenda. Breathe.
This doesn't have to do with anything. This is like the dumbest example I've ever heard.
You guys, can we possibly dial it back? This kind of just sounds like people fighting right now. It's not really a discussion. Can we get it back to the discussion?
He can't not breathe, so, I mean...
Well, the argument is that the claim on the table is that information is purpose.
It has a purpose, yes. It is. That's true.
No,
now, whether you ignore that purpose is your own problem.
So the way I can falsify that is simply by noticing that purposes can be misaligned with information.
No,
Therefore,
you're
they
ignoring
can't
the
be
whole
the same.
situation. You're ignoring the whole point. The information has a purpose. It has a purpose. But let's talk about
I'm not
something
saying
else.
that. I'm not saying information quote has a purpose. I'm saying purpose itself, right? Whatever that purpose may be, whether it be to dig a hole, whether it be to just stand there, is information, right?
Yeah.
Like, yeah, exactly. So
And I
if
told you that's
hold on.
wrong. That's wrong.
Well, Brenda, you could just share your idea instead of heart. It kind of gets into just heckling when you just want to.
Getting over
All right.
talked.
Yeah, now you're over talking me. All right.
I'm trying.
Anyways,
to,
yeah, let's.
I'm trying to, Gio. I'm trying to.
Yeah,
It's really
everything is.
simple. It's
Yeah,
really
Jay.
simple. If purposes can be independent of information, then they can't be the same thing.
But they can't be independent because without the information to convey the purpose, there can be no purpose.
No, that's
exactly,
just not
Brenda,
true.
exactly.
It's just
Tell
not.
me why then. Don't just say no.
I
Tell me why.
He was able to pick up on your rhythm. That was awesome right there.
It doesn't matter.
He could tell. He could tell that your mind like had to actually think about what it was and question within itself.
Yeah, that was the win. That was the win I was looking for.
So the fact, yes, I know that's all you exist
You're
for.
just covering it up now. You're just covering it up.
No, I'm not. If my purposes can exist independent of any information, particular information, then they cannot be identical. You're saying that information is identical with purpose. Nevertheless, purpose can be independent of the information that I have. Therefore, they cannot be the same. It's simple logic.
I didn't say they were the same. I said purpose is information. Bro.
That's saying they're the same.
Everything is information. The weather. If I give you the hang on. If I tell you what the weather is, that's information. I'm saying, oh, it's this amount. Hang on. I'm saying it's this amount of degrees outside. It's this amount of this. That's information. Does that make the weather information? Right? Because at the most fundamental level, that's what everything is. Right now, our interactions, the words I'm saying is just information, right? It's all just information.
Right. And without memory or retaining of the information or purpose, then that, you know what I mean? So yeah, it all comes together.
What Right the Hand said is that information is purpose. That's an identity relation. And I can refute that by showing that purposes can be independent of information. Therefore, they cannot be identical.
Everything in Brendan's world is disinformation.
Hold on. You mean stuff does stuff without any information or any like action or anything to make it do it?
Yeah, that's
so it
insane.
just like
that's crazy.
Like,
can you give me information? Can you give me some information, and then I could have a purpose that goes against that information?
You're saying it wrong.
That doesn't make the purpose. That doesn't make lies or information, right? So I'm not saying that information is fact, right? Information is just the uniqueness of a message, right? Like red, blue. Red and blue are unique forms of information which we use to distinguish the world, right? The world is just information being translated through different mediums, and that's it. So that's all it is.
A purpose is not information. A purpose is not a message.
Translated through memory.
Okay, sure.
A purpose is not a message.
Why do we have a memory if there's no purpose for information, Brenda?
I never said that there was no purpose for information.
Well, information is purpose for itself. There you go.
It's not. It's not.
Well, I'm seeing it as looking ahead. All information has to come from a source, right? And this is where, right, like trying to stay away from like
information is physical.
Yeah, no, that is interesting. Yeah, the way you said that exactly, like this idea of purpose and information. Well, information exists for a purpose, I would say, and that purpose is to transmit itself from one unit to another unit of consciousness, perhaps soul, on some level. So in that sense, it has a purpose because it has a direction, it has a start, it has a journey, and it has an end.
Could Brenda
that's what the memory
define
is for,
her
too.
position of what purpose is?
Yeah, that's what I'd like to hear, because that's where the memory falls into play too, because it comes under all those categories. That's why you have a memory, for a purpose of, to sectionalize, to like put things, categorize, like decipher, come on.
Is there a question out there? I didn't hear a question.
He told you to recite your idea of it.
You said dog bones are clock. What did you mean by that, Brenda? I've always wondered.
That they are clocks. They track time. What do clocks measure, Brian?
Shoes.
What do clocks measure?
I'd say they don't measure anything.
Space time. Space time.
They measure distance.
Clocks measure time, right?
No, they just click, and then we impart this kind of measuring.
Clocks measure time.
They move a distance.
Clocks measure the sun.
It's a distance. The sun's motion. The sundial works on the distance that the shadow moves.
Over time.
You're not tracking time. You're tracking the distance, though.
No, you're tracking time. That's what time is.
Oh, and how would you track time? By the motion or distance of the shadow. So you're not tracking time. This is going to be a round and rounder.
Clocks measure time.
You can say that much as you want. That doesn't make it true.
Well, it's kind of. I think it's kind of both. Like it's a distance, and that distance, because it's not just a set distance outside of time. It's a unit of measurement from one to another. Yeah.
And the one to the other is the two distance. Is
a rate of distance. Right hand is correct. It's a rate of distance.
No,
right. The time comes in when you start comparing things to it, right? Like you got to have this like the wheel that it goes around, right? Like without the sundial, right? Like you have the circle to compare that motion to, then you can chop up the circle into parts, hours. That's why clocks were round, blah, 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 blah.
Yeah, like Brian just said, the rate of the distance. Yeah, that rate of unfolding.
Rate being time.
But there's no measurement. There is, when you have measurement, right? You need the actual device that measures something, and you need the thing that is measured, right? So when you
a stopwatch measures time.
So a clock measures the distance of movement. Yeah, it measures that rate of movement.
It's completely technical. It's a rate of movement.
It's just the movement.
Right? Actually, clocks. So you're right. So clocks measure time.
No, it's the movement around the.
And time is the movement of the sun.
The movement in a period of time.
No.
No.
There is no period of time. There's just the motion of the clock.
Defines the periods of time.
The only way you can know
in a period of time, what do clocks measure?
Motion. The only way
they measure the movement of the sun.
Yeah, the only way you can know that quote unquote time, I'm using whatever you think time is moving or passing, right? I have to use motion verbs even when we talk about time, right? Oh, time passed. Oh, it's
Is the shadow of the sundial linear as it's moving? Then what is time? Is time linear? Exactly.
Yeah, time's not a thing. We use time. We use it like a
thing.
Because it's not like an area of space you can occupy. It has there is no time mechanism that is affecting everything. Like even age is chemical reaction. Getting older is chemical reactions, right? It's your skin losing elasticity. Like your skin
over time, right?
Your skin losing elasticity is not time. It's a physical.
No, it's movement, turning over of cells, the unraveling of telomeres. It's all movement.
Yeah, over time.
No, the time is
you mean
movement.
no?
It's movement of the sun. That's what time is. Movement of the
it's
sun.
not. The
Yes,
time,
it is.
Time isn't movement of the sun. Movement
It's
of the
movement,
sun
period.
is,
But our conception of time is movement of the sun. That's what we've pegged it to.
No, it
the sun.
isn't.
If we didn't have, yes, it is. If we didn't have
No,
the sun,
it
we'd use the
isn't.
moon. If we didn't have either of those, we'd
time-
use
I can
a
keep
drop
time
of
without the
water, like
sun.
in Chinese water torture. We'd always peg it to something out of convenience. But it's movement in the end of the day.
Brenda, just to jump in for a second, I just want to comment on something. This is a good discussion. I think there's good ideas, but I think it's getting really riled up. I think, Brenda, because often when you respond, your first thing is some kind of a no or no, it isn't. And I get that, like that you're, feeling that way, but perhaps it's not the most productive way to kind of engage, because then people feel like they've been screamed no at, and then it just makes the conversation pretty chaotic and not
My
really
apologies, Gio. I was doing a bit of the same.
Well, that's what I'm saying, but I think she's doing it with such. I'm not trying to blame it on Brenda. I'm just saying that she's doing it so strongly that it's activating, I think, kind of everybody.
Well,
yes, Gio, I try to butt in, but it's hard to. I know the time difference is there, and I try to wait for the right moment, but I can't. It's hard to get that gap.
No, that's a good point too, Terry. Thanks for bringing that up. Yeah, totally. I was actually going to say that earlier, that because sometimes if like two people are just the only ones talking, then it's almost like no one else can even get in. Yeah. So yeah, I think we should keep more in mind of that, because sometimes like certain individuals tend to do that more.
Somebody picked up on that before when there was a gap from a question, and I heard the other person didn't answer it, and then I thought, well, does that give me a chance to say something? And then I got told off for saying something. I don't know.
Yeah. Well, I think like if it's a more open chat, then it is more difficult in that way to kind of coordinate that. But I think part of the idea on this server with the live stream host is that, perhaps hosts can kind of work with that more, and be able to bring people in, make sure people are heard, because otherwise it's just the mods modding and maybe not as much of, so it's a good point.
Gio, part of the problem is that I'm simply relating elementary ideas, and people here are reacting emotionally to facts that are uncomfortable to them.
Yeah, but Gio's point.
Yeah, we could watch a movie with that projector.
See what happens there. I get talked over, and I didn't even realize.
No, that happens sometimes. But go ahead, Terry.
And because I'm older, my thoughts get pretty well lost if I don't get it out straight away. See, now I've forgotten what I was going to say.
It'll come back to you.
Yeah, it'll come back to me. I liked it that like you were saying before about the people having a conversation, but the one-on-one is not necessarily the conversation. It's other people able to have their opinion or stating something in that conversation. The one-on-one to me is too. There's a word for it. I can't think of it, but yeah, too controlled in that way. And they're not allowing other people to come in at times and let other people come in on the conversation, and then the other person will butt in again to try to get their conversation back to the way that they think it should be going. That's control. I don't like people trying to be controlling like that.
I do think that when you get two people that hand it off, it works good. Like I feel me and Demok there were, we were talking the same things. I was talking and he would go, and it was, as long as you kind of stay focused, you can have as many people as you want talking. It's just when you get 3 or 4 or 5 people in the same conversation and one person wants to take it away.
Yeah, I mean, I think ideally in terms of like pacing to have really good conversations, like if each person, like if we left like almost 2 or 3 seconds of silence after somebody finishes speaking, that would be interesting, because then let's just say, okay, there you know for sure there's a long enough pause, and then of course whoever's going to speak next, like maybe 2 people jump in at once or 3. But if that happens, then basically just it needs to be sorted. Like someone has to step back. Like if 3 people talk at once, then obviously 2 of them are going to have to step back. We figure out who goes, and then they're able to speak. So I think,
as long as we don't monologue, like we've been having a conversation where nobody monologues, so more people can get in. That's what I like.
I rarely get to complete a sentence.
Well, I think Terry's right though. When one interruption happens, then they're like contagious. It's it's like somebody yawning in the room. Once somebody starts doing that, then it's like everyone else starts doing it, and yeah.
And it's also the fairness of the conversation where you have to allow mic time for other people that you haven't heard. Say Brian hadn't spoke for 5 minutes, and he goes to say something. Well, you have to at least let that person that hasn't spoke for a while, or he hasn't spoke yet, at least come in and actually say something, and let them have a conversation for a couple of minutes or whatever it is, and not just cut him out or tune that person out, because then they feel like they're not in the conversation.
Yeah, I feel if you haven't spoken in a while, you should get like preference, right? Like, so like if you haven't spoken in an hour and you want to say something, you should just be like, hey man, I haven't said anything in a while.
Yeah,
And
usually
then
when we hear new voices, we back off.
Sorry. The other thing I do notice, if the other person knows what side of the fence the other person's on, I do notice that type of conversation or attack or preference. Because a lot of people here don't know what side of the fence I'm on, so that I like it to stay that way.
Dude, don't worry.
Yeah, it shouldn't matter what side of the you should, because that's like not addressing the argument.
Yeah, I mean, this platform is designed really to be kind of more of like it's like an open discussion platform. So there's not, you don't like. Of course, people have their maybe groups or sides that they feel are a thing for them, but ultimately everyone is free to have their own viewpoint and opinion, and ideally to be respected for it, and not attacked and ridiculed and beaten down for it. So yeah, I think sometimes there is like.
I don't think I personally attacked anybody tonight.
Oh, Brenda, you're good, man.
Yeah, I haven't personally attacked anybody. I attack the arguments.
Yeah, no, you do. You've always been like that.
People are emotionally attached to their beliefs. And so when I attack the argument, it feels to them like I'm attacking them. And then they get triggered.
It is though, Brenda. It's like for me, if I could just explain my frustration at times, it's like when I'm trying to draw the connection between the idea that nature created you and therefore you gave yourself purpose, therefore nature created you. And in looking at the story of like mitochondria as like a creation tool of life itself, like these things are to me could be quote unquote considered creation stories. How you don't make them, how
Brenda says we're so emotionally attached,
how
but
you
she's
don't
just
make,
projected, man.
excuse me.
Because look,
See?
How? Yeah, no, stop.
Real quick.
I'm not
I'll
doing
give you an
this.
example real quick.
I didn't do this.
Because
I didn't do this.
flat earthers would say, what we'd say is, it might be an infinite plane.
This is what we were just talking about. Like what I'm saying is this: is that how you don't draw that conclusion, or make that leap with me on the idea that nature creates this, and that the modern scientific theory of creation is a creation story. Like how you don't put that together, I'll never know. But I'll give you credit for never conceding on any of these fucking points at all.
My position is pretty standard. I mean, if you go through,
that's our issue with your position. It's the idea that we're literally in opposition to the standard in the sense of whatever, and that's where I understand that you understand that gets people emotionally riled up. And good luck to you.
I don't know what you mean by that. I don't know what you even mean by that.
Position in a cosmology room that favors the flat position.
Why did you bring up mitochondria? What's the significance of that for you?
Well, the idea of let's say watching mitochondria and speculating on what they're actually doing. Like it's like, kind of like the tiger kind of idea. Like, what gives the tiger its stripes? What gives the blue jay its pattern? These things are, ingrained in life, right? And and their purpose is to feed themselves, and that is to promulgate the species, if you will, in your model. But to still negate the idea that even that's like that very speculation is a story.
In their model, time is the cause for all that. Everything you just said, time.
No, it's natural selection. So the reason tigers have stripes is natural selection.
Right. But now, second, Brenda, let me cut it short. Forgive me for interrupting. I don't mean. I think we know each other well enough to talk to each other. But like the very idea that you would belabor this point to me right now and say that, well, tigers have stripes because of natural selection is in itself a creation story.
No, it isn't.
Well, okay, to me it is, and that's maybe my frustration.
I understand that.
You know,
why is it not a creation story?
Because there's no creator.
Good question. Right, but if you can give me the story about how the tiger and natural selection, that's a Darwinian creation story.
Well, it's an evolutionary one, right?
Which comes from Darwin, right? Conceptually, like, if you will,
like 160 years ago. Yeah,
colloquially, you know what I mean. But like, that theory is like a Darwinian, creation story that we've elaborated on.
Okay.
So the
you
reason
said it was an evolution story.
The reason I have to object is because there are many people that want to teach religion in schools as if it's science, and that is highly objectionable. We should not teach religion as if it is science, right? So creationism is religion. It is not science. It doesn't belong. It doesn't. Nobody cares what you think.
Well, I can agree. How about this, Brenda? I can agree with you as much as that. Let's say in a public education system, being that they are to remain secular, right? It isn't their business to necessarily speak about creation stories. But let's say in the concept of even in the concept of world religions, I mean, granted, I understand the distinction, but wouldn't it be good to be referencing, let's say not that I'm trying to critique the education system, because I couldn't care less, kind of, is the idea that, it should remain secular, but it doesn't mean that they can't teach this concept either as a scientific proposition.
What concept? What concept?
Let's say the concept of a local sun and like the alternative, let's say to even like in brief passing without, let's say, ridicule.
Well, because we know for a fact that it isn't local.
Okay, before the conversation shifts to a local sun, let me just say, Brenda, you said that it's a Darwinian evolution story, not creation story. Okay.
No, I said it. I never said that. I said when somebody else said that, I said it's an evolutionary story.
Yeah, exactly. You said Darwinian evolution story, not a creation story.
Darwinian.
I may have added that.
Okay, fine. An evolution story. Now, my question to you is: can something evolve? Can something that doesn't exist evolve?
Huh?
Can something that does not exist evolve?
Can you get things that didn't exist before by the process of natural selection?
That's not what I asked.
Yes,
no.
Species come into being by means of natural selection. They didn't exist before, right? So dinosaurs didn't exist, and then natural selection selected the ancestors to dinosaurs, right? And so then dinosaurs did eventually come to exist. Human beings did. Human beings did.
One second. Your point is well taken. You don't have to give me another example. So the dinosaurs, the ancestors, existed, right? And they evolved. Yeah. So they had. So again, can something that does not exist evolve?
Do you mean that as a?
If the ancestors didn't exist, they evolved.
Is that an adjective or a verb? So something that doesn't exist can't do anything.
Very good. Okay, so something had to exist to evolve, right? Where did that thing come from? How did it?
Natural selection.
How did it start existing?
Natural selection works with existing materials, with the materials that it has. Yes.
Okay, so where did those materials come from? How did they exist in the first place?
The pre-life Earth. right?
The pre-life Earth.
As far as we know, yeah, Earth was.
So, based on what Brenda's saying, my assumption is that she doesn't believe that there was a beginning. Now, with that said, my question to her that I asked a while back, I'm still highly interested now, is what is your position on what purpose is?
Purpose is intentionality.
Okay, so where did the pre-life Earth come from?
Are we doing this?
Mm-hmm.
Everything came from the Big Bang.
Okay, so the Bang created this energy?
No.
So where did the energy come from?
We don't know.
That's the smartest thing you've said.
Yeah. You can read or watch lots of videos on what was
theory of relativity. Hold on, Brenda. When they come up with the theory of relativity, they thought they'd have fusion down in 10 years, 20 years. Okay, it's been over 100 years, and they're still chasing bullshit. They thought they could make new elements and stuff. They thought they'd be able to combine gases and make solids and stuff, but they can't. It boils down to the relativity bullshit, and so that's why evolution's falling apart. And the longer they don't go to the moon, that's why the moon missions are falling apart, man. All their hoaxes are falling apart, and people are waking up.
But we do make new elements, Brian.
Hold up, Brenda. You said pre-life
You
Earth.
combine two things. Combining two things into something is not making something from scratch.
Yeah, it is. If I take a bunch of some wood and assemble it into a table, I've made a table. It's a new thing.
But we're talking. I'm pretty sure
Not really.
the entire argument was about where the wood came from.
The wood came from the Big Bang.
Yeah, it sounds like God.
Yeah,
No,
and you don't
it
think?
isn't.
Hold on,
So,
Brenda.
so
you
where did
don't
the
think
life
you
come
sound-
from the pre-life
Brenda,
Earth?
Hold on one second. Can I ask the question, Brenda? You don't think that you sound at all like when Christopher, like an Indian that says, like, where do your people come from? And they say, we come from the Big Bang. You know what I mean? It doesn't sound like a creation story at all to you.
If somebody said, "What's the Big Bang?" and you're like, "Big Bang,
Oh, the Big
everything
Bang,
comes Big
It's
Bang."
like, it sounds like a big monster, Big Bang. Big Bang's a big, like Big Bang's this monster that roams through the fucking universe.
Nah, it's not a monster roaming through
We
the
come from
universe.
the
It's
Big
just an
Bang.
elephant in the room.
Yeah, he comes from nothing.
And then they say,
He
"Well,
comes
what
from
is the
land
Big
of
Bang?"
nothing.
Right.
No, he comes from the
Well-
land of nothing.
First there was nothing, and then all of a sudden there was everything.
There's never been nothing.
Is that a creation story? No. It's not a creation story. However, first there was nothing, and then there was everything. Oh, wait, so you mean a bunch of stuff was created? No, it's not a creation story. It's just, what is it?
Science, motherfucker.
Geo, there has never been nothing.
Yeah, everything was here. It was just compacted into like a really dense turd. And
Well,
then
I
the
think-
universe diarrheaed everything out.
On that viewpoint, in terms of nothingness, I actually do think that nothing exists. However, it exists infinitely because it's often what's referred to as the void. People have had these experiences since the dawn of time, like of actually having like a mystical experience of the void, where it's often experienced as being a dimension of creation and of consciousness where essentially nothing exists. Like it is complete empty. However, it's pregnant with everything. So there's like often that understanding that's like it's like pregnant with all of creation, all of life, but somehow in that state, it is completely void. It's like the void on that level. It's like the opposite of light, not really like dark, not dark and light in terms of like evil and good, but more just like light is that infinite creative energy. And then the void is like the complete opposite of that, the polarity.
Does nothing exist?
Well, I would say so. In consciousness, yeah. The actual state of nothingness exists, yeah.
Right.
But it's only in a
nothing can exist because there has to be a God.
But
God's
only in the
always
polarity to the everything. Yeah, the everything just has everything has everything in it that it can create nothing out of everything. But the everything comes first. That's how I see it.
So if nothing exists, it isn't nothing, then, is it?
Nope, it's still nothing.
Yeah, that's not how things.
It's the state of consciousness of nothingness. It's consciousness in nothing form.
If nothing exists, it isn't anything. I mean, it isn't nothing anymore.
Okay, Brenda, you mentioned something earlier. You said the pre-life Earth came from the Big Bang. So my question is, what changed to make the pre-life Earth the life Earth? What gave life?
Well, there was abiogenesis took place.
So the first primordial, species came from rocks and stuff.
No, it came from. We don't know. We don't know. Probably we'll never know how the first life came to be. We have some pretty good theories, right? But it's going to be pretty hard. It's going to be pretty hard to check those. But we can just give a educated guess.
Y'all will never know that hydrogen ain't helium or never will be helium. How y'all going to know something like that? You can't create it in the lab. They've been trying. They've been trying profusely, billions of dollars to create life. They never will. You never will because you can't, and you can't fuse hydrogen and helium. It'll never happen. It's different. God made it, but science can't deal with that.
Go on. We were talking about Big Bang. And remember, you guys are saying it wrong. It's not Big Bang. It's Big Bang, like wigwam. Big Bang.
Right, it's not the Big Bang. Like it's not a Big Bang. It's the Big Bang. The Big Bang.
It's the Big Bang.
So Brian is incorrect. We can and do fuse hydrogen and helium. It's called fusion. It happens all the time.
Well, Brenda, you were talking about nothingness existing. So, in your idea of this Big Bang idea, okay. So, like in general, okay, I'll put it this way. In general, what I'm describing in my general epistemology is the idea that the consciousness is primary, and from consciousness you can have basically all different states, just like different states of matter, states of soul, states of consciousness. So there can be a state of nothing, which is the void, which is experienced as being pregnant with all of creation, but also being completely empty and void of anything. So that's how I'm seeing it. So like nothingness and existence are both in existence, but they are like they come from consciousness. Now, in your viewpoint, are you saying that nothing existed, like truly nothing existed, and then this Big Bang event, and now all of this exists? And if so,
no,
how does that link in your mind?
No, I don't. I'm rejecting that. I don't think that there has ever been nothing, because nothing can't exist. Because if it exists, it isn't nothing. Nothing is the absence of existence, so it can't exist.
But we're talking about it, so it already does exist somehow.
Oh yeah, we can talk about things. We can talk about Sherlock Holmes, but Sherlock Holmes doesn't exist. We can talk about things. That doesn't mean they exist.
See, Brenda, or can I ask a question? Is that?
Yeah.
Like, so like when you were talking about, like the idea of the theories regarding Big Bang, and I was wondering, when you say that they're theories and that we could never know merely because they're just speculation.
I was talking about abiogenesis. Those are ideas about how life came to be. It's separate from evolution. And as far my understanding is that people have a number of different ideas about how that could have happened. And they're pretty mature, but there's no way, as far as I know, that they could ever verify those theories.
Are there verified theories in regards to biogenesis? Or do you accept that there are,
there are experiments that people have done that indicate certain things could have happened in a certain way, But whether or not they actually happened in that way is not something that we're going to ever find the records of.
So in some sense, we could say that they are scientific stories.
So, well, they're theories or hypotheses.
I mean, those are just fancy words for a story, aren't they?
No, they're not. Science isn't just a story.
Not just a story, but it is a story.
You can create a narrative from the facts that we know of as science and stuff like that, but at bottom, you know, it isn't just a story. It is science corresponds to reality. So we know in reality for a fact that the Earth is round. It revolves around the sun, and the sun revolves around the galaxy.
Right, but as regards
Brenda,
these are facts. These are facts.
Hold on. But as regards to biogenesis and the theories thereof, we could agree that those are just creation stories.
No, they're not. They're hypotheses based on scientific
Oh my God,
experiments.
And hypotheses
Let me make a point quick. Let me try and change this up a little bit.
Hypotheses are not just a story.
We've got to get this off philosophy, man.
That's true.
Right. So if they're not just a story, then that would imply that they are a story.
No, that doesn't follow. You can make stories, you know, the stories can be about that, right? You can construct a narrative.
It's a hypothesis. It's not just a story. It's a it's a creation hypothesis.
We've got to change this up, man. She said science. Her science believes that gravity. She's saying our science. She keeps saying we, but she's. Hold on, dude. Hold on. She thinks her science. Hold on. I want everybody to think about this. Her science thinks that gravity. Wait, dude. Quit interrupting me, man. Her science thinks that gravity and heat alone can turn hydrogen into helium. I wasn't talking about fusing them two together. I'm talking about they think that the sun, which they say is caused by just gravity and heat. So they think that if they compress something together strong enough and heat it up, then it'll turn hydrogen into helium and helium into what you call it, and so on and so on. They don't know by now that it's electrical. The only way they're going to ever fuse anything together is if they learn that the sun is electrical. And that's why we get solar panels. Think about it. Everything you put, electricity, you take a plate and you add heat to one end and cool temperature to the other, you get electricity. So if you take that same device and you add electricity to it, then you get a hot side and a cold side. Same thing with all types of electricity. You get in what you put out.
So that's not how physics works even at all.
So a sun doesn't go nova when it reaches iron from fusing, starting with hydrogen and helium and so on, till it reaches iron, then it goes supernova from heat and gravity?
No. So suns only go nova if they have enough mass, right? Our sun will not go nova. It will simply...
So when you say mass, you mean gravity, right? Gravity.
All you need to create the elements is gravity and hydrogen. And then you can create all the elements that we have.
And what I'm telling you is they've been chasing that bullshit for over 100 years, and science is starting to figure out that it's electrical. That's what you can turn everything into plasma. You can turn everything into plasma just by adding enough energy. But they're starting to realize now that with just gravity, just pressure, basically, and heat, you ain't turning nothing into nothing, man.
That's literally what can be done in dozens of laboratories around the world every day. They
have not succeeded with fusion, Brenda. They say they almost got cold fusion. They've been saying that for 30, 40 years that they almost got a cold fusion reaction. They have never changed elements with pressure and heat alone.
Brian, cold fusion is pseudoscience. It's not a thing. It doesn't exist. There's no such thing.
Well, I get. Brian said he didn't like the philosophical discussion and kind of put it into this, but I'm much less interested in this at the moment. I was actually enjoying the.
It's fine with me, but fusion is something that is done in laboratories all the time. We've definitely achieved fusion. We know a good deal about it. What we haven't done is create a fusion reactor, right, that can sustain itself and power a city. That we haven't got.
It is related, I suppose, to the Big Bang and the idea, because you're well, I guess you don't call it a creation story, but this Big Bang creation thing, you claim created all of these types of events, or the fusion of these different compounds that are making up stars and all that. Like the whole thing is kind of built on that, right?
All the iron, everything, all the iron, all the elements.
It's wrong. They have never changed elements. They have
Brian,
never changed.
someone is speaking.
Yes, they have.
My bad.
All the time. Yes, they have, Brian. All the time.
And they could make gold, Brenda. Brenda, they could make gold if they could change elements.
They do make gold.
Out of mercury that's amalgamated gold already.
No.
You ain't up with the stories. All you do is look at the science. You don't look in the debunking shit. That shit was amalgamated mercury.
So, Brian, we've made all of the trans-uranium objects in labs.
That claim has been debunked, Brenda, is what I'm saying.
No, it hasn't been, Brian.
Yes, it has. They said they made gold. It was debunked. They did not make fucking gold.
That's not true. They made gold.
No, it was gold. It was gold that was amalgamated into mercury. You know, mercury dissolves gold, and all you're left with is mercury. But with gold residue, that's what that shit was. It's debunked, Brenda. I'm pretty sure.
I'm sorry. You'll need to provide a journal article, a study that shows that, and not some conspiracy website.
To be fair, you're the one with the positive claim, Brenda, saying that they've did it to, like, they said the trans iron metals or something like that. They've converted all of them.
Trans-uranium. The
trans-uranium.
Trans-uranium elements are created in laboratories.
Yeah, you said that they've converted all of them into gold or something.
No,
So
all of the trans-uranium elements, all elements heavier than uranium, have been created by people, right, in accelerators and various laboratories.
Okay, so which ones were created?
Einsteinium, Americaceum, Californium.
You don't have to list them all. Which ones did they turn into gold?
You can turn lead into gold.
Okay, so lead, iron, you said?
What?
You also said iron, correct?
No, I don't think so.
Maybe I just misheard you. Alright, so they turned lead into gold. That's a positive claim. Burden of proof is on that positive claim. Brian saying it's like debunked, it's not true. That's a negative claim. He's rejecting your positive claim, which has the burden of proof. So if we're gonna play the game of, like, providing journals or something like that, you have to go first. And then Brian, if you're provided with the substantiation, then you better be on your game and come up with the debunk.
We can also just
They could take
chill and hang out. It doesn't have
already carbon.
Yeah, or we could just dismiss it.
They can't
sounds
make
like-
new
it sounds like
elements
a-
without electricity.
It's Friday night. We can just dismiss it.
It sounds like a court case.
That's what intellectual discourse ought to be. It has to, errant claims and accusations and, casting of doubts and stuff. They are unacceptable in honest discourse.
Rainbow's got colors in it. And no matter what I say, Brenda will deny it. I mean, maybe not that blatant, but just about anything I say, like Paid NASA Shield, Brenda, they will deny it one way or another. And no matter, it's just insane, dude. Because like I was saying earlier, we show them all. They ask for all these facts. We show it to them, and they act like they didn't even see it. Like we showed them how on the Himawari's website it says how it's stitched and how they get their data from the NOAA and other radars. Himawari's website, they act like they never even seen it. Next debate, they try and use Himawari as proof of a picture of a globe. It's insanity, dude. Like
is a picture of a globe.
Michael Collins earlier.
It is a picture of a globe. It doesn't matter if it's stitched. It doesn't matter.
It's all good, Brenda. It really is at the end of the day. Like, I mean, you know, yeah, you've got your own conclusions, and I doubt anyone's mind is going to be profoundly changed. But I think what we could hope for is information to be exchanged that could be useful, you know, to people. Like, to me, it's like the goal is, in my viewpoint, it's much more interesting to like actually unpack ideas rather, because like convincing someone, I mean, what even would you get out of that? You know what I mean? Like, let's say right now, like, let's just say, Brenda, because you have been pretty contrarian to almost everything that's been said, but that's fine because I know that that's your perspective on things. But even if right now, Brenda, if everyone in this room completely just agreed with every single thing you said, and we had the exact same perspective, therefore you wouldn't have anything to quote unquote argue. You would just be like, yeah, we would all just agree. If that was the case, like, if you were to imagine, like, would you really kind of get anything out of that? You know what I mean? Like, at the end of the day, you're still going to go to bed and you're still yourself at the end of the day. So there's nothing really to be achieved in convincing someone other than if people want to control people or manipulate or whatever. But I'm just saying, like, there's no other reason for it.
One of my main values in life is I value the truth, and I want my beliefs to be as true to as large extent as it's possible for me. And so to that end, I'm enrolled at the University of Minnesota taking a course in philosophy and another course in American history, and I greatly appreciate that. So, and then I go to other Discord servers besides this one, and I talk with people there about politics, about atheism versus theism, about different ideas and things like that. And I come here to talk to people who are flat earthers, right? Who sometimes challenge me and motivate me to learn better and learn more. The one positive thing I've gotten from flat earth is that they have motivated me to check and to see that my beliefs are as correct as I can possibly make them.
Our goal is, Britt, is to open your mind so you can see what's going on around you. You know, we see one thing we all have the ability of is we see through bullshit. You know, a lot of people don't have that. Most people are naive by nature, but there's a breed of people who see bullshit on its face. Usually good poker players like David and shit like that. You know, you see something and you just know it's bullshit, but most people don't have that. We're trying to share that with y'all, and we show you things, and you don't accept something for even with y'all's own evidence. Like Lael earlier, I said Michael Collins said, you know, he didn't remember seeing any. Lael would not accept what Michael Collins said. And we're just trying to teach you to open your mind up. So if you come away with nothing at all, just try and get this. Open up your mind. Try to see the bullshit.
Yeah, Brenda, our goal is to open up your mind, and the University of Minnesota's goal is to open up your wallet.
I'm paying $40 for it.
Damn, that's cheap.
It's because.
Well, Brenda, I do hear what you're saying with that.
It's because
I think, yeah, that I would say that what you said. Sorry, just what you said is, I mean, that's one of the core components of, like my interest as well. Like part of what you said, like truth and sharing information and knowledge. Because to me, if we're all together, there's more potentials to. It's like I kind of see it like it's like tending a garden, and it's like we're all throwing in our seeds. And then I throw some seeds, you throw, you know, we all do, and we see what grows. And then, you know, maybe I'm attracted to something someone's saying, or I resonate with it, or I can learn from it. If, you know, on one level, if something else, if I'm not, you know, then I could just, it's like, you know, take it or leave it kind of idea. And I guess for me, I just don't have any interest in convincing anyone. So I'd rather just hear all the ideas really more for myself. Seems like some people are more outwardly projected, like they want to convince someone. Whereas I would say for myself, I just more want to like actually have as much information exchanged so that I could potentially learn something, potentially add something to my tool belt, you know, of information. Even if I'm not going to be an expert in that thing, I can still learn something.
So number one, because I'm older, I get a special seniors discount. However, so I can take courses, so $10 a credit. So a 4-credit course cost me $40. However, I don't receive a grade for it. It doesn't, at the end of the day, it doesn't really count for anything, but I enjoy it.
Do you still have to pay like enrollment fees for like using the transportation or
Well, I have to pay
like
for
the
my.
exercise facilities and stuff like that?
Well, I haven't used those. I pay for my own bus fare. I had to pay for my own. I had to pay for my own books. The books cost about 3 times more than the tuition did. The last book I bought was $107. It's highway robbery.
Yeah, the university textbooks are a scam.
Yeah.
Yeah, I used to pay well over $1,000 for a whole semester.
Well,
at my undergrad, I think it was at least that much. My graduate school, similar, but maybe, not quite, because I think the undergrad was more like some of these mainstream big companies, and they just charge unbelievable amounts. Whereas in my grad school, I think those were more like just.
Shit, I used to pay like $650 per class.
Well, I just remember just books. Like in undergrad, it was like over $1,000. It was usually like $1,500 to get all your books.
Damn. Yeah,
it's crazy.
Yeah, they'd be making money.
Damn, I just thought of a good idea for the electric motor. Son of a bitch.
Well, they just have it monopolized, so it's like, hey, if you're here and you've already paid the tuition for this whole college, then they just assume you're going to pay for the books, so they just charge double what they probably should be, or more than that. That's what I'm saying. Most books are 15, 20, 30, whatever they are, but like they're all just like 150 and stuff. It's crazy.
I had a couple classes actually where we had to buy the book, and then the prof barely used it. He had his own notes, so like we barely used the book. I think we used it just for like some like class quizzes, surveys, where you use a little clicker and you give your answers. But aside from that, we barely touched the book. We had to buy the clicker too.
Hard to change, but another thing, if I got anything from this, even if they were to get a rocket to go up, like they got the go fast to go up like 72 degrees, what did we find out? We found out that the shit gets cold almost down to absolute zero up there at like 71, 72 miles. We've seen actual readings, not shit from the government. And so if they could get higher, if there's nothing stopping them, and they can get higher and ever even prove it was a globe, I can still say I got this. And I would hope Brenda would listen to this. Like, the shit from the ISS they show us is garbage. Even if there is an ISS up there, that shit they're showing us is bullshit. Okay, and even if they went to the moon, I say they didn't go to the moon because I can see right through that garbage. And even if they did go to the moon, what they're showing us ain't it. I could see right through it.
Well, I think you're just mistaken about that. So I don't think that the images from the ISS are garbage. They're beautiful.
Brenda, and one of them, a teddy bear beams into the picture. It's for kids, right? But they use special effects to beam a teddy bear into the top right-hand corner of the screen. She grabs it, she spins it around, and then puts it back up in the top right-hand corner of the screen, and it beams out of existence. That's a slap in the face.
I do have to say, Brenda,
that doesn't prove anything. That doesn't prove what you think it does.
I'll say this, Brenda, for me, even if I just remove any thoughts of cosmology or shape of Earth or just anything, right? Even just remove all that. And if I even remove all my just biases or any ideas or anything like that, and I just take it straight up, that footage and everything that NASA gives us, to me, is not even in the realm of being real. Meaning it's not even in like the field of possibilities. It's so, for me, I'm just saying for myself, as I've looked at everything, it is so 100% clearly fabricated. Whereas I would say the opposite. Like some people say, well, how do you know China exists if you've never been there? That's fair. However, in terms of what is available of pictures, people, culture, there's so much that's very verifiable to see that it's real. But in terms of the quote unquote mistakes that NASA makes, they're so thorough that for me, there's no question that it is not authentic. So it's always interesting to me that some people can watch it and say, "Oh yeah, it's real." You know, it kind of blows my mind. I mean, I respect everyone and their viewpoint, but I mean, I've looked at a good amount of it all. I don't know, you know, perhaps people have looked at different amounts, but I mean, I've gone through it more or less with a fine-tooth comb. I mean, maybe not as deep as some people, but whew, I mean, the moon landing, when I first did that back in like 2004, 2005, I spent like a month or two researching it, and it was like, I got to admit, at the beginning, I was on the fence. I didn't quite know, but at the end of it, it was just slam dunk case for
what's your evidence?
Fabrication.
What's convinced you that the ISS or the moon is fabricated?
They caught the wire. Hold on, Brenda. They only caught the wire off one reflection. You know, the wire coming off their suit. They only got one picture of that, but it kind of give you evidence. There's a wire when a guy tries to pick up a hammer and can't lean over. He backs up 3 steps, gets a running start, jumps up in the air to try and bend down to pick up a fucking hammer. Excuse my language. He still misses. It took him 4 tries to get up enough momentum to jump high enough to bend down to pick up a hammer. That's all I needed to see to know that what they're showing me ain't real. Whether they went or not,
how do you know?
Maybe. But what they're showing us ain't it. I promise you, I'd bet everything I own on what they're showing us ain't real.
But how did you decide that it's not real?
Well, for me, it was analysis, basically looking at the footage that's presented, going through it, like I said, in detail, hearing other people's commentary on certain footage as well, watching just hundreds and hundreds of hours of different. I could literally make. I could probably 200 proofs. I could probably list 200 fundamental, not just flaws, not just individual flaws, but fundamental entire categories of flaws. For example, the on-the-fly editing, green screens, the virtual reality in the ISS, on the moon. I mean, the list is so long of so many.
What's your biggest and best proof that?
Okay, mine is I live right by the Space Center. I'm about 110 miles north of it. So when these SpaceX rockets go north, I see them go up from a distance, and they level out about where airplanes go, and they go. And they get, and they're going, I've got an orthographic view of the rocket, and the son of a bitch is going down, okay? I'll be generous and say it's 15, 20 miles up, but probably more like 10, maybe 15 or 20. I'm watching it go sideways, and I'm watching it get lower. I see the wires. I'm looking out at wires, and I see the rockets. The wires in front of my house that are, pretty well parallel. So I see it just work its way down lower and lower and lower underneath the wire. And then it works its way down, just gradually getting lower, just like a fucking airplane does, And
then it disappears over the horizon, right? Is that what happens?
When I see a real rocket, they shoot them straight up. If it's only going 12 or 20 miles high, how is it getting out into space if it's not getting higher?
Does it disappear over the horizon, Brian?
I lost it in the trees.
It disappears over the horizon then, right?
She said it didn't, but I don't think. We have an artificial horizon, Brenda. To be perfectly honest,
I don't know what that means. So, did it disappear over the horizon or not?
Brenda, I have an artificial horizon. We have trees, okay, where we're recording from. We have trees, okay, right. In that direction. So it disappeared behind the trees. So yeah. My horizon would be the trees, yeah, it did. Right. But it's not gaining in altitude, Brendan, was my point.
How do you know?
Because I got an orthographic view. I'm directly north, okay, of where it launches, okay, and it comes up to the north, okay. When it gets closer, it's supposed to be getting higher. Like an airplane, as it gets closer, it gets higher. So it does that a little tiny bit. But as it starts to get real close to me, it starts dropping down. It's not perspective. Yeah. It doesn't work.
That's called perspective, Brian.
No, it's supposed to. Instead of getting lower, okay, the airplanes.
You just said it gets
lower.
They
continue getting higher until they get level with me, because my house is facing directly east, right? So picture my house facing directly east. I'm looking directly east. The shuttle's coming from directly south. Okay, not the shuttle, but the rocket. Okay, now, so I'm watching it. Basically from an orthographic view, it should keep getting higher until it gets level with me, closest to me. But it doesn't.
No, that's not what you would expect.
That's what happens with airplanes, Brenda.
No, the airplanes go into the artificial horizon too, don't they?
I'm talking about when it's coming into my view, when it's getting up
Brian.
north. I'd like to time it one time. And what pisses me off is I never timed it because I could almost tell you how fast it's going. I can give you an idea how fast it's going because they're launching it down there. That much I don't deny.
Do
But it's
airplanes
just what they're
also
saying.
do airplanes also disappear into the artificial horizon, the trees?
That's not my point. My point is,
Do they?
is airplanes get higher as they get closer to me. That rocket ain't.
Do airplanes disappear into that artificial horizon, the tree line?
I told y'all, she'll disagree with anything I say. Yes, everything that goes away from me that's above the tree line, Brenda, everything.
Yes, that's
the
called
sun included, the
perspective, Brian.
stars, airplanes, birds. Listen, Brenda, I'm answering your question. Everything that's above that tree line, everything, no exceptions. The sun, stars, airplanes, birds, rockets, you name it, it disappears behind
That's called
that
that's
cloud.
perspective. Brian,
Now you answer my question. Now you answer my question. Doesn't everything getting closer to you up above the tree line get higher as it comes in nearer towards you?
The rockets aren't getting closer to you. They're far away, Brian.
See, so we try and give them information, they won't have it. They just won't have it. This is what I meant earlier.
Far
I try
away,
to tell them
Brian.
they won't have the information.
Brian, the reason it disappears into the tree line is because it's far away. It's going over the horizon.
I'm not denying that, Brenda. So don't ever say that again, please.
So
I agree with that. I'm not saying that it's dropping down like that. What I'm saying is it's supposed to be getting higher as it gets closer to me.
No,
Okay?
it's not getting closer to you, Brian. It's getting further away.
So it's launching straight over to fucking London then, right?
Well, I don't know if it passes.
You don't know, so just listen to what I'm saying. I'm north.
Does the path
I'm
take
north.
it over London? Does the path take it over London? Then yes, it does. It's going away from you, over the horizon, around the curve, and it will pass over London. Yes.
Dude, she's the straight still, y'all. I don't know what to say. I'm gonna back off.
Yeah, it's pretty uninteresting, Brenda. I just
repeated what he said.
Yeah.
I did. I just like with the crepuscular rays thing. I've demolished flat Earth.
I mean, it's almost as if you view, like, in terms of your speaking here, like, it almost seems like you view it as just a quest to try to deny everything, rather than like a give and take where there might be ideas. It's just every time. Well, here's why I say that, because every time someone says anything, you scream no, and then you start shouting about how what you think they said is just wrong. You know what I'm saying? Rather than, like, maybe they say something, okay, and then you maybe say something that you have to say. You know what I mean? Instead of actually having a back and forth where ideas can be put on the table, it seems like you just have an agenda to do that, which is coming off as kind of a disruptive troll kind of energy.
So the problem is that you're not entitled to your ideas, to your opinions. And you have this feeling of entitlement that any ideas you have a right to be taken seriously, and you don't have that right.
Everybody has that right, Brenda.
Yeah, everyone does.
No, you only have the right to those ideas that you can successfully defend.
But you can't thought police everybody like that. Then they don't have the right to think something.
By that I mean you only have,
Sorry, go ahead.
You only have a right to those ideas that you can defend logically and rationally. Of course you have the political right. You have the political right to believe anything you want. You have the political right. I'm talking about intellectual rights.
Yeah, no, Brenda, but let me give you an example. I just told you that I don't have a horizon. I have trees, and it went behind the trees. Then after that, you started asking me 5 times, does it go beyond the horizon? After I just told you that I don't have a horizon, I have a false horizon of trees, and yes, it goes behind it. You then just shut your mind down, and you're trying to tell me what I'm seeing when I'm bringing that up as my evidence, okay? You just shut down and
So
started
not
asking
cool.
me a question that I already answered and trying to use that as proof of some kind of point. It's demented. I don't know what to say.
The proof is that you don't understand even what perspective is. That's the rocket is moving away from you. So yes, it goes down in your field of view. That is perspective.
It has my house to get north. I'm technically a little bit northeast of Kennedy. Technically northeast. It goes parallel up the coast of where I'm at. I told you that. You just won't hear it. Okay, so it's got to come. Listen, it's got to come north, Brenda. It's got to come north to pass me. Okay, so when I walk out my door that's facing east, see, you're shutting down again. When I walk out my door that's facing east, out toward the coast, okay, it's got to get north, to get level with me north, it's got to come up the coast and get level with me, just like the airplanes that come from the south do. They get higher. What I'm telling you is they get higher and higher in my view until they get as close as they're going to get to me. Then they start down as they go away from me.
Right.
I'm not denying that it went down and perspective causes that. My point is it should match pretty close to what an airplane does, shouldn't it?
No, it shouldn't, because the airplanes are close to you, and the rocket is far away. It's hundreds of miles in the air and going over the curve. It's going over the curve.
What curve?
The curvature of the Earth.
So about the CubeSat, there's a 700. I've put a video out. 700-mile chain of CubeSats going in a dead straight line. So you're going to also call that perspective a dead straight line. You could draw a pencil-sized line from the first one to the last one, and 700-mile stretch. I don't know if they had upgraded to 1,100-mile stretch yet, but I know it was 700 at the time. Okay, and 700-mile. And also, if I look to the very right CubeSat and the very left one, they should be lower due to perspective, right? But so it should be exaggerated. The Earth curve should be exaggerated in that line of CubeSats, and it's just a dead straight line of whatever the hell they are. Just go and follow the leader.
Are they
You're
passing
going to
over
also call. He's going to also call that perspective. So she's going to step on her own tongue.
Are they passing over you?
No. Same scenario. Out in the distance.
Yeah. So it seems to me that like you expect an awful lot from your eyes to be able to see things that eyes probably can't see and measure.
It almost sounds like Earth curve is getting equated to perspective, and I think that's the contention, right?
No.
That's
it's
exactly
not
the contention.
No, it isn't.
Yeah, it's Jack perspective. That is, you've heard it a million times, Brenda. The math matches Earth curve. The math matches Earth curve to perspective. Y'all call it coincidence, and we say no. We're trying to look beyond that. What if it ain't? You know, what if you 20 years from now you're on your deathbed and they finally get the go fast rocket to go up there high enough to finally show y'all, and you've been arguing and just wasting all this time.
I don't know what the go fast
like an enemy of humanity. What if you're wrong, Brenda?
I don't know what the go fast rocket is. What is that? What is that?
What
A rocket that goes fast.
What if you got enough proof? What if we were to triangulate the sun, or just any solid proof that you couldn't deny? I mean, we know you'd still deny it, but if somebody reasonable finally come out, I'm just being hypothetical. What if you're wrong? Is my point. What if you are wrong? All this stuff is up in the air as far as we're concerned.
Well, you are, but I'm not. I don't think it's up in the air at all. It is a well-established fact for the last 2,600 years that the Earth is.
Science has said that since the beginning of books, since they could write down shit. They've always said that, Brenda. Now, if science says that, we know this, and it always changes. Cosmology always updates and changes. We always get more knowledge, and then it takes something special to get a paradigm shift, but they always come, Brenda, every time. We're upgrading. We're learning everything is electrical. We're learning that the sun is electrical. We're learning.
No, we're not learning that.
We're learning that our perspective is matches Earth curve. You know, what we see, even the math matches Earth curve. And you know, you just get with the times is what I'm trying to say. Open up your mind.
I am with
Consider
the
the fact you
times.
might be wrong. You know,
I am with the times. You're stuck in the past. You have an antiquated, dogmatic, religious belief in the flat Earth.
no, that's not true. Not even at all. You're projecting. You can't deviate. You can't concede one fact because you're stuck. You can't learn nothing new because you're stuck. You just got to learn what they're telling you. You got to read your book, and you know, everybody's gonna, you know, just you regurgitate the stuff, and people are, oh, he's smart. He memorized the most out of them books. We're looking for new knowledge. We like to explore. And to do that, you got to keep an open mind. And you know, talking to you, man, is
I'm
like
open.
the opposite of that.
Okay, my mind is open. What is your experimental evidence for the flat Earth? Where's your measurements?
Myself, I've not even been 2 miles. I've done short range surveying my whole life, pretty much. I've worked an auto level. I've used it almost every week, but I've never done no big giant projects. So I can't say for sure, but I do know this: we went down the coastline to looking for Earth curve a long time ago when I first heard about this shit, and I just got monotonous. I'm like, when's it going to start curving? You know, but we gave up early. I wish I'd have went a few miles. But
Well, you know
then I
what?
found out that people who did claim that it's flat and went far enough, they just said that they were shooting their way around the globe. That's how I looked into all the survey, and I found out that they're just using the radius. Geodetic surveyors are literally just using the calculation from the radius to make their model.
I'm just asking for your evidence, your numbers, your measurements. Do you have any?
Okay, since you got an open mind now, you're opening your mind. I'm gonna start you off by
Yeah.
looking at all the NASA blunders. First, seeing that what they're telling you.
I'm
what
interested.
they're telling you,
I'm not
you gotta
interested.
start there, Brendan.
No, I'm not interested. I want to hear your evidence that shows the Earth is flat.
Mirror reflections, laser beams.
What?
Long distance photos, black swan. Okay, just
no.
What do you see when you walk out your door, Brenda? How does the Earth present itself to you on a day-to-day basis? That should be all the evidence you need. At least look into it.
I don't start with my conclusion and look for confirmation.
Okay, well, if the Earth, let me tell you, slam dunk. If the Earth is a globe with a radius 3959, then every horizon can be no more than 1.22 times the square root of the observer's height in feet. We have slam dunk that. They're everywhere. Black swans, we call them.
I understand.
They're
I
everywhere.
understand the argument.
Okay?
I understand it.
You say the Earth is curving and light spinning. We say no, just light spinning, and we can prove it. The shit moves up and down. Okay.
So, Brian,
you asked for evidence. I just gave it to you. It's slam dunk.
Yeah, the argument is fallacious because it is a straw man, because the globe model does not say that every horizon will be no more than 1.22.
The geometry dictates it, though. Listen, Brenda, if you're getting all your measurements from geometry and you're saying that it's bending, that light's bending, that's your excuse, then you have no geometry. So therefore you can have no radius because it's all optical. Is the point?
So no, that's all fallacious. Again, the globe model does not say that all horizons must be no more than 1.22. In fact,
the geometry, Brenda, once again, the geometry claims that. So you have no geometry. We've disproven the geometry. And let me say it one more time.
Say that, Brian.
Yes. Go to the Earth curve calculator.
I get to say what the Earth hypothesis is. It is not what you said. In fact,
you don't get to say what you don't get to say is what geometry dictates. You can give me an excuse of why we could see that far, but all the argument does is debunks the geometry. Your geometry is flawed. Now you can give me an explanation, but we've debunked the geometry of the globe Earth.
You did not, right? Because the actual argument is that every horizon can be no less than, not no more than, no less than 1.22.
And around we go.
Right? So that's the actual.
But she says she has an open mind, and then she says something like that. She says, "Okay, I'm gonna open my mind. Give me some evidence." I just give her evidence that solidly shows that the geometry is not valid. Okay.
Yeah.
I don't. You can tell me why. I don't care why, but I've showed you that the geometry is not valid. And
yes,
and
I understand.
You trying to flip it on its face. It's unbelievable.
I understand, but you're wrong. It doesn't show that. Because it's fallacious. It is a straw man. You have straw manned the globe model. The globe model says, the globe model doesn't say that every horizon can be no more than, it says it can be no less than.
I don't think that's correct.
Yeah, it is correct. So when we're talking about every horizon, we mean geometric as well as apparent horizons. And so the apparent horizon can in fact be further than the geometric horizon.
But would you agree with a measured distance is not affected by refraction? It might make it look funny, but it doesn't affect an actual measured distance.
Yeah, but the black swan photograph isn't a measured distance. It's a relation.
Well, there are measured distances based on the oil rigs, right?
Yeah.
So the horizon is apparently behind those measured distances.
I don't know, maybe. The globe model says that the apparent horizon can appear to be further than the geometric horizon.
Right, but it can't be closer than a measured distance.
The globe model says that the apparent horizon, that's the horizon that you see in the black swan image, can be further than the geometric horizon. Nathan Oakley is lying to you. He's lying to you.
The geometry, I don't know how many times I got to say this. Geometry, Brenda, dictates where the horizon should be. Now, you can give me any excuse in the world
No,
you
it
want,
doesn't.
but you can't deny the geometry is broken.
That's wrong, Brian. The geometry doesn't determine where the apparent horizon will be.
You can tell me why the geometry is broken, but don't call Nathan a liar when they have proven that the geometry is not valid.
No
It's
such
not
thing.
valid.
They've done no such thing. The geometry, the apparent horizon can be further than the geometric horizon. That's the globe model. If you want to refute it, you have to refute our model, not your straw man of our model.
Well, so are you saying that the Earth curve calculator is incorrect then at that point?
No, it's not.
I would argue it is if that's the case. That's just me.
Why?
Well, because if that modus tollens is correct, do you have a problem with the modus tollens in that argument then, and not the picture, or what?
The first premise is false because it strawmans the globe model. The globe model says that the apparent horizon can be further than the geometric horizon due to refraction.
Well, then you have a problem with the Earth curve calculator. That's what I'm saying.
The Earth curve calculator takes that into account. There's no problem with it.
It almost sounds to me like you're saying, like playing two different sides of the coin.
No. The Earth curve calculator is accurate.
Okay. Well, then the 1.22 and all of that gives you a geometric distance, right?
Yeah. Yes, you're right. It gives the geometric distance, not the apparent horizon. That's why I'm saying that Nathan Oakley is lying to you, because he is deliberately confusing the apparent horizon with the geometric horizon.
So the horizon moves around, right? So the horizon, what you're saying is the horizon moves around, right? That's what we're trying to tell you, Brenda.
The apparent
We're trying to
horizon.
tell you the ground isn't bending. The light is bending, and it can make the horizon further or closer. That's what we've been trying to tell you for years. You just won't listen.
The apparent horizon.
By the way, hold on. I got to say something first, Brendan. Hold on. Please don't slander people on this server. You're talking about trying to call people liars and stuff, people that aren't here and stuff. Please don't do that.
The apparent horizon does move around depending on the weather conditions, whether or not there is a lot of looming and refraction going on. It can move around. The geometric horizon is always there. The black swan argument deliberately confuses those two.
You can't prove the geometric horizon is there if you don't have the geometry. That's the whole point of the black swan. I rest my case. There's no way around that. You can't prove the geometry if the geometry was broke. And they proved the geometry. They proved that the horizon is apparent. It moves. Okay, so you cannot apply geometry to the horizon anymore.
I don't know what you mean when you say the geometry is broken. I don't know what you mean.
It means that. So I think it means that it's. Sorry. Go ahead, Brian.
No, she said the geometric horizon, like it moves around. That's the whole point of the black swan. The geometric horizon is no longer. You could say the horizon all you want, and I'll agree with you. But the geometric horizon has been debunked. There's no geometric horizon, okay? It's not geometric. It moves around.
I didn't say that, Brian. The geometric horizon is determined, right, by the curvature of the Earth and the height of the observer. The apparent horizon moves around due to refraction.
There is no geometric horizon, okay?
The horizon is apparent.
No, there is a geometric horizon and there is a apparent horizon.
Well, can you ever go to the geometric horizon?
Of course you can.
It's always in front of you. There's no way you can ever get there.
Well, relative to you, so you could theoretically you could like have a friend walk out with a stake, right, and go walk out to where the geometric horizon is for the other person, but his geometric horizon is going to be different. So again, there are two horizons at least. There's actually 3 or 4, right? There's the celestial or astronomical horizon, there's the geometric horizon, and there's the apparent horizon.
Brenda, instead of spending money on college, go buy yourself a camera. If you take the time to buy yourself a good camera and go out and make these observations, not over wavy shit like B-ball in Hawaii or shit like that, but over calm bodies of water. Go make observations over calm bodies of water, and you will see there is no Earth curve. Okay? You have not done this. So that's hard to convince you. I understand.
How would a camera show me Earth curve?
It won't, because there isn't any.
No, the way I could prove Earth curve would be if I bought a drone and I took a picture at, say, my eye level, 6 feet, and then I sent it up, say, a couple hundred feet. Then I could see further. That would prove curvature.
Would it curve from left to right then? Oh, sorry, I didn't mean to interrupt.
I mean forward and backwards.
Brenda, the Brenda criterion, okay, matches the globe math. Okay, it's not a coincidence.
How come I can see further the higher I am?
Brenda, listen, if the ground's going away from you, level, off in the distance or the water, it's not gonna just get so high that you don't have a horizon, Brenda. You're gonna lose the ground, okay, when the angle gets too small. And then that angle just happens to match the globe math. Do you really think that's a coincidence?
So how can I see a sunset twice? I could see a sunset at eye level at 6 foot, and then I could get a drone and I could send it up 100 feet and I could watch the sunset again. How is that possible?
We've literally demonstrated that in 3 different ways.
How is that possible?
Rob Steven demonstrated it, and 2, Guy Freed demonstrated, and 3, Pebbles on the Pond demonstrated it just by opening a garage door and watching the light disappear. We have demonstrated that 7 ways from Sunday, 3 to be technical.
No, that
and
doesn't prove
give you
anything.
3 actual observations of refraction of lights disappearing, and you still just won't. I mean, you just won't even. You act like you just won't even look at it.
Because that doesn't prove what you think it does. So
No,
how
we
is it possible?
agree, Brenda. We agree light bends, okay? So refraction, especially over long distance.
Refraction. There's no refraction going on. I'm not talking about refraction.
That's how the sun sets. It gets lower as it goes off the distance, and then it refracts. You look at it when it sets. It's never
How the
perfect.
sun sets.
Oh,
Brian, that is not how the sun sets. It
Brenda,
doesn't.
you'd be surprised. You can only see an actual sun go over the actual horizon like about once a month, maybe twice a month, and maybe none the next month, maybe 3 times the next month. It's rare that you see the actual ball of sun. But when you do, it's always distorted and refracted to oblivion.
Not
usually
always.
it goes over to, usually it disappears into the cloud deck. Okay,
Right,
you'd be
so what does that
surprised
have
if you
to do
go
with
out and make
anything?
these observations, Brenda, you're not going to see what you think you're going to see.
The sun does not set because of refraction. That is not how it works. Right?
So-
The sun sets because it is obstructed by the curvature of the earth.
But how do you square that with perspective?
Why? Perspective is a completely different phenomenon.
Well, I'm putting an image in Livestream text 1. And I know it's not a perfect example, but you can kind of see that the sides of that, like from the top to the bottom of that cathedral hall.
Yeah, that's
not setting.
perspective.
Right. So it's not setting. You wouldn't say necessarily the bottom of that is setting. I think that's what trying to be relayed is that if you imagine that would be the sun at the top, it doesn't necessarily go to the bottom.
So with the sun, you can sometimes see only half of it.
Sure. Well, if you were to I'm sorry, go ahead.
Because the lower half is obstructed by the curvature of the earth.
Right. So if you were to extend, like imagine if you could extend that picture a little even further, you would see the same optical effect.
No.
And it sure
you would never see half of that end entryway obstructed unless there was something between you and it.
Well, it sounds like fallacy of stolen concepts, because it's almost like you're arguing against the point that your argument relies on.
My
because
argument does not rely on perspective.
Well, you're claiming one thing at one part, and then you're arguing against it in another part.
No, I'm saying that perspective is a completely different phenomenon from the sun setting. The two are different things.
How do you differentiate those two without without assuming something?
Well, in perspective, in the image that you posted, right, that entryway at the end simply gets smaller.
Right.
Right. That's not what's happening in the sunset. It's disappearing. It's obstructed.
Do you not see how that kind of conflicting
No, I
it with
don't.
itself?
I don't see that they're completely different.
I'd kind of like to get a different conversation going. Kind of the contrarian Brenda thing is getting kind of worn out at this point.
Well, all I am doing, and all I've ever done, is relate basic high school mathematics and science. That's all I've ever done. your inability to understand these
Okay,
concepts.
stop. I was
isn't
going to say, just
Not
stop,
bad.
stop right there. Just
Don't even
stop.
understand the geometry
Inability to
of
understand
a
stuff.
simple radius.
You don't. You don't
Stop.
understand them.
Brenda, come on now. None of these backhanded, underhanded, passive aggressive insults are going to help anybody.
Brenda, does understanding.
Brenda, what's the sine of 30 degrees, Brenda? Just a simple question. What's the sine of 30 degrees?
Brenda, does understanding something make it true?
Brenda does not. She's going to say we don't understand. She does not understand high school mathematics. I promise you. She can't even answer simple shit.
We can't go back and forth with that part of it. I mean,
I know she's going to act like we don't understand, trying to belittle us, and I could easily prove that she doesn't understand it. She doesn't understand the geometry from the radius. I just proved that. She said that it would have to be shorter. She literally said that the horizon would have to be shorter, according to that math. I mean, really? But I'll digress.
yeah, looks like she bounced out just now.
Well, that's too bad.
Sine of 30 is 1/2, by the way. Or 0.5. I just got somehow another channel opened up. I don't know how it got there or what, but I heard Pete and Peyton That's a Shield and Rumpus. They were holding a conversation, but I couldn't hit talk. I couldn't hit mute. I couldn't get out. I was looking like in live text room 2, and I wasn't getting nothing. 3, I couldn't get in there. And finally, it just stopped. I don't know how that even happened. Are they on another channel on this server? Because I never left Discord. I never left this channel to my knowledge.
I'm not sure what you mean exactly.
Did I accidentally hit another Discord that they're at right now currently, or are they on Earth Awakening? I'm just curious.
Your mic just kind of went out, Brian. It's like real quiet, muffled. Something happened.
No, I'm asking. Are they? Was that something recorded or another channel? Did I accidentally hit another button, or are they in another room here in Earth Awakening?
Did you have the YouTube stream on maybe at the same time?
No, I mean I could double check. No, it didn't. I must have hit another room on accident, but it was exactly similar to this. But I don't know. I don't know. It's weird.
Must be sunspots. I didn't hear anything on this side of it.
It is possible to be in. You can be in two channels, I think, like with one with a computer and one with a cell phone. I don't know if you mean that.
This is weird because I was pacing around to try to get a signal pretty much with my cell phone. I got the page on that mutes and unmutes, kind of in the middle of going back and forth with Brenda. And all of a sudden I started hearing Rumpus and Brenda, like they were talking over each other. It didn't take me long to realize, hold on, this is something different. And I still have the home screen where I can mute and unmute and see everybody's name. Never changed screens or nothing. That was weird. Then it dumped. I hit leave the call. I hit the red phone signal to leave the call, and then all I could hear was Rumpus and Pete Shea and Peyton That's a Shill, and I couldn't figure out where they were at. It wasn't YouTube, and I went to live room 2, live room 3. It didn't appear to anybody be in there, but then it just went away, and then so I rejoined. I didn't want to be a distraction, but that's weird, very weird.
Maybe you got fillings in your teeth that are catching different CB radio ham signals or something from Discord. I didn't hear it on this side. I'm just saying. Funny.
Get Rumpus pinned down because I really want a response for that. Like, okay, if I'm gonna fly off at 1,024 whatever miles per hour, that means that gravity is holding me down. Despite that, the gravity's outpowering my velocity or my tangent, my angular velocity or whatever you want to call it. And so it's outpowering. But if the Earth stopped, I'd go flying off at 1,000 miles an hour. I guess gravity would catch me, according to them. But initially, I'd fly off at 1,000 miles an hour. But what if their Earth kept spinning, but gravity shut off? Like, just hypothetically speaking.
I saw a thing. I saw a thing recently that actually I'm hearing feedback to myself right now, so it might be whatever setup you got, Brian. But I did see a thing recently where Neil deGrasse even said if the Earth stopped spinning, we wouldn't go floating around. We'd just be the same. So to your point.
Yeah, I've asked a lot of them this, and they all agree that if the Earth stopped, I mean, they'd be arguing their own math. If pretty much, if the Earth stopped, then I would retain that momentum. That's their main argument. I mean, you'd have to agree with that. They go crazy over the fact that they try and put you in a car that's going straight or a plane that's going straight. You got to remind them every time. They say you want to feel an angular change, but if something's rotating, you would absolutely feel it. They always leave that out. No matter how many times I correct them, they always leave that out, that they're saying we're rotating. That is an acceleration. Leave that out.
Well, it's a constant acceleration.
They love to say, sorry.
It's a constant acceleration, right?
Momentum, right? Sorry, go ahead.
I was just going to conversing with you, I was kind of going to your point of it's rotation is a constant acceleration, isn't it?
Yeah, by definition, because it's constantly changing directions. If you're changing vectors, you're accelerating. But the main point is they all say, I mean, they love to remind us that we're conserving momentum. Okay, so if the Earth slammed on brakes, we would have to initially fly off at the speed we were going, or we wouldn't be conserving momentum. You see what I'm saying?
Yeah, trees would fall over.
That brings a lot of questions, because even a balloon. So if they have the Earth and the atmosphere spinning at once, so a drone in the air would also have to fly off at 1,000 miles an hour initially.
Blood. Yeah.
But all that, and they say that we're only like a quarter of a pound or a half a pound lighter at the equator. So, I mean, we need to make some kind of modus tollens out of this shit. That is a complete contradiction. If the spin is dictating that I'm basically getting pressed outward at 1,000 miles an hour, of whatever it takes to project me 220 pounds, freaking 1,000 miles an hour. That's a big force,
Yeah, centrifugal forces outwards, isn't that right?
Even if it's partially linear, even if they want to make that argument. But yeah, it is. It's outward, and they all say outward. But even if they wanted to try and say it was straight at an angle, it's still me getting flung 1,000-something miles an hour. They have to say upward because gravity is the only thing that would combat that, right? I would think.
Yeah, I think the thing that even Brenda was saying, well, the globe model says this, and I think you can only argue against a model for so long before the model, it's not arguing reality, no matter what model it is, so.
Right. I was trying like hell to pull her away from the model, and get her into reality, tell her the geometry, and get her to think about pictures or things we could see, but I try to pull her away from the model.
Well,
we're always arguing the model.
Yeah, 100%.
I already have a modus tollens.
Yeah, let's try that. Hey, sorry, Essie. I was just gonna say, hey, Brian, I've heard you. Big fan, long time listener, first time caller. Good talking to you, man.
Yeah, absolutely, man. You brought up a couple of good points in a short period of time. I'm curious to hear Montreal's modus tollens. Hang around.
Yeah, right on.
Yep. So listen to this. If the Earth is spinning at 1,000 miles at the equator, a plumb bob would not hang plumb.
Let's work on that, Essie, because I think you can't do future projections in a motor like when you say would.
It's kind of late, so I have it written down. I'm not saying it, precisely, but you get the.
For sure.
If you have a spinning platform, a plumb bob cannot hang plumb.
It would always have a bias, wouldn't it?
I think Level Earth Observer. Level Earth Observer is a crane operator, and he put out a challenge, to anybody who could get a plumb bob at least 5 meters high. I think he said, it ain't got to be that high, just 5 meters high at least, and try and move it at all without it moving. If I'm not mistaken, that's a good point, Essie.
Yep, there's no way around that. If you got a spinning platform, a plumb bob will not hang plumb.
Well, that's something that could be demonstrated, right?
Yeah. Oh, yeah. I challenge anybody. Make something rotate, put a plumb bob on it, and make it hang plumb.
Even an ant carrying a plumb bob on a basketball.
Yeah, even that, yeah.
It kills me. They have a way in their mind of thinking that they try to equate the Earth spinning to a damn clock. Like, look, if you take a jump rope and you spin it just barely, it's not going to, let go. It's not going to fly off that far. But the longer and longer you make that string, it's going to be more and more velocity. The math even tells them, but somehow their brain won't let them realize the implications of something spinning that fast. And it baffles me how they attach the horizon. They just, even though it says on all that, the atmosphere is free to move, independently, and does, you got jet streams, you got freaking all the winds, currents, everything moves independently. We watch it, we experience it, and they just have to attach the atmosphere. Like it's unbelievable. It wouldn't be that bad if they accepted a container. But they have to insist the vacuum, man. How could their brains even not comprehend the problem?
I have a question for you, Brian. And I think everybody was a Glober at one point. We all grew up, with the same thing, with the same teachings. What was it for you? What was the thing for you that made you kind of go, wait a second, that's not, wait a second, hold on. What was it for you that did it? Just curious.
Man, I'll be honest, man. Thinking back, man, I try to think back. My problem, I always had problems with rockets in a vacuum in my head. They come up with a reason when they started talking about how they had to use other planets' trajectories to slingshot. I mean, that made sense. Like they have to use a trajectory and then propel to get that certain angle to go where they're trying to go. So that in my mind, that they were trying to say, that my mind found a way that they didn't have to try and turn in space. I already had so they had to get the speed right at a certain angle toward a planet, then spin around that planet, get a launch. I'd never bought the rockets in space because if you could push off nothing, then you might as well have a rocket motor in the rocket and just blast off a rocket inside the rocket, a rocket engine inside the rocket. You're pushing against nothing. Same difference, right? You should propel according to their logic. But they try and equate it to a bullet and a gun, which you could have maybe physical separation of matter. But then I took a wand and I hung it on a balance, and I had the propane jetting out. Right when I turned the propane, it moved the wand. The wand started moving, and then I lit it, and it didn't even budge. So lighting the shit on fire didn't give me any extra propulsion. So maybe they get a little teeny something out of some oxygen, but they can't get. But I think it's a good argument, and I will get to the point. But one more thing, I don't even think a gun would spark. The dude took gunpowder, and it wouldn't ignite in a shitty vacuum. He couldn't even get gunpowder to ignite. So how's the gun going to fire the bullet? So I didn't even bring that up when I was debating that a while back. I was like, maybe if you had bullets to shoot, you might be able to get a tiny bit of propulsion. But if you're saying you're letting out gas that is also being sucked, You know, everything about it was always wrong to me. So I always went in deep thought thinking, how are these rockets working? So I was like, but that was even to sleep, I had problems. So then when I just could, you know, I heard about flat Earth and I thought, yeah, you know, that's crazy. Look at the moon, look at the sun. And I watched a video, I don't know who it was, but, and it kind of vibed with me right off the bat when I seen the map. Cause I was like, how could you fly to Japan if the Earth is flat? You know, how could you go to Japan? I'd never even considered. I didn't even have it's crazy, you know, how you just don't even have any concept of how simple it would be to fly to fucking Japan from California. But me, in my mind, I couldn't picture how that would work on a flat Earth because I'm instantly thinking about circumnavigation. Like, so I'm thinking, you know, if it's flat, you can only go one way, you know. So I think that's what woke me up when I seen a video. I think it might have been ODD or somebody like that. And then, you know, I still was real skeptical. And I found out like GPS, all this shit, it's a model, all this surveying and shit. It's all modeling. They're trying to prove a globe with a globe model. They're trying to use the model to prove the model. So I realized that they're full of shit. And I always say that like Rumpus and Brenda, like, got me into flat Earth. They kind of sealed the deal when I went over to Nathan Oakley's and heard them. I was like, dude, this is the arguments for the globe. Are these morons? You know? But it was kind of Nathan Oakley too, also, you know, that just everything in general that sealed the deal when you start thinking about the logic.
Yeah,
it just kind of vibed with me.
One thing led to another kind of deal.
Yeah.
Yeah, same for me.
I already seen the, you know, I always thought, of course we landed on the moon. You know, I mean, I thought, shit, dude, they got to have moon bases up there. You know, we went 60 years ago. In my mind, there's moon bases. They're just not telling us, you know. That's how my normal mind thought. I literally thought that before I knew anything about flat Earth. I thought that there was moon bases up there. They're just not telling us, you know. And, but then all you have to do is see the footage. And that's all it takes. When you see the footage and you still believe it, then you know, you're indoctrinated, in my opinion. It's easy to see that that's bullshit. Even if they went to the moon, that's what I was saying earlier. Even if we went to the moon, that ain't it. You know, that's
yeah.
Right.
I think SC was definitely onto something. If we could put some Modus Tollens logical statements to the arguments, then it would be it's going to be game over. Just like QE did with the Black Swan. If we can do more of that, it's just going to prove logically, you know, that what they've been saying is complete bunk.
For sure, and then to use those for sure, yeah, and then to use those as a baseline for, you know, test experiments, research into the future as well is awesome. Because like, a modus tollens is only in as good as it's able to be verified in the physical world when it comes to this kind of inquiry, I would say.
We have them down packed. We have the water tollens and we have the spinning one I just gave now. Bev has the water one. How does Bev's go again? If the Earth is a sphere, then all water must curve. Something like that. I don't want to butcher it, but
the surface. I think it's the surface of water must curve.
The surface of water must curve. Yeah. Put that one with the one I just gave, the pendulum, the plumb bob. It's game over. Both provable. One with a plumb bob, and the other one with water.
Can you say the plumb bob one more time?
It comes down to vertical and horizontal, actually.
Yes. Yes. Basically, Brian, if you have a spinning object, a plumb bob cannot hang plumb. I have it written down somewhere the way I formulated it, but that's the gist of it.
Man, that gets me to thinking of an experiment. Like, I would like to mount a little platform to a clock and have it spinning real slow. But then I would want to make the string real long. You know, I mean, because technically it would have to equate to, in their model, like a 60-mile freaking string, which there's no way you could move that without the fucking pendulum moving. But I think we could probably demonstrate it with like a 20-foot string. I don't think you could even. I don't even think a platform moving the speed of a clock would be able to sit still.
Well,
It's
I think
impossible.
I think that there's a way that something was continuously in motion, then that would mean perpetual motion, which would mean free energy for everybody.
Exactly.
Man, they got free energy. I mean, basically,
Well,
solar
yeah,
is damn near free energy, man.
Is it?
I mean, I gave up on getting my generator to run on the HHO, but I got it to run for a few seconds. But but when I looked at it, I combined two generators into a T valve where I had double the freaking the HHO gas. But then after I took it apart not too long ago, I realized one of them wasn't even working. So I thought I was getting double the gas, but no better result. Coming to find out, one of the hoses was freaking clogged the whole time. So I need to, but they done rusted. I need to clean them off and make another one and clear out that hose, because I thought, I got it running for a few seconds. And so if I get these HHO generators, they got the adapter kits also that you can run them off propane. So I could just,
So
if
what
I
are you
had,
doing with them? The thing is, you would have to have just one amount of either water or one amount of propane to actually make perpetual.
It's on my channel. You can
The
go,
energy source.
You got to add
it's on.
something to it.
I'll explain it real quick. It's on my channel. You can go look at HHO generator attempt like number one. But what it is I got an old generator that I took the complete. So they didn't say I had gas in there. I took the carburetor completely off. Okay, where it's just the block, and I got a hose hooked up to the block. Okay, and then so the generator has like 4 outlets, right? Of 110. Okay, it's an old Coleman. Right now, the HHO generator I hook up to a car battery, basically, and I ran the hose into the block, and I got it to fire for a couple seconds, like 2-3 seconds. I let it build up a little bit, But then I was thinking, I got challenged and everything. It's hard to find time for this shit, but I got challenged enough to do it anyway. So I made another one out of a pickle jar. Okay, and with more plates, I tied them in together so to get double the amount. So here's the theory, D-Mont. The theory is if I can get the thing running off of the HHO gas, I could have two plugs. What?
No, go ahead. You can.
Yeah, you probably can, but here's my point.
Can you spin the car?
I can use the power from the two plugs to run the HHO generator, because I'm only using a car battery. So I could easily run a charger or 10 chargers to a battery. So I could use 1 or 2 of the plugs for the HHO generators and have 2 free plugs, I guarantee if I could get that far with it, they've already done this shit.
Well, they only try to use regular plain water, too. You want to put something in there.
Yeah, Mythbusters did that, man. I've seen the Mythbusters doing it right when I was in the middle of doing it. I almost stopped because I was like, oh, here's Mythbusters doing it. And they're showing that it's just barely trickling bubbles at all. But I was like, I'm already this close. I'm going to finish making it anyway. Then after I did it, I realized they didn't put a catalyst in. And they made this beautiful generator, but didn't know to add salt to the shit. And then they had a tank of hydrogen or the Brown's gas, and they sprayed it in the carburetor. And Jamie goes, look, he cranks the car up, starts revving it. If we could make the gas, it would actually work. But unfortunately, myth busted. We can't make the gas. And they was barely trickling, like one bubble every 2 seconds, like bloop, bloop, bloop. And I plugged mine in, and that shit's going crazy bubbling, dude.
I got an idea where you create your own vacuum and it does it itself. Like it'll pull the shit itself. It'll create its own. It'll do its own pull it'll be its own pump for like coolant. Because like when you do a magnetic motor for electricity, also, what you do is you can implement the magneticness and you can also implement the HHO at the same damn time, the same design.
I agree with you with the vacuum hose and everything. Man, like I said, if I could do this, if I could do it with a pickle jar, I was gonna say if I could get it to run for a few seconds with a fucking pickle jar First time I ever even made it in a battery.
No,
and I know
here's
damn good
the idea.
they've already got this technology.
Yeah, but you want to do it like okay, the pickle jar idea is good, but you want to do a 2-liter design, okay?
A what?
A 2-liter design.
Yeah, that's not a bad idea either.
Well, there's
Well,
a
the thing is, you don't want to have to
separate
add more to it, right?
Separate it.
Well, I want you to spin it.
Huh.
I want you to spin it while you're trying to do it and getting electricity.
Get it moving. That might be something, dude. Get it moving.
Yeah,
and
magnets.
also, I want you to have 2 tubes in there and have 2 tubes going like a snake at tornado pattern inside the 2-liter out near the opening.
Magnetic vortex.
Yes, sir. Yes,
now we're
fucking
talking.
Hey, but if it didn't work, it'd be cool as shit.
now you can add the hydrogen or the water or whatever, and you can add it in it. And what happens is it'll try to heat up and reverse, or it'll RMP, EMP, whatever, it'll fight back the other way. But when you have the coolant automatically sucking itself through the fucking center of the vortex, back up and out, you see what I'm saying?
Almost like a siphon at that point.
Yes, sir. And you can use helium, and it'll automatically separate it from the centrifuge, from the the suction. It'll vacuum it, and you'll get a reaction from that too.
I lost you. Hold on. I lost you for a second. I like what I'm hearing. I think. Did you say that you use one of the tubes for the air to cool the HHO generator?
Yeah.
Dude, that's a good idea, man. Because the fucker does get hot. I was running water on it. Dude, that's a good idea.
Well, it'll automatically pool the liquid. Like if you have an upside down 2-liter design and you spin it, and it has that tornado effect, it'll automatically pool the liquid through those tubes upward. It'll go against gravity if you need it to. You just put it at a slight angle, and now you have the same effect. And you don't have to have it straight up if you don't want to.
That's like a couple principles, dude. Like the Bernoulli principle, almost a couple different.
Well, no shit.
That's a fucking good idea, dude.
I got it drawn out on paper right now. Let's do this shit.
I kept my shit, man, but I do got to redo it, man. So I could do the 2-liter idea. You just use something in that shape, maybe a little.
I just wanted to give you the idea. Yeah, because if you have the tornado tubes going from big to small, wrapping around themselves almost like the inside of an ant or an anthill or whatever, how they have their air conditioning. They make the air cooler in the desert. It's that same.
Right.
Yeah, you do it upside down. So you have the smaller portion and you spin it. While it's spinning, it's automatically going to pull that shit through the center. So as soon as it gets to so many RPM, it's going to pull so much. The more it spins, the more it'll pull, the more it'll cool itself off.
And the point is for anybody who hadn't done this, look, it doesn't take much power to get these fuckers going. So even if I had to make 10 of them, it just doesn't take that much power. So one or two of the plugs would be enough to run the fucking generators to make the gas, right?
Right. Well, here's what you can also do. One tube can be iron and one tube can be a magnet. And you can kind of like have them both spinning around each other, kind of like, like a copper tube or a copper coil, right? So you have a iron tube, right? A hollow iron tube, and then you have a hollow magnetic tube. You understand what I'm saying? So now you automatically have the air in the middle that causes a different ARP. Like as soon as it fucking gets fast or whatever, it doesn't matter. It's never gonna overheat this way. It won't be able to.
Hey, you're right. That is the main thing, dude. Is the heat. That's the main fucking thing. Is the heat, dude. So
right. You hollow your tubes out. Yes, sir. And then in between each tube, so you put one tube, then a space, then the other tube, then a space, then the other tube, then you keep going like that, and you have the tornado.
I'll tell you how.
Through.
I want you to draw. I want to see a picture of it, even if not right this second. I want to see. I got the general principle, and it's definitely addressing my main problem. Here's how I found out about the heat. I bought a couple weather balloons, right? I bought a couple big ass balloons,
Did you cut out?
I'm hearing Pete Shea again.
I don't hear Pete Shea.
You must have a video. Like, are you on the YouTube maybe?
Man, I can barely hear you, Gio. All I could hear is Rumpus' stupid butt.
You're playing a video. Stop that video.
You must be playing a video from earlier.
I'm not on YouTube. I still got the mute unmute page.
Well, you might have YouTube running in the background. I don't know. Because I can have both on my phone. I don't know if you're on your phone. I assume you are, but I can have both, like a YouTube video and my Discord audio running at the same time.
It was the YouTube page. You're right. But the YouTube page was freaking still on accept invite. You know what I'm saying? I don't know how it played. I had to leave the accept invite with the YouTube emblem up top to get back to YouTube to hit stop. But that worked.
And all this time you thought that you were just hearing voices, and of all voices, you're hearing Pete Shea and Rumpus.
Yeah, and Rumpus, man. Man, I like having Rumpus on, man. He's
well,
dude, I got him. I mean, it gets aggravating sometimes. So there's a limit. But man, I got him answering I started talking about things up in the atmosphere and just asking him the dumbest questions, and he was answering every one of them, dude. I got him strung along for like 10 minutes, and they were all like, "Stop," but he just kept answering the questions, man. So I kept asking like crazy questions, like if something's like between this big, right in between the moon, and what if something's right above it? And he just was answering every one with his logic, and it was so funny, dude. I need to make a video out of it. He was answering any dumbass question I would ask, as long as there was physics involved, that made no sense at all. I mean, I was just asking the dumbest shit you ever heard.
That's like the ultimate Rumpus troll. I'm saying to troll him, like just to ask him all these questions, and then he just goes on all these rants.
It highlights his sophistry.
It's just comedy.
Oh my god! Did it ever, dude? Did it ever? I got to make a video and show just a short clip, man. I forgot what it was even about, dude. But it was just highlighted something. That was perfectly put. That's exactly what it did.
Well, apparently he's going to be doing like an in the field measurement observation at Bedford level, and we're talking with him.
You're in a comedic mood today.
He might even present it live on the
Yeah,
circuit.
right.
Let me tell you something.
You know how long he's
over
been saying that?
over that still body of water, he ain't gonna get that Earth curvature he thinks he's gonna. But if he goes out there enough times, he might find a mucked up day where he can get it close, where they could use 7/6R to make it match if he goes out there enough. But he is almost ever going to get over a body that calm, that distance. He's going to have to jump in the canal if that's what he promised. He's not going to get a globe out of that.
He's never going to do it, gentlemen. It's never going to happen.
You're probably right, dude, because he's not going to like what he sees.
No, he's going to come up with excuses. This was last year he was supposed to do it.
Yeah, well, he was also saying that the internet connection is not good there. So
yeah, that's his latest excuse. Yeah,
like NASA, they just keep pushing it back. Oh, we'll get to the moon in 2024. How about 2027?
Exactly, bro. Yeah. Have you seen that?
Anytime you see their shit, it's with waves.
Have you guys seen that crooked pole? They tried to put a pole up there and they couldn't even get it straight.
Yeah, I saw that.
You guys haven't seen the crooked.
Imagine.
I've seen the crooked pole.
Yeah.
Just blowing in the wind.
Yeah, they can't even get a pole straight. I mean, look, prove me wrong, but he's never going to do it. Never.
If he does, he's not going to like what he sees. I guarantee you that. But I could get like ships vanishing over, out here at the Atlantic Ocean. You don't see shit like that in land until you get like 50 miles and shit, man. You got to get way away to start seeing refraction, over land, or over oceans, man. Moving bodies where you get all the mirages. That's why I think the mirages, because I see them in the road. It's in the dips of the road, never on the humps, always in the dips. So the way these mirages combined, the Earth's got to be dipping in, and you're still seeing them dips combining to make a big. I don't know exactly, but I know that you could get that effect over the wavier it is, the more you can get that effect. But over calm bodies, no, you're only going to get mirages, inferior mirages, or flat, one or the other.
Well, he's going for the drop, Brian. He's after the drop, not the hump. Yeah.
He ain't gonna get it over that distance, guarantee you. So yeah, he probably won't do it. I didn't even think of it like that. I'm just assuming he's put all this into it. But did he say like his pole was like 4 or 5 meters? I mean, doesn't Bev?
Yeah. Things like
I got 2-story poles. I've never even stretched them out that far. I've never needed to. I need to get in, go in my shed and see, because I think, I mean, why would he have to build all that shit when they make story poles that high?
Because he doesn't know what he's doing, bro. That's why. Last year, it was a comic routine. He couldn't get plywoods in his car. He couldn't fit him in. I don't know if you guys remember that.
He trying to put plywood in his car.
Ryan, I put that in the back chat, that drawing. And then you can just take the idea, like while you're spinning it, like you can also have your connectors or whatever on the right and left side of the outside tube, inside, the shell or the.
Hey, is that the name of the chat that you actually posted? Is it actually called back chat? I'm new to this server.
No, the live stream, I guess.
Livestream one.
Yeah, thank you, man. Thank you, man.
But just like imagine if it's got the anode, cathode, whatever, it's got the two the sides you put on the positive, negative, right, on each side or whatever, how you got it, and you can spin it, and at the same time that you get that effect, you also can put your little salt and whatever you need to do, like yeah.
You got me hella curious, man. And I know you know what you're talking about because you went right to the problem that I had with the phone. And you do something out about that.
So what you do is the problem that solves the heat is either hydrogen or air, space in between, right? So that's why.
Let me tell you real quick, man. Real quick. This is how I figured out the heat. I figured out the hard way. I was making, I figured out the HHO gas was it floats like helium and shit without separating it. It floats. So I set up my pickle jar and all that and had a hose go into it. And I bought a couple Hal 2 balloons. I still got one. But so I was just wanting to inflate it to see how much lift I could get from that gas. So it was filling up, but it was just real slow, So I just left it outside, plugged in, and I went back out there and the bitch melted. It melted a hole through the balloon, dude. I had it filled up a good ways before that happened, but just the gas coming out of the hose, melted a freaking hole in the balloon.
Oh yeah. You need to spiral it. You spiral it to cool it off. You can either condense it or compress it or decompress it that way. You understand?
Yeah, like the ant beds, man. Like you're saying.
It'll change. Yeah, it'll change the temperature. Yes, sir.
And they got the size of it too, man. Like I said, it's using a couple different kinds of principles. So that's an interesting thought, dude. You must have put some thought into this shit, man.
It's freaking refreshing, man, to hear like critical. Oh, sorry.
Oh, I was just going to say it also works with magnetism. It's the same thing works if you want to make a magnetic motor. You get the 2 vortex, you get the 2 tubes, an iron tube, and you put a copper tube inside, but you have the air in between. and you do the same thing. You keep going with it. You make like the tornado all the way down with 3 things. The 3 things being the iron, the magnet, and the space in between. So all the way down, you have like.
Talking about, bro?
What are you talking about?
Magnets and shit, bro.
Iron, magnets, and air in between. And the air in between is going to be filled. Yeah, when that thing starts spinning, it's going to be just designed just like a tornado, and it's going to pull the liquid through itself. It's going to pull its own coolant. And it's also going to have a huge effect. And
you see my hair right now, bro?
It's going to compress the coolant also. So you can send that coolant through the whole fucking system and make like a radiator throughout the body or whatever you use it on. And send it in the
Daiso, are you at a Halloween party or what?
Bro, I'm fucking rocking out, bro. You know? Just fucking rocking.
Getting your Halloween on.
Yeah, I just got back
the
from my
problem,
80s Halloween party.
Yeah, we were talking about the problem with magnetism is like usually the heat or how it wants to, the EMF gets too much and it wants to, turn back. But you can correct that with like a space in between or a liquid. And that automatic, all 3 of those happen. You get the cooling effect, the spreading effect.
Shit sounds like heavy metal to me, bro. I don't know.
Awesome, isn't it? Isn't it too bad Tesla didn't think of it first?
Okay, you got some splaining to do now. What's turning your magnets?
Tesla just thought of a big chunk of fucking iron where he just puts the little magnets in there, and sometimes he puts a section of air in between the little magnet and the slit in the hole, and he spins it, right? Well, when he spins it, if it gets too hot, what they had to do was put a little bit of air in there, right? Yeah. So what he had to do was put a little air in there in between. So it changed the flow of the field. So now it kept it the way they needed it. And they got, torque, good torque out of it. It didn't heat up too much. It didn't reverse its polarity. It didn't change the field.
Yeah. I don't know, man.
Is this just magnetism or is it some sort of...
This is magnetic. This is magnetic.
Kind of.
Well, it's an iron and a magnet spinning. And they create the fucking current. They create electricity.
What creates the spinning?
But you have to have a conduction.
How do you keep your magnet spinning, bro?
Well, the magnetism is spinning.
Bro, I tried a lot of these contraptions. I never got it to work.
You did?
Yeah.
Did you try a tornado one?
No, that's why I'm interested. How do you eliminate the
I don't
lock?
have it made. I don't have it made. You'd be the first to make it. I just thought of it. So, you're asking me all this shit. I just thought of it just now.
Oh, my bad. I thought you worked it out. I was intrigued.
No, I just drew it on paper and just thought of it. You need the tornado. You need the 2 tubes. You need to hollow them out. That way, when you hollow them out, you get the air in between automatically, right? Automatic insulator and automatically changes the field. So now you can spin these motherfuckers as fast as you want. They're hollowed out.
Jeremy's going to love this. Wait until Jeremy hears this.
Going to cool themselves off. That's the problem with Tesla and everybody's motor. That's electricity and the battery packs and all this shit. The heating up. Well, I fixed it.
Look, personally, I think magnetism is the only free energy that we have, right? Besides the sun and you know what I'm saying, right? Waves and shit like that, wind. But the thing is, you gotta override that lock. The north and south.
Yeah, it's all an action or a reaction of magnetism, creating a vortex or a pump or an action or a reaction. Yeah, and it also separates the mediums with the different fields it put off, the potential or the voltage. Yeah.
Try it out, man. Try to build a little mini model. See how it goes.
Yeah, I'm telling you what. In my brain, it automatically worked. It works. I know it sounds stupid, but
no, nothing stupid with magnetism. That's one of the keys of our existence.
That's why I was explaining to you how the Tesla motor it works. It's just a chunk of fucking iron, is what they explain, with some slits out of it. Like you can see like holes through the so a long thing of iron, like a rolling pin of iron, right? And then some slits taken out of it all the way through, all the way like 4 slits. Then the magnet needs slit, and now then they had a problem. It was getting too hot, or the EMP, whatever you want to call that, the technical term. I don't give a fuck about that shit. So anyway, it was doing wrong because it was too hot. That's the main point. So they put a little extra. They took out a piece of magnet, didn't fill the hole, and they left a little piece of air there. So now when it spun around, just leaving that little piece of air created the right effect to keep the flow going to where what they needed. I just figured out if you take a hollowed out fucking thing itself, it's hollowed out. You have air in between each object itself. So you automatically have that. And you can spin them as fast as you want. You don't have to do it's there. That's the design. And you can put them in each other too. You can put one inside the other and one outside, one next to it, however you want to do it. And you can have the outside shell of it, the fucking iron core, iron too. You see what I'm saying? So yeah.
I just posted something for you, bro.
All right, I'll check it out.
You're gonna love this. Yeah, electromagnetism, that's the key to everything, bro. That's what makes everything work. Think about it. Your brain, your heart, everything. What's powering this device on your hand? That's
what gave me the idea. The heart,
I agree, man. And they won't incorporate it in their model, man. But it's
our
a matter of time.
blood.
They have to. It's too
Now
obvious.
listen, our blood, our heart is supposedly a pump, a circulatory system. We have iron in our blood and plasma. You take those two effects. You take the iron, the liquid. You take the tornado pump. You got it. It's all right there. The hollowed out tubes, just like our veins, just like the heart. It has some, yeah.
You know, you can get a couple of, 2.5 or 2 or 3 volts of energy if you stick 2 pieces of, like 2 different metals in the ground, touch a wire to it, you'll get a couple of volts.
Yep, and if you compress helium, you also get electricity or voltage. So
yeah, but I'm just saying, without doing anything, without any chemical reaction, just just the ground itself.
Right. You know, like if you put a piece of iron between a magnet, you can divert the magnetism towards the point of the iron out where the iron's going. So kind of everything around, everything is a reaction or an action, like I said, or like you're saying, everybody, it's a magnetic field. It never stops.
Yeah. Tesla was onto it. That's why they shut him down. They made him look crazy, like a pigeon, married a pigeon and all that.
All you have to understand is where to fucking put your ground. I can't say it any easier than that to anybody that's a layman in anything. The ground is the key to everything. For the electrical, where you want to get the power, you want to get the source, talk about, well, how do we power? How do we get this? That's the key. Kinetic energy off a motorcycle, a bicycle, a human, everything.
Yeah, he had Wi-Fi, 80 years ago? So think of that, how long they suppressed that technology. Charging without plugging in, he invented that. Radio, he invented that. Microwaves, he invented that.
Well, there was a story about a kid, right, who had 2 brains as a little kid. And the little kid figured out how magnets work. Right? That's the story. Because he had 2 brains. So like whatever we couldn't fathom or think of with 1 brain, he was able to with 2 brains, like he got it. And what his thing was magnetism. And like he created all kinds of shit and like was like, I don't know. It's just a cool story, and magnets are the key to like what he was saying, what he did, and like created like people or something with once he found out magnetism.
Well, this professor, the video I posted, this professor, first of all, he swears and this and that. He's like, he's something special in that sense. But the things that he says, man, if half of it is true, talks a lot about LEDs. You'll see what I mean.
Oh, there's a lot about the LED, yeah. Before I even look at the video, I'll tell you what I've heard. LEDs can send and receive and transmit.
Yeah, from what I
adjust?
heard, LEDs you can use an LED as a to collect energy from the sun, like a solar. What do you call them?
Yeah, like a solar panel. You can also
yeah.
You can also record information, send and receive information through LED.
Yep. Yeah.
That's what I heard about it. Like your light bulb can record and send, and it can like do
Yeah, that's what they're saying with the TV, the spy things. Yeah, I heard of those things too.
But now the LED thing with that, and why don't we have materials and paints and fences and sidewalks and streets that are whatever and
Yeah, but think about this. You have a light, right, at night, but in the daytime, it can collect energy. So that technology exists. Why isn't it out there?
Oh, yeah.
Think about it. Your light just turns over in the daytime and just charges.
Well, I used to have, when I was younger, I used to have this little ball that it would be a off-white looking ball, like a weird looking gray color almost. And then whenever you sat it real close to the light and walked it anywhere out of the room, or anywhere away from the light, you could tell it was glowing. So it would charge up and glow. So light could be shined on it, light could affect it, but it also became its own source from the charge. So the light could affect it, and be brighter than it or, dimmer. But when you took it in a black room, you could tell this thing was a glow in the dark ball. It charged up, just like you're saying.
Yeah. What I often think about is imagine all that, because this Tesla is like almost 100-year-old technology right now. They got it off him, right? Now imagine what they did with it. Imagine what stuff they have that they're holding back on us.
Well, if you contain certain things and you wave them a certain altitude in the air, it's an automatic voltage, so it's going to give them a charge, and certain things will glow, right? Plasma in a tube, right?
Well, what do they call it? In altitude, there's a potential. Forget the exact terminology. Like every height, there's a different
voltage. I'm pretty sure it's voltage.
Yeah. Amperage. But there's a term for it.
Amperage,
anyways.
Voltage, watts, what? Current, what?
No, that.
Frequency?
But there's a word for it. Like they call it. Anyways, it'll come to me. Like the difference in altitude, like
electrostatic potential.
It increases with the difference, like from the ground. Each step up is more energy, or
the pressure, the resistance. What do you? I mean,
I can't think of it, bro. Can't think of the name. But what the story is like this. What Tesla, one of his ideas is you have one wire on the ground, and then as you step up in altitude, there's a potential in electricity. I forget it's pissing me off. But yeah, that's basically the gist of it. Free energy.
Right. Remember I told you it's the ground?
Yeah, it always has to do with the ground, yeah.
Yeah. Now, see, I didn't read that Tesla thing.
Yeah.
But what I know is ground's the key, because, motherfucker, if you have the key to the ground portion is all the energy you ever need. The in-between thing is the source, which will be the thing you're using to power. So you power your thing, ground on the other side. After your thing's powered, then your excess energy goes to ground, and then it's completing the circuit. That's what you're doing. High to low. You break a circuit by adding two things. So now you created something in between the fucking field. You got a wire here and a wire there. You have a space between. That space between can do work now. Whatever you plug between that motherfucker is going to get electrocuted. So it's something's going on, right?
Yeah. Well, this wacky professor, he says like scalar waves, and he has a way of, he hooks up the LEDs in some freaking manner, and it creates like energy. Gotta watch the video. Like, I understood maybe a quarter of it.
The bottom of your shoes and feet rubbing across the carpet create energy. Anything with a resistance creates energy. Anything with differential, right? Differential. Positive to negative, high to low, hot to cold.
Well,
So
all we
anything-
need is movement. That's easy, but we're talking about motionless energy. Sort of like with magnetism, right? Well, maybe not motionless. Maybe that's...
Well, something's moving. I mean, something's moving with it. You're getting an excitement or a charge or something, like you're doing something. It's doing something.
Yeah, when I get moving, you get excited.
Well, if you can make a balloon spin around in the air and touch my hair at the same time while I'm standing still, then we've got something.
You can put that balloon on a drill bit and then go rub your head on it.
The perpetual motion drill bit.
Put the balloon on a fan blade or a windmill outside. Tape the balloon to it. The balloon will spin while the blade spins, while the wind blows it, and then you got that.
I thought we were still talking about perpetual motion stuff.
Well, you can do perpetual motion with wind. If you have a big string, like a rubber band going around the thing, and you have a hollow plastic tube, like a slide material, and you have a whole bunch of fuzz, like a fuzzy ass carpet material on the inside of it, rubbing it and rubbing it and rubbing it and rubbing it with the fan thing rotating, that's free energy.
Yeah, basically you rub some two insulators together. Yeah.
Yeah, when all the kids go to the fair or the slides or the parks, all that shit should be connected, and all that stuff should be ground, and then to ground, and then you put the power to another source and then ground it out afterwards. So every time a little kid goes and swings or plays or slides, it powers the park and everything around it.
Kid powered electricity.
Well, why not?
I'm all for it.
Well, everything powered. You put it in the street, you put it in the sidewalk, you put it in bike paths. Everybody powered everything. The kid was just to give you an example so you can go along with the idea so you understand how it works. When I slide down the slide, I get shocked every fucking time.
Yep, I'm with you. I follow it. I'm picking up what you're laying down.
That's right. So let's use that. We can use that. If you had like a little battery pack set up somewhere where all that energy went to that and then ground, shit. Or, went to wherever the source it needed to and then, wherever, ground after. Fuck ground. Ground to be the last thing you worry about.
Imagine how many patents have been suppressed, how much technology has... there's a lot of people. We're not the first ones to think of this stuff. You are aware of that, right, guys? So
yeah,
imagine. Yeah.
I'm perfectly aware. Hemp material rubbing on shit. Yeah. It's a lot of electricity wasted. I mean, you can use hemp and rub it. It can be the insulator or whatever rubbed against the plastic, and it's like fucking super conductive too, and it'll stick to it. And static, electricity, all that. Hemp, weed. Hemp fibers. I think we got it,
It's
guys.
sticky. I just call it magnetic.
Electromagnetics. Hey, that's a good word. We should use that. Electromagnetics. That should be
I
a
like
thing.
electromagnetic waves. What about that one?
Well, it'd be electromagnetic bleeding effect because it kind of bleeds into everything else. It either gets overbled or bled out. You know what I mean? Like,
Electromagnetic tampon.
no. God damn it,
That's
Dyslow.
that's just a.
No, like if you
That's
stab a
already a thing.
balloon, the gas goes out. If you have a light, the light goes out. If you have this shit, it goes out. It can bleed into the. Everything can be mixed or mingled with the medium around it, so it has a bleeding effect. That's what I call it. I don't know why I just call it that. You know what I mean? Like helium can pour out into the air, but then it's going to do what it has to do in that medium. But everything can pour out and react. You know, you can have magnets here, magnets there, positive, negative, whatever, until you have them touch or get close. You know what I mean? Until they get close enough, you're not going to get that reaction. So everything can react on its own and have a frequency, and it can all work. You know what I mean?
I mean, kind of like it does.
Yes.
Yeah.
I just call it the bleeding effect because it reminds me of TV waves, radio waves, Wi-Fi, antennas, everything sending their own little whatever it's supposed to be, and everything's going through and going this way and that way, and everything gets there regardless. So, yeah.
Are you twacking?
Uh-oh, George doesn't like my Morris Tollens.
That's a wall of text. I can't read that.
He wrote a thesis on it. Jeez.
Must be important.
I must be dead on for him to do that.
Yeah, he must have nailed it. It's basically, let me just sum it up. That's exactly what we would expect to see on a globe model.
This globe.
Yep.
Where'd Brian go? He knows the wider end is the end that's going to cool it down, right? I don't want him to put it backwards. He'll heat it up more.
Did he go try something?
Well, he's going to. I think he's going to try the tornado thing. But I mean, it's going to work definitely.
Oh,
but he
shoot.
has to put.
What was this 2 nickel thing? I don't asking you to repeat it, but just summarize maybe.
He had a problem with something coming out too hot, and I told him if he spiraled it like a tornado, he'll either compress it to make it warmer or decompress it to make it cooler, like ants do for the little anthills in the desert or termites. So he's like, yeah, but he has to do it. You know what I mean? He has to do it the little part and then expand it to the wider portion, releasing outward or up. So fuck. So you don't want to compress it, you want to decompress it. So yeah, that's all. Expand it as it releases and push it outward. So the spiral is going to expand it by getting it bigger and bigger and bigger and bigger and bigger inside the tube, and it's going to go bigger until it releases outward.
Like a really pressure release kind of thing.
Yeah. And what he's going to try to release it into something, and he doesn't want it to burn the object. So he wants it to be cool enough by the time it gets into the object, it has the effect he wants, but without burning the object.
Yeah, needs some sort of like a heat sink kind of idea.
Yeah. So like a little valve, like a temperature valve. Yeah. Like a temperature release valve or a thermostat, basically. Yeah. And a thermostat would work too. But I think that's the simplest version without fucking around with anything. Just coil a tube wider and wider and wider and wider and wider and wider and wider until it releases. That should work.
See, in theory, everything works. You got to try it because magnets are freaking tricky, man. and they'll
Oh
piss you
yeah,
off
yeah.
real bad.
This one is just no Montreal. This one's just mainly the heat. He has like something that's hot, like a liquid or an air that's going to be coming out hot, and he wants it to cool. So this one's yeah. We were talking about magnets too. I mean, you're not wrong, but this one right here was just for the idea to cool the air before he enters it into the material, so he doesn't melt it.
Gotcha.
Yeah. So I just told him if he spiraled it, he would decompress it the whole way up, just, until how many ever coils he needed to get it to the temperature to where it's just cool enough to where he can, do his thing. Oh, but I know what you're talking about the magnetism. Yeah, it'll reverse on itself. Once it gets too
locks,
hot,
bro.
Yeah.
If somebody could come up with a mechanism to bypass that locking system, when
I got it. I told you that's the vortex. That's it. You have a
gotta
hollow
see
tube.
it, bro. You gotta do it. Try.
Listen.
You're gonna create perpetual motion, bro. Simple.
I know. I already know this. I already knew when I was 14. Listen, when you take the problem was heat, and the only thing they did to perfect the heat problem on their motor so far was put a little slit of fucking in it for air, a little slit. You understand? I'm proposing to take the material and hollow it out, and the whole material be hollowed, so air can go through it. Actual material in question, the magnet itself and the iron itself. Therefore, no problem anymore. You don't just have a little fucking slit in a piece of something, like a piece of Swiss cheese, like just a barely nothing. You like a gas stove, like you have a very, very little hole for your gas to come, right? Well, I figured a way to make it like a shotgun tube, see, and spiral them. You'll never, ever have to worry about the fucking heat or the lockup. I promise you.
I'd like to see it, bro. Like I said,
I know. Me
this
too.
is, it's against a few laws. I'm
Well,
sure you're
you do
aware
have
of.
to be able to. You do have to be able to do some stuff. You have to have access to shit. See, all I have is theory in my brain.
Hey, that's all you need, man. Like I said, try a little model and then see how it goes. Me, I've racked my
Well, I'd rather fucking
hours and hours.
I don't know if this sounds stupid, but I mean, shit, I'd rather go call Tesla's goofy ass and be like, "Look, man, I got the solution to your problem. Give me a little bit of money, and I'll tell you how to do it. And I don't give a fuck about nothing else. I'll see you later."
Don't forget us when you're making the big bucks, huh?
Yeah.
remember your friends.
My thing is, if anybody ever wins the lotto and they play it, everybody should play a pool. Everybody should be in a pool like every week. Like, I don't care how many people, for like the whole fucking United States, right? And if anybody wins it, the lotto, the big game or whatever, it's gonna be like hundreds of millions of dollars. You just give everybody like 500,000 or 50,000, or you just agree to give somebody a fucking good sized cut. You know what I mean? It's like basically a free car or something for everybody. Like, here's 20,000, everybody, or 50,000, 50 at least. It wouldn't hurt you. Everybody in America. So that's 50,000 to 300 million people. Boom. Everybody's happy. You won. You're fucking good. They're good. It'd just be a house and everybody wouldn't have to worry about so much shit. That's my idea too. Everybody should be on it because everybody can win from it. It's a win-win situation. Only one person fucking wins. They give everybody a little cut. They have a big ass chunk of money they can never spend. Everybody else has a little chunk. Everybody's happy.
Listen to the logic of some people now. We have George, right? We're talking about a spinning Earth, right? 1,000 miles an hour. And in his head, a plumb bob will hang plumb on such a surface. And the mental gymnastics that he has to go through, it's unbelievable.
A plumb bob should never ever be straight, only except for one position ever possible. Even on a, I mean, on something moving, I don't even know. I'm not even talking about that. I'm talking about something sitting still. If you're on a sitting still sphere, there can only be one straight plumb bob ever for the history, world's history of time. Wherever you put them, from the beginning plumb bob to the end plumb bob, you could put 1 billion of them. Only the middle one can be straight. Every other one would have to be off.
Join me next time. Yeah. George, I know you're listening. How can you not get that? How can you not understand a plumb bob on a moving object, especially a spinning one, will not hang plumb? How can you not get that, bro?
Where can you show us that on a sphere? Can you show us a little sphere with that happening? Where a plumb bob does what you say? At the speed or rate you say it's spinning inside a vacuum? And if the vacuum of space is nothing, right? If you can just pee out of a hole and it doesn't harm you or doesn't bother you, how come it's so hard to create that on Earth? Am I losing my mind or what? How come that's so impossible to create?
What book, George? Come on. Come on in and let's talk. You know that's, you can't show that. You know that's physically impossible, George. Come on. You know that, man.
And how did Elon Musk design a toilet that blows in on somebody with a fucking vacuum on the outside of the ship? Wouldn't it be impossible for something to come back in on you and not be taken out the opposite direction? What the fuck? I mean, what the heck? Right?
If this could be shown, wouldn't they show it? Right? If this was possible.
Well, the only reason I could think that Elon Musk's toilet backfired is because they're on their things got to be going in the atmosphere, flowing, flying, and it just pushes back in. It doesn't suck out anywhere.
So the ISS is full of shit.
Yes.
Yeah, basically, yeah.
I knew it.
They said they had to block off a room where the new design $1 billion toilet was put, or however much it costed, because it was blowing poop and pee back on them. How does that work in a vacuum? How can that even? I don't get it.
Who would have known a toilet would take apart the ISS?
I think they just sat around one day and they're like, okay, we've already convinced them of this ISS thing. Can we get a bunch of like piss and shit humor somehow in the news, so people can be thinking about pissing and shitting up in the space station? Because it seems like they've been releasing the Russian astronauts that were converting urine into water. And then there's all these discussions of how they shit up there. It's just funny.
What, you never had a golden bendy space-time shower?
The Cleveland steamer of space junk.
That's called a black hole Cleveland steamer. I don't know, man. These people.
So
I took a picture with the NASA guy. I'll post that. There was a NASA guy tonight. His face was half fucking mangled off, dude. It was pretty gnarly. If you zoom in closely, you can see it's all cooked off.
I think
Come on
Brian's
in, George. Stop typing. Come on in.
And I also meant for Brian to actually spin the container where he has the liquid at that he's trying to convert the hydrogen, that he's trying to convert, spin the hydrogen itself also. That's another thing I'm trying to tell him. You add the centrifugal force to that. I just want to see what reaction you get if you do that.
Have you guys ever heard of a Stirling engine?
Yeah, I've heard of that.
Just that alone could power a lot of stuff. And it's basically free. All you need is a temperature differential.
Right. High to low, hot to cold. Yeah. Resistance. Resistance is all energy. It's kinetic energy at its finest.
What about thorium fucking driven engines? How come they never brought that into production? Cadillac spent all that money producing it. They just gave up on it. That was really weird.
Which one?
Cadillac produced the car that was ran off thorium, and essentially it could power itself for I think 25 years or longer without ever fueling itself.
Really? Thorium?
Thorium. Yep. Yeah, I heard about that. Yep.
That's a salt, I believe.
Well, all the batteries are with salt. It's just really fine super salt, like just the fine, like the salt underneath the salt underneath the salt. That's a battery. It's electricity, baby boy.
Good night, Georgie. Maybe another time.
Yeah, that salt's what is your car battery. I mean, it used to be. I mean, I don't know what they do these days, but for the most part, all the car batteries had salt.
You guys heard of thorium reactors?
Yeah, that's what this was. It was a small thorium reactor inside the Cadillac car.
I never thought they got them that small. That's freaked out. When was this? What year?
Oh, maybe 6 or 7 years ago or so.
Wow.
I think here I'll pull something up for you. See what I can
They swept that under the rug real quick, huh?
find. Right. Yeah, here it is. Oh, post the link here.
Yeah, this thorium stuff is freaked out. It's basically a reactor that's safe, produces energy, shuts down. If there's like a meltdown, it shuts down on its own. It's like amazing technology, right? No radiation, but they shut it down.
Yeah, it's right there in the chat. It's a Cadillac thorium fueled concept. It's essentially a
Which
nuclear
chat?
powered. Where am I? Live stream. Oh shit, man. Sorry, wrong chat. Okay, here we go. Live stream 2.
Shit. Wow. What a concept car, huh? Damn, I never heard of that. They kept it under wraps.
Well, just like they keep it under wraps as saltwater lights when you focus energy on it. Focus a certain frequency on it. Like a magnifying glass focused on it the right way. In principle, in idea, in theory. It just lights it up. Just like
Imagine
gas.
having a car, you don't have to fuel it for 20 years.
Yeah, that'd be nice.
If you can focus a damn magnifying glass with the right lens onto an opening of water that has like a container of salt water that has like a little opening where like the portion can come out that you're like focusing this thing on, it'll light up and you got energy right there. It'll light.
Have you seen a guy start a fire with a plastic baggie full, like a corner full of water, and focusing the sun on it, on like a tinder bundle? That's awesome.
Well, I know that you can take a piece of ice and get fire with it if you focus it like if you rub it and make it like a magnifying glass and put the sun through it. Like all kinds of ways, yeah. Think about it though, just taking a magnifying glass and holding it onto water with a little bit of electrolytes in there, and you focusing on there, and then like the little gas that releases lights up. It's just crazy.
How's it go? Right on. Yeah. Exactly.
Sound effects, boy.
We got free energy all around us.
It's a tea kettle. It's not really going off. That was just me.
That's pretty good. There was a lot of ass at that Halloween party, by the way.
Everybody laughed.
Huh?
Everybody left. Everybody laughed.
No, I said there was a lots of ass, like butt cheeks, like raw butt cheeks showing.
Oh, what the hell?
Yeah, it was pretty epic. I don't know what's up with chicks and Halloween, man, but they get pretty weird.
What are you gonna be for Halloween?
I got a clown mask I'm gonna wear.
It's gonna
One of the
inhibit you being
clown.
able to have a bottle of beer or something, or no? That's like what kind of mask? Like a pullover rubber one, or what?
Yeah, yeah, but I'm handing out candy and shit. I'm not. I already did the Halloween party. I might go to another one tomorrow, but yeah, if I go to a
I'm gonna
party, or I'll just wear like my wig again.
I'm gonna be a Napoleon Dynamite. Fucking, I'm gonna
Oh,
win
hey,
Halloween with that. Yeah,
fuck yeah, dude. Go for Pedro.
that's right. Vote for Pedro.
What's another thing he likes to say? I don't know. Trying to think of some Napoleon quote. Chicks like guys with bow hunting skills.
How much you want to bet I could throw a football over the mountains?
He throws the stake and it hits him in the head.
Oh man, it's one of the best scenes of all time.
Is that Uncle Ron?
Uncle Rico.
Uncle Rico, dude. That's how you should be for Halloween, bro.
Bring me my chapstick.
You can get some Tupperware and shit you're selling. Yeah, dude. Uncle
I
Rico's
caught you a
rad.
delicious bass.
That was a classic movie. Chifondo thinks I'm handsome.
Yeah, Lavanda. Yeah. I see you drinking 1%. Is that because you're fat? Because you're not. You could totally be drinking whole milk if you wanted to. Pretty much my favorite animal. It's like a lion and a tiger mixed, bred for its skills and magic.
It's a liger.
Yeah. Whatever.
I like when they're sitting on the couch watching Uncle Rico's video of himself throwing the football. And Napoleon goes, "This is pretty much the worst movie ever made."
LaFonda made me this mixtape.
It's a hit. I just gotta carry around some tater tots with me, and I'll win Halloween.
He's eating them in class.
Yeah, give me some of your tots. No way, get your own.
Pocket.
Get your own.
And whenever anyone mentions crystals, I just think of the scene when they get the time, the time, fuck is it? Machine. And they're about to do it, and he said, "No, oh, I almost forgot the crystals."
I forgot the crystals.
I wonder what makes that movie funny to some people and just completely boring to others. Because you could show it to people, and I'll just say, "I don't think this is funny," but I do. It's just the way that he talks. It's just the absurdity of it.
I mean, it's a classic storyline, I think, of like an underdog. Everybody kind of roots for the underdog when they're watching the movie, because it comes back, and no, he's a fucking nerd, and he wins, like he does a dance contest and all that.
Can't forget the Velcro shoes, bro, if you're gonna do it, okay?
Yeah, the boots. Yeah, the moon boots. Yeah. I got the fucking Casio and the Walkman and the headphones and everything.
Yeah, but you got the moves to go with it.
No, well, no.
Yeah, that shit was pretty classic, dude.
And he found that dance tape in a bargain bin of some dollar store.
No,
he learned
that was the one LaFonda made for him, wasn't it?
No,
LaFonda already had it, and they're hanging out in his house.
He got the music from her, but he learned how to dance from the tape that he saw.
Oh, yeah, that's
right. He got all his moves from that one, goofy little tape. It's crazy.
Yeah, they really nailed that movie.
Yeah, the thing about it is like there's no punchlines. So, some people see it and say, this isn't like, what's so funny? I don't know. It just is.
I made you a cake. What about when he goes to Pedro's party after he wins and it's just like a shit ton of gangsters and fucking Mexicans and shit? Was Rico trying to hit on that that young chick? He was like
I
doing the
don't know.
photos and shit. The shit was
There
so
was a
weird.
very thin line. I think he was dancing on it. I don't think he crossed it, but he was definitely dancing on it.
Yeah, I wasn't sure like if I was being creepy or if it was like a movie. Like, kind of made me like feel awkward.
One of my all-time favorite lines that I use all the time, even in just regular everyday life, is when Uncle Rico says, "You might as well do something while you're doing nothing." It's such a good line.
I don't know, but that steak in that movie looks so good, bro. On that.
Yeah, Grandma called. She said that she wants you to go home because you've been ruining everybody's lives, and eating all our steak.
That's fucking classic, dude. Yeah, I think we should all dress up like characters. Pulling that. Just have a big flat Earth Halloween party. This fucking house I went to was like probably one of the best decorated Halloween houses I've been to, dude. Like, this guy had like legit props fucking all over the place, inside and out and in the backyard. Like movie quality props. It was like lighting. I don't know how much fucking money he spent, but oh my god. It's off the chain. Took some pictures.
I wonder why people deck their houses out like that just for one day.
Yeah, I don't know. Well, I think horror movies were pretty prolific. Like this guy's right around my age, and I don't know if it was him or his wife. These are like my wife's friends. Like my wife knows this chick. It was her husband's birthday, so it was a Halloween/birthday party, like an '80s theme type deal. But one of them was like obviously into fucking horror movies and shit. Because you don't collect shit like that unless you're like you said, unless you're into it. Because one night out of the year, not the amount of money this guy had into this shit, dude. And then it's like, where the fuck does he store all that, dude? I mean, this was a god awful amount of shit. And that stuff, like, you got to keep it. You got to keep it like room temperature. You can't keep that shit in the attic. It'll just fucking get destroyed.
Does he do that just for Halloween, or does he go out for Thanksgiving and Easter?
I don't know, but I'm assuming it was just for Halloween. Yeah, I mean they had everything. Dude. Fucking DJ, they had catered food. Probably because his birthday is right around Halloween, so he's probably always,
Oh yeah, there you go.
Yeah. One of my son's friends had another Halloween birthday party, and everybody dressed up and shit. I didn't go, but my wife went. She said it was ridiculous, dude. It was just shit ton of chicks there dressed inappropriately, and alcohol. It was like not even a kid's party at that point. I was pretty pissed I didn't go. I go to all the other kids' birthday parties, anytime my kids get invited. It's a good one. Mm. That was a second game. No, you don't wear MC vests.
Where's Biodual been? I haven't heard from him in a while.
That's a good question. Somebody called me Bioslow before. I thought that was pretty funny.
That's funny.
Yeah, I think he a couple weeks ago he left the server, and then I'm not sure he's rejoined it. What his decision, or if he's gonna rejoin or not. I think actually, now that I'm thinking about it, I think maybe someone had given him a warning too. So I think it was like, yeah, something like that happened, I think, and I think he left.
Yeah. If you get heated, man, hopefully he calms down and comes to his senses. I had something happen not too long ago where I got modded accidentally. Oh god, that shit was so frustrating. Yeah.
Yeah, I like chatting with Biodual at times. Usually when he's kind of his guard's down and he's just chilling. But he seemed to get really frustrated in these conversations. So I don't know, maybe he decided to take a break or something. I mean, just the concept of like being a globe earther and coming into some of these places and trying to push that, like that's got to be frustrating. Like if you really have a desire that you have to push it and convince people, like it's just like it just gets repelled and broken down constantly. So it seems frustrating, or it could be frustrating.
Well, he actually presented my unicorns, the truth about unicorns and rainbows that they never told you about presentation. It was funny. It was hilarious. Yeah. So yeah, there are times when he's like on, not all worked up.
You guys going to any Halloween parties? Gio?
I'll be right here on Earth Awakenings.
You don't get like trick or treaters coming by or nothing?
Yeah, I do, but I don't answer the door. I leave I leave a bowl of candy out there.
Yeah. I set up a table one year and I set up a couple dummies and I did the same thing this year. I got a couple dummies set up. I might sit out there with them and my mask on and shit and put the bowl on the table and let the trick or treaters try to figure out which one's fucking real or not. It's usually fun when you never know which way it's coming from, when you know something's gonna happen.
Okay.
For the magnetic thing too, you could have the copper. What you're really doing is doing the current. Doing the current flow through the copper.
Through the copper or with the copper?
Well, both. I can barely hear you. Copper's looped all around the underneath outside shell right before the magnet. The magnet's on the outside of the copper, and then you got the iron on the inside of the copper. It's just strung around like a radiator, kind of. My idea puts them all together in a better fashion.
Bloody wish you'd get on to some of your ideas.
Do what?
I wish you'd get on with some of your ideas.
Yeah,
Application, practical application. Yeah, it'd be good.
Well, fuck, I'm telling them to you guys. I don't see you guys doing nothing.
Yeah, I think you're the only one that truly grasps them enough to actually do that.
I'm the only one that knows what a hollow tube is in a tornado pattern. Okay. That's cool. I didn't know you didn't know what a tornado pattern was or a hollow tube.
Have you got a YouTube channel?
Do what?
Have you got a YouTube channel of your own or a server of your own or anything?
Hell no, I don't need none of that.
Fair enough.
Just got me and my voice, buddy. I think that's all I need, right?
Oh, I don't even think you need that.
I think Brian's working on one. I think I just helped him because he had a problem with heat. It's first in the heat, and I gave him the key to it. So maybe, you know, if it helps him, I guess it's a part of my idea now too, a little bit.
Nice.
I reckon if I made one of my ideas, I probably wouldn't be on here long.
Yes.
Be like, oh, Democ went crazy. He shot himself in the back of the back.
Back of the back twice.
He shot himself 15 times on the side. What the fuck? In his leg. He killed himself by shooting himself in the kneecap. See, what happened was he shot himself in the kneecap and fell off the cliff and then shot himself in the back of the head at an angle with an arm he doesn't use. Sir, is
yeah,
it
then for
true?
some strange reason, he went up to the top of the building and he jumped out the window all by himself.
Right. He didn't have any legs on him. How could he jump?
Well, it's a problem.
You see, he jumped this 3-foot fence right here. 4-foot or 6-foot fence. He jumped it, and then that's how he committed suicide. Your Honor, he had no legs.
Desperately wanted out. Clearly.
It was the case of jumpercide. He was scared of planes, but just this one day, he had to pilot this helicopter out of nowhere and die.
It happens, mate. You can't deny. It's not just coincidence, Dimmer. It happens. Even the Kobe Bryant thing. Is it Kobe Bryant?
Oh, yeah.
Is that his name?
This kid's scared to swim, but he drowned. Couldn't get him in the water any other day, but this day he wanted to go for a good swim. No, I know what you're saying. Quit being a jackass and do some of the shit I say. I wish I had some materials to do it. I would.
Oh, look, for all we know that you have, and you're utilizing it, but you're just not obviously sharing it, which is probably a smart thing to do. Sometimes the best way to help people is just to drop little golden hints, little nuggets, and hope they run with it.
Most of the time I try to keep it as simple as possible. Maybe it's too simple. I don't know. I think things that seem too simple never seem like they're ever going to work.
Yeah,
But
and what seems simple to someone is very difficult for someone else as well, though. You know.
yeah. But the less moving parts, or the more simple it is, the more simple it is. Huh. Like a motor with less moving parts, you know?
Oh, now you're talking. The old Wankel, beautiful design. Rotaries. But that's off topic.
You shouldn't really ever need a motor when you got magnetic motors. You should only need a gearbox for your gears, like first, second, third, fourth, fifth, you know, extra torque.
Yeah, but no one's making money off that shit every month, mate. It's a one-off sale. Off it goes. You might get some, recurring business with the gearbox, but other than that, you're not gonna, the business isn't gonna grow hand over fist each year like they want.
Well, you have different torques, so you have different top speed ones. You got the 100-mile-an-hour one, you got the 50-mile or 75-mile, one that can go on any highway. You got the 200-mile-an-hour one. You got the fucking NASCAR one. You got souped up. You can have different ones. You can have different stuff. All around camera, motion detected, fucking automatic. Just a lot of cool stuff with this electrical shit these days. I mean, you can have your windshield show like YouTube, anything. It can turn to a TV, a big screen, play a game in it. Just all kinds of shit, man. I got all kinds of badass ideas, but you can do a lot of stuff with this. The electrical inside of a car, being electric, can have the ability, to have the electricity. All of them automatically come with their own hotspot or Wi-Fi, like automatically. Like if you buy this car, it's connected.
Oh, you're part of the bloody Internet of Things. You're up there with Klaus Schwab, aren't you?
A what?
It's all good. I'm gonna go on
No,
mute
I'm
for a
just
minute
saying,
and eat a steak.
Well, I'm just saying. I mean, like if you can say, hey, something or whatever, and your car does it, and it tells you and talks back, and you tell it, your car can teach you to fucking drive a stick. First, second, clutch, gas, shift, clutch, gas, shift. You know what I mean? Like it can teach you this shit. So you can have an electric car, but you can still have a gearbox and still shift like you're in a manual, That'd be pretty fun. Just slam that motherfucker forward first, slam it backwards second, third. You don't have to shift, no clutch or anything. Just it's still fun. It's the stuff you could do with electric cars. It seems pretty neat. You wouldn't even really need a glass for your electric car. If you think about it, it could be a shell, and you wouldn't even need glass. Like it'd actually be like a shell of a car, and you just have a camera, and your screen is what you see from the camera screen, from the camera lens. So when you get in your car, it turns on like this, like Star Trek. So your screen comes on in front of you like a TV screen, but it's just showing you the outside. It's not really the outside.
You're way behind, mate. That's what Bezos has got in his little cock rocket fucking blow jobby that hangs around up there.
Yeah, that way nobody, I mean, you don't have to roll down, or I mean, you don't have to have windows like that for the front and the back. No defrost your window and shit like that to look out. You just need that little camera to be warm. Steam. Steam as a deterrent. If somebody comes up, your car can shoot steam at them. Doesn't kill them, but it'll burn them. It'll get them the fuck away.
Electric car, mate, set a fucking electric fence around it. Boom. Bzz. That'll even stop the dogs pissing on it.
Oh, yeah. It'll electrocute you. Yep. So if you press a button and somebody's trying to get in your car or attack you or fucking they touch your car, you can electrocute them like a taser. Or steam. Those are my two ideas. Like, you're not killing them, but you deter them. Yep, shock the fuck out of them, and then you just drive away. Or steam them. Psst. Steam at their face from the little top part of the vent. Shit. But I mean, they have automatic thrust. They can go like fucking 500 miles, 1,000 miles, whatever. I don't know. You just keep it as simple as possible. Have like a hard drive or two. The hard drives would be the thing you'd buy. Like you'd get the X with one hard drive, or the Z with 2 hard drives, or the P with 3 hard. You know what I mean? Something like that. And each different hard drive or fucking whatever, like modem in a way. I'm sorry, can like do a lot of shit. Like the basic package would be like Siri, like automatic Siri or your car, whatever you name it, it'll talk to you. Have a voice. So your car will have like a little personality and a voice.
Now you're just talking about Knight Rider. You're just going full circle.
Yes.
And Airwolf.
Zoo, zoo. Hello. Hello, Whites. What would you like to do today? Well, X-Car. Well, X-Car, I'd like to go to the grocery store and then go to Grandma's house. Zoo, zoo. Okay, on the way.
Kosha will be asking for blowjobs.
It'll remember codes for you, remember grocery lists. Remember the grocery list, CarX. Okay, go. Anything. It'll remember all kinds of shit for you. Like if you need to know something, it'll answer it. It'll have like its own little thing, like calculator, translator, all kind of shit. If you're driving around in China and somebody walks up and talks to you and you press the translate button, it'll translate to you. Your car will tell you. It'll come through in English.
Mark,
Tell me
I
it ain't
can't
bad.
believe you have to fucking press the translate button. Shouldn't it just know that someone's speaking fucking Chinese and just translate?
Well, it can. You just, well, yeah. When you enter China, you're gonna push the China button. If you enter Japan, you're gonna like, you know what I mean?
Oh, stop
You know what
putting
I'm saying,
buttons
right? So it
there.
will. Yeah. So yeah, it will.
Back in the
I just don't
80s.
think. I don't know if it'd be smart enough on its own to know every single little slang type of language. So you might just put it in just to be, I don't know, make it easier, I guess.
If it doesn't know it, how are you going to recognize it to press the right button?
Well, fuck, I don't know. A computer's a little bit different than
And how
me.
many of these buttons are you going to have on the dash?
Well, I mean, it. I think it depends on how many languages it has programmed into it, right? So, like, if it's got 10 or 20 languages programmed into it, does it know the other 15 or whatever? Like, I mean, I don't know. You know what I mean? Like, I'm just
No,
saying.
fair enough. Fair enough.
I just think it would be easier just to be like, if you know where you're going and you know the people here are kind of like Mandarin, Japanese, whatever they are, Indian, Indonesian, I don't give a fuck. Tasmanian, I don't care. You say it and you know what I mean? And it kind of helps you out. It just, yeah, goes right to it. But isn't that a good idea?
Well, it's a good idea, but obviously there's no AI. This is just a
Now,
dumb car.
right. Now, in
Excuse
the
me.
future, they probably will just be like your car pull up and know every language of every person of everything. Of course. I'm with you there.
Hello, Robert. I see you've gained weight today.
No, it'll feel you gained weight. When you get in the car, it's going to know your weight. It's going to know you. It's going to know your iris. It's going to know your fingerprint. It's going to know your ass. Yes. No one else can drive your car and get in it if you got it on me. Put it on me only. It only drives with you in it. That's it. Ain't no stealing your car. That means when you get out of that motherfucker, when you walk up, your fingerprint can unlock it and do all the shit. No one else's can. Nobody can just open your car and get the fuck in like they can now just because you got it running. And no, it's got to be your
Cut your
weight.
finger off.
Well, it's got to be your weight. It's got to be your fingerprint, your iris. You can tell it which one. You can do it by one, or you can do it by all four. You know, super secure or just secure.
So it's dumb but smart. I like it.
Yes. Yeah, like if you don't want your seatbelt thing dinging all the fucking time, shut up, seatbelt. So shut the fuck up.
That's annoying, isn't it? But
Yes, you'll be able to tell it to shut up automatically. It'll shut it up.
see, I'd design a car system that told you, that yelled at your back, be like, no, put your fucking seatbelt on. Then I'd ding the fucking thing louder at you.
It might be in there.
Yeah. I thought it would be a good idea to have
I told you put your
navigator system voice that abuses you.
up. Your car starts speeding up. I told you put your seatbelt on, motherfucker.
Yeah.
You want to try me? You put your seatbelt on and it slows down. I will drive you to the police. Put your seatbelt on. What the fuck? Hold on a minute. Car be snitching on you and shit. You do a burglary, and on the APB, it's like all persons bulletin for this car. Your car drives you to the county building. What the fuck? They're looking for us.
No, that's bloody Judge Dredd.
Oh, I
Isn't
better
it?
shut up, huh? They're looking for us, Michael. Let's go to the county building. Let's get the fuck out of here. No. Unlock this door. Ooh. Only works by your voice. Voice recognition locks. Start and locks and stuff. Voice recognition. Yeah, it can have all that shit. Voice recognition, fingerprint, whatever you like. See, that's why you could sell different versions of it. Different colors, and you can have a disco ball in one. You can have one change colors in it. You can have one have waterbed seats in the fucking back. Man, I'm telling you. You got a car with waterbed seats in it? Hell no. Ooh, a fish tank in your car. That'd be badass. Well, a digital fish tank anyway. The ceiling would be a digital fish tank.
Still pay real money for the digital fish.
Ooh, the outside of your car can change colors. I mean, just switch like blue, white, green, like an LED. Your car will be an actual LED car. That'd be pretty neat.
No, the government wouldn't allow that. Not here in Australia. Because what colour was the getaway car? Oh, the getaway car was green. X.
Not anymore. That color change stuff is a good idea, though. Maybe do half and half, green and blue. Maybe do it one color. You can do it neon green. You can do it neon orange. You can do it neon purple. You can do it neon pink. You can do it neon something. Steering wheel would be warm. Your seat would be warm in the winter. If you had a winter. What else could you do with an electric car other than have it do like what you needed to do with your command? Like, what's the oil level? What's the spark plug? You know, I mean, check this. What's this? What's, you know, diagnostics, like a super diagnostics right on the fucking screen. You know what I mean? Pops up, tells you everything, shows you the car, the tire, everything. That'd be pretty cool too. It'll be able to record stuff for you. Like if other people say stuff, you know what I mean? Like if you pull up to a thing and they're like, hey, this, I need this. And you're like, all right, what'd they say? It'll tell you. Something. There's got to be something cool you can do with an electric car. Oh, and that fucking Baghdad battery. Iron, grape juice, a copper tube, an iron tube, the air in the center, a magnet, Baghdad battery. Copper magnet. We also had an electrolyte. Grape juice. It was hollow out. An iron chunk. The spiral. Fill that bitch with copper. And then fill that with a magnet. Until you fill the material. Spin that bitch. Put some helium and hydrogen in that motherfucker. Both of them. Add a little salt. Surrounded by a container of iron. It's also spinning. A piece of copper. A piece of magnet or aluminum or whatever you need. Magnetic current should turn the hydrogen into HHO. HHHO. 3 H's. Now you'd have to have helium. Add that in there. Pressing the fucking helium and hydrogen at the same time as you're electrifying them. It's gotta have an effect. I hear if you compress helium, it has a charge. So if you spin fucking helium, just spin the shit. You're automatically gonna compress it. Get it? They're not spinning water in that motherfucker. They're spinning helium. Victor Schauberger. Hydrium. Hydrogen. Hydrium. Hydrogen and helium mixed, fused together.
Why is everybody so quiet? I'm worried about that X flare on Sunday.